Hello everyone, welcome to the session. I think बहुत लोग excited है. The first topic is regular languages. आपको पता होगा, the regular language has more weightage than any other topic. Okay, even you study Turing machine, it will be weightage for 1 to 2 marks, hardly 3 marks. But last 3 to 5 years, we see 80 to 100% weightage only given to the first topic, and 1 or 2 marks for the context-free languages. That too, in last 5 years. Okay, शुरू करते हैं आज theory of computation regular language के साथ. Right. In case अगर आप टेलीग्राम चैनल में सब्सक्राइब नहीं हुआ, please scan the QR code and you can join Geeks for Geeks Gate channel or group. Let's begin the first question, but before that, if anybody is not aware, I have the group on Telegram, so you can also join my Telegram group by scanning the QR code here. And if you want to know about me, please you can have a look at each point. Okay, so we'll start the gate PYQs. Before that, let me know any queries before starting. Yeah, Hyderabad offline classes, yes, we are going to teach. It's true. If anybody aware of the offline classes are going to start soon, and you can visit the GFG website to know more about it. कितने class time होगा? Yes, शुरुआत में good question. Right, class के time is not decided because we should complete the most of the PYQs. That is the target. And ये हो सकता 5 घंटे, 10 घंटे, 12 घंटे, but we'll try to wind up in 6 to 12 hours in between. I'll give you 1 minute or 2 minutes time hardly, and then I'll start focusing on solution. I'm not going to respond any unnecessary queries except the doubt in this question. Okay, please read the question. You have the 5-state DFA which is given to you, and which is recent gate year question 2024. Okay. I'm sorry, I'm not able to take any unnecessary doubts here, but we will have the group. Okay, the question is given that you have the language which is subset of 0 plus 1 whole star, which is shown below, and the string is given belongs to 0 plus 1 whole star, and n0 of w, it represents the number of zeros in a w. W is a string here. Number of ones in a w can be represented as n1 of w. Which of the following statement is or false? So I'll be mentioning how to approach the gate question first. I'm not going to solve this kind of question. Many people do in different way. Now look at the question. Question has nothing to do except what is the language. Every language in the world is subset of 0 plus 1 whole star, no doubt about it, and n0 n1 notation is given, and the question is which of the following statements false. And when you read the options, the statements are distinguishable, 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 and there is another thing, any string with n0 equal to n1 in L of m. So he's talking about the property of L of m. Now, if you want to solve this question, you should know about the minimization concept. Remember that this question is depends on the minimization. Okay, I'll also write the concept which is required to solve it. And anybody not studied the minimization, definitely you will not answer this question, because some people think, sir, I will not study minimization, right? And if you don't study that, it's not easy to solve at all. The concept is minimization. Those who knows the minimum DFA of this machine, you can answer the first 3 options, and the last one that you can understand by looking at the language. Correct? Okay, do you know how to minimize this DFA? By using the partition algorithm or table approach. So what is the partition algorithm says? I'll write, minimization algorithm. If you are aware the partition algorithm, step 1, you keep all the non-finals in one side, that is 2, 3, 4, 5. You can keep one side. And all the finals in one side, that is only 1 is here. So now we don't need to worry about the singleton set because you cannot merge with anybody. Now the problem is you can merge 2 with 3 or 2 with 4 or 2 with 5 or 3 states also possible to merge. We'll see. Compare 2 and 3. Here also you can compare 2 on 0, it goes to 3, 3 on 0, it goes to 1. So 1 goes to 3, other goes to 1, but 1 is here, 3 is here. So 2 and 3 cannot be in the same set. So 2 and 3 will be separated. Now compare 2 and 4. When you compare 2 and 4, on 0 it goes to 3, on 0 it goes to 1. 3 and 1 definitely not in the same set. So 2 and 4 also separated. And 2 and 5. 2 and 5 when you compare, on 0 this goes to 3 and this goes to 1. So is it? Just check again. 2 on 0 goes to 3 and 5 on 0 goes to 4. 3 and 4 are non-finals. They are in the same set. And on 1, 2 on 1 goes to 1. 5 on 1 also goes to 1. So 2 and 5 we can keep together at this point. Now 3 and 4 are separated from this set because of the 2. You compare. ये दोनों को compare करना पड़ेगा. 3 and 4. So 3 and 4 compare करके on 0 it goes to 1. 4 on 0. So both are doing same. On 1, 3 on 1 goes to 2. 4 on 1 goes to 5. 2 and 5 are already together. So 3 and 4 also. Okay. 3 and 4. Then 1 is alone. Now step 3, you will compare 2 and 5, 3 and 4. So 2 and 5 when you compare, check it now. 2 and 5 on 0 goes to 3, on 0 goes to 4, 3 and 4 together. And 1, 2 on 1 goes to 1, 5 on 1 goes to 1. So now both are together. We are not able to separate. 3 and 4 also you can compare. In exam, just check it. I'm explaining, so it is taking time. 0 and 4 on 0 going to the same. On 1, 2 on 1, sorry. Which one? 3 and 4, right? 3 on 1 goes to 2, 4 on 1 goes to 5. 2 and 5 already together. So now if you look at it, it's exactly same as the previous step. यहाँ पर आपको distinguishable नहीं हो रहा है. तो अब समझ में आया 2 is equivalent to 5, 3 is equivalent to 4. We understood. Now these three options you can easily identify which is true, which is false. 2 and 4 are distinguishable. Yes, 2 and 5 are equivalent, but 2 and 4 distinguishable because they are not together. So this is the true statement. And state 3 and 4 are distinguishable. No, 3 and 4 are equivalent. So this statement is false. We have to choose the false statement. So we'll take this. 2 and 4, so 2 and 5 are distinguishable. Actually, they are equivalent. So this statement is false. False we have to pick. Any string W with n0 equal to n1 is always there in the language. We are not talking about what is language. We are talking about if any string that you have equal number of zeros and ones, is it there in the language? That means is it accepted by this machine? You can see that the number of zeros equal to number of ones. Who can be epsilon and 0 1 1 0, such strings, right? Epsilon accepted, 0 1 accepted, 1 0 accepted. And what are other strings that you can accept? Like 0 0 1 1, 0 1 0 1, 0 1 1 0, and so on. You can see 0 0 and 1 1, 0 1 0 1, 0 1 1 0. So always you are able to accept it, and this is also true. So we don't pick the true one. So somebody already answered B and C are correct. B and C are false statement. That's why we have to choose them. Okay. And here, what is common mistake that we do? And यहाँ पर बहुत लोग mistake कर सकता है. क्या है mistake? Actually question में पूछा है false. ये पूरा करने के बाद एग्जाम में because of fear, because of tension, आप सही तो आइडेंटिफाई किया, तो हम ट्रू टिक करने के लिए कोशिश करते हैं. क्यों? दिमाग में यही बढ़ता है which of the following is true, right? तो थोड़ा ये ध्यान रखना. तो you have to mark, are you going to choose false or true? So avoid that common mistakes everybody does. Okay, including me, this kind of mistakes happens if you lose the connection between the question and options, right? Yes, 000 can accept. We don't worry what finite automata accepts. The question is about any string W with, is not talking about what is language. Is talking about any string with equal number of zeros and ones is also in L of M. Getting my point? So one it's a belongs to, we are not talking about equal, belongs to L of M. Yes, true, right? L of M can be superset of this equal number of zeros and ones. To understand this statement, if the string has equal number of zeros and ones, it is there in L of M, but L of M need not be only this zeros and ones equal. So understand this statement. Okay, this statement is not what is L of M. It is about if the string has equal number of zeros and ones, definitely it is in L of M. But L of M can contain other strings. Example, 000. 000 is not having equal number of zeros and ones. That can be there in L of M. Correct? So this is what you need to understand. This is the first question. Every question will see what is the concept और concept के साथ साथ उनको कैसे solve करना है और what mistakes that we do. So 3 things we do. This is how you should practice the gate PYQs. है ना? और बहुत लोग को ये क्वेश्चन नहीं पता, सर मैं सॉल्व नहीं कर पा रहा हूं. प्रॉब्लम ये है, उनको ये कॉन्सेप्ट पता होना चाहिए मिनिमाइजेशन कैसे करते हैं हम. अगर मिनिमाइजेशन नहीं आता तो ये स्टेप आपको नहीं मिलेगा. अगर ये नहीं मिलेगा, ये आउट ऑफ द फर्स्ट 3 ऑप्शंस यू कैन नॉट चूज इट. एंड ये करने के बाद भी ऑप्शन डी में गलत कर सकते. क्यों? आप ये सोच रहा होगा व्हाट इज एल ऑफ एम. ये पूछा नहीं है व्हाट इज एल ऑफ एम. ये स्ट्रिंग बारे में बता रहा है. मेरे पास अगर कोई स्ट्रिंग है उसमें जीरोस एंड वंस इक्वल है, वो लैंग्वेज के अंदर है बता रहा है. राइट एवरीवन? डी इज द ट्रू. वी वांट अ फॉल्स स्टेटमेंट, राइट? Many people are saying yeah. अगर ये भी सही पॉइंट किया. ये नहीं पूछा L of M is equal to W such that W belongs to 0 plus 1 whole star number of zeros of W is equal to number of ones of W. ये तो नॉन रेगुलर है, इनके लिए तो DFA भी नहीं होता. तो ये प्रॉब्लम लैंग्वेज की बात नहीं है. जो स्ट्रिंग के अंदर इक्वल नंबर ऑफ जीरोस एंड वन से वो लैंग्वेज के अंदर है. राइट? बिलोंग्स टू कह रहा है, इक्वल टू नहीं बता रहा है. दिस इज नॉट द L of M. रिमेंबर दैट L of M इज नॉट इक्वल टू. वी आर नॉट आस्किंग अबाउट इट. ये तो नॉन रेगुलर है, ये तो फाइनाइट ऑटोमेटा है. इक्वल नंबर ऑफ जीरोस एंड वंस का मशीन ही नहीं है वो. बट दुनिया में कोई भी स्ट्रिंग इक्वल नंबर ऑफ जीरोस एंड वंस ले लेना, इसमें एक्सेप्ट होगा. बट इसके अलावा अदर स्ट्रिंग्स आल्सो एक्सेप्ट्स. तो अंडरस्टैंड द पॉइंट. Anybody is having weak in understanding in English, you cannot answer option D is true or false because you are assuming this is a false statement. Okay? And understand this point. It is one-way statement. What is the statement? One way. If W has equal number of zeros and ones, then he's saying that W belongs to L of M. That's it. Here you're looking at what is L. Take the W in the sigma star. If that has equal number of zeros and ones, it is accepted. But what it accepts, that need not be equal number of zeros and ones. Great. Okay. This is what you need to understand from the gate PYQs. बहुत लोग ऐसे उनको आंसर पता है B and C, but they don't know exactly why B and C. So that's what we are understood here. Go ahead. Next question. I will help you only the related doubt. If you ask any doubt which is unrelated, I am not here. Okay. Sorry that I am looking at a lot of questions, but I am not able to reply because you are asking unrelated to this slide. The minimum possible number of DFA, number of states. In a DFA that accepts the regular language is dash. I've seen 2 times in the gate similar to this question. And you need the concept how to construct minimum DFA. Remember that the construction of minimum DFA. Then you can answer this question very easily. And remember, go to every question after this video, look at how many concepts are repeated. If the construction of minimum DFA is repeated 20 times, then definitely it is important for you. Okay. Okay. How do you solve this? Now L is equal to W1, it's a 2 length, right? It is 2 length. W2 is minimum 3 length. So now 2 length you can represent with A plus B for A. W2 you can represent minimum 3 length. So A plus B power 3, A plus B whole star. This is a minimum 3 length, minimum exactly 2 length, and A already there. When you look at this data, now total string 2 length, 3 length, 6 length, right? But the third symbol from begin is A, not just third symbol, and also total string length 2, 3, 3, 6 length. Minimum string length is 6. Now how many states required? If the minimum string length is 6, you need 7 states and 1 trapped, so you will get 8. So without designing also you can understand, but if you want to design you can go ahead. 1 length, second length, third is restricted to A. If it is not A, you should go to trap. And 4th, 5th, 6th is anything, but minimum 3 length should be guaranteed after that third symbol A. And then after that any sequence is fine. Now you can count the number of states. To understand 6th length you need 7 state, and the third position must be A. If not A, you need a trap state. So total you require 8 states. Correct? What mistake we may do here? You might be forgetting sometimes the trap state. So you might be answering 7, but anyhow 7 is not there. So you are lucky. Sorry. Go ahead. It is really 5 times asked in the gate so far. The concept is you should aware of NFA to minimum DFA conversion. Of course, it also involves NFA to DFA. But the concept is, how will you get a minimum DFA when I give you NFA? How will you get minimum DFA? Minimum DFA को कैसे construct करना है if I give you NFA? Right. ये तो बहुत straight forward question था. कितने टाइम लगता है ये 2018 और recent भी ये question पूछा गया. यहाँ पर n states दिया है. n be NFA with n states and k be the number of states in a minimal DFA. What is the relationship between k and n? Right. So n, when you construct minimum DFA, you will get the at most 2 power n. Right. How do you get at most 2 power n? When you convert to DFA, you can always design a DFA, right, with 2 power n states. Always we can design. And when you convert this DFA to minimum DFA, it will take less than or equal to 2 power n. So k answer should be less than or equal to 2 power n. Great. Understand the concept, and sometimes they might give you different variables, and you should know how to relate them. Okay, please read the question. यहाँ पर the question दिया है, concept is easy for you when you know recursive functions like recursive equations. It's given like recursive algorithm. It includes discrete mathematics concept, algorithmic concept, but ask the question in the TOC, right? Just like a discrete maths question, but asked with the languages. If anybody observes, it actually looks like a discrete mathematics question, you know, along with algorithms. Only the language is from TOC, but everything is from algorithms and discrete maths concept. And where is the machine? Just wait. The machine is gone somewhere. Okay, I'll write. How do you get the 2? Have you seen the people who are answering without giving the finite automata? Because they are blindly answering without knowing the concept. This is another way to prove what are you doing in the gate practice. That means they are not reading the data. They are only knowing the answer for this question. And you should never do that. First read the question and is it given everything or not? Concept is given, you should know what is the recursive algorithms. Recursive algorithms always have two things. If you are defining f of n, you will have base condition and recursion. Everybody knows? If you don't have the base, recursion will never stop. And you can see this looks like L0 is the base and Li depends on Li. Oh, it's so many mistakes are there, I guess, here. I don't know how you are able to solve this. Are you able to solve this? L power 0 is equal to epsilon and L power I is equal to L power I minus 1 dot L. This is what, right? For all I greater than 0. That L is typed below. So just have converted this exactly how it need to be. Read the data carefully and answer it. Now everything is properly given, whole data. Now you can solve it. Sometimes the data might be incorrect. You should know how to identify it, because you are not reading the question, you are only answering it, will not happen in the exam. Okay, you don't know the answer, right? How will you answer 2 or 3? This was gate PYQ, everybody knows it is 2. Even though you know the 2, but you should read the data. If any changes happen, you should know how to derive it. Okay, let's solve. So many times we have solved it, but still we are doing it again. Okay, anyone? What is the first approach? Know what is given. What is given? L power 0 is epsilon. L power 1 depends on, you can see L power 0 dot L. That is epsilon dot L is L. L power 2 if you want to calculate, L power 1 dot 2 minus 1 dot L, which is obviously L square, you will do it. L power 3 is equal to L power 2 dot L and so on. L power 4 is equal to L power 3 dot L. But the question here, the order of a language is defined as smallest k such that L power k is equal to L power k plus 1. So now the idea is very simple. You need to find smallest k, where L power k is equal to L power k plus 1. So now if I say L power 0, if k is equal to 0, it means you will get L power 0 is equal to L power 1. If k is equal to 1, what happens is L power 0 not equal to L power 1, but L power 1 is equal to L power 2. This should happen. But it should happen L power 1 is equal to L power 2. Similarly, if k is 2, that means k is not a 0, k is not a 1. So k is 2 means L power 2 is equal to L power 3. So you need to find what is the smallest k such that L power k is equal to L power k plus 1 will happen. So you are going to solve this way, right? If anybody answer k is equal to, that implies L power 0 equal to L power 1 will fail, L power 1 is equal to L power 2 will fail, but L power 2 is equal to L power 3 will succeed. Done? Okay, it's 0. So now first, what is this L1? L1 means L only you can assume. What is L? Epsilon, or it's 0 and odd number of zeros, right? 0 followed by 00 whole star. That's it. This is L, or the language accepted by the machine. Now start with the power 0. Definitely you know L power 0. L1, L both are same. L power 0 is epsilon. You can assume it is a 1. And L power 1 you are calculating using the L power 0 dot L. L power 0 already you know it. Epsilon dot, what is L? Epsilon plus 0 followed by 00 whole star, which is same as L only. L power 2 is equal to L power 1 dot L. Both are L only, right? L power 1 is also L, L is. So this is repeated. Whole star, it's the first time, and second time also same. And what do you get? यहाँ पर आपको only epsilon चाहिए, आपको epsilon epsilon, only 0 चाहिए epsilon 0, 00 चाहिए 10 10. So you will get everything from here. So that is 0 star. If you practice regular expressions, you will know that this will generate every string over the zeros. Now you look at, when you compare this to L power 0 not equal to L power 1, when you compare this to L power 1 not equal to L power 2, because this is different from 0 star. When you go for L power 3, L power 2 dot L, L power 2 is 0 star, L is epsilon plus 0 followed by 00 whole star. And if you try to derive 0 star epsilon, it will give you every string over the 0, correct? And these two are exactly same, right? L power 2, L power 3. L power 2 is equal to L power 2 plus 1, that is L power 3. That's why k is equal to 2. Minimum k value we computed, here it was failing, that's why we came to the L power 2. That's why order of L is equal to, is equal to k, that is 2. That's why many people have answered 2 only, even though data was incorrect. And many people still they were trying the question number 1. Even though I told you were not able to understand the option D, please understand this option D. Option D only talks about W, not language. Only talks about W, not about the language. If the W has equal number of zeros and ones, that is there in L of M. L of M may contain additional strings. Look at is in. We are not talking about what is L of M. So understand, please. Many are doing mistakes still. They're not able to come out of the meaning. Okay. Go to the next one. If L is a regular language over the sigma, which one of the following languages is not regular? In 2019, okay. What is the concept behind it? Suffix, prefix, and it is concatenation along with the reversal, and this is something else, right? The concept behind this question is closure properties. Those who study closure properties, easy to understand this question. Closure property is nothing but operations, like various operations you might be studied: union, intersection, complement, difference, subset, prefix, suffix, right? Concatenation. Okay, don't look at the spammers. As you know, there are a lot of people are there, so don't worry about it. If I say whatever you are answering now, you might be wrong. Many people are saying B. Is that B correct? B, can you guarantee not regular always? Is it always not regular? Okay, anyhow, you know suffix property. So suffix is always regular. Suffix of a regular is regular, right? It is true. So you can say regular. Prefix of regular is also regular. So you can say regular. The definition only, right? And concatenation, reversal of a regular is regular. Yeah. I hope it's fine now. The streaming issue is happening. It's okay. My question is, you're answering B. Is the question which of the following languages may not regular or is not regular? Both are different, right? Did they ask may or is? If they ask is, that means definitely it should be not regular. Can you guarantee it is always not regular? Okay, let's give you one counter example. Over the AB, I'll just take one example. Suppose L is equal to A star. A star is also a language over A comma B, right? Now if you do W power R, W belongs to A star, this become like W power R, such that W belongs to L. L means A star. Now you know this is equal to AA whole star. It's regular, right? Now can you guarantee this is not regular? They did not mention which language they are talking about, right? L is the regular, that's it. Which regular they did not mention. And if you are choosing this, you are assuming it is always not regular. The question is about which one of them is not regular. So this is, you cannot guarantee not regular. Here there is no option, and B is only sometimes not regular, not all the times. Okay, there is no option which is correct, because this cannot be always not regular, sometimes only not regular. They did not say sometimes, they said is not regular. It's a sometimes not regular, but also sometimes you see there is a regular. Okay. That's what, you know, not all the gate questions are correct. Some of the gate questions could be having wrong options, and people, you know, misassuming, you know, the concept they are not able to apply because of they misunderstood the data and the options. And the question, when they ask W power R such that W belongs to A plus B whole star, definitely it is not regular, no doubt about it. But they did not ask belongs to A plus B whole star, they asked belongs to L. L is regular, but which regular they did not mention. Okay, this is always not regular, but here W power R, W belongs to L, where L is regular mentioned. Which regular? We are not aware. Is either regular or not regular, depends on L. This is the right answer. Look at the note. The 2 points you should understand. यहाँ पर दो क्वेश्चंस में इतना ही डिफरेंस है. W belongs to A plus B whole star, W belongs to L, where L is regular and that regular is over A comma B. Yeah, if the question is having the wrong data, after the exam you can challenge it. Like this is a wrong question because there is no option, so everybody will get full marks. In case if you don't challenge and even they are also choosing the B, then those who have chosen the B, they will get the marks, remaining will get negative marks if it is MCQ, right? Keep that in mind. After releasing the response sheet, you must look at each and every question properly, and in case if you have a doubt, you can interact with concerned faculty and discuss each and every option. Done? Again, this question has the common mistake that we are not able to understand this option, so we are going to the option B rather than understanding this B is also wrong. Okay, is another very interesting data where even GATE has the wrong data in the question that we are not able to analyze because we miss. And even when IIT professors are doing these mistakes, obviously we can also do the same mistakes if you don't observe it. है ना? This question concept depends on pumping lemma. You should know what is pumping lemma, proof and concept, so that you can easily answer this question. Hardly will see 1 or 2 types of questions in pumping lemma. इसमें बहुत easy है solve करना है. सिर्फ pumping lemma आपको 15-20 मिनट लगता होगा समझने के लिए, but 1 or 2 marks sometimes it will carry. Like 2 mark question is asked from pumping lemma in 2019. Look at the trick. Without even solving also I can do it. MCQ. If it is MCQ, it's very easy to answer. Which one of the following can be pumping length? See, if it is MCQ, among them only one should be correct, right? Suppose assume that 3 is correct. If 3 is correct, 5, 9, 24, all of them will be correct. So 3 can't be chosen. Suppose 5 if you choose, and if the 5 is there, 9 also correct, 24 also correct, because greater than or equal 5 everybody is pumping length. If you choose 9, 9 and 24 both are correct. But it is MCQ, without analyzing also you can pick the 24, right? It's one of the shortcut in the pumping lemma. But if it is MSQ, then this is not the shortcut you should apply. And which one of the following, if they ask cannot be, choose the smallest answer. Which of the following can be, choose the maximum answer, because many answers are there, many pumping lengths are there. That is the reason, and you should be carefully choosing the options. MCQ questions are easy to answer, but MSQ questions you need to apply the concept. Trick will not work. Trick will not work. Okay. Where do you apply the concept? When it is MSQ. And you need to apply the concept, just apply the trick in MCQ. Right? If they ask which of the following can be, out of this 4 only one is the right, that is the largest answer. If it is which of the following cannot be, then choose the smallest one. That's how you can quickly answer for MCQs. Okay, because MCQ they will give you the only one option is right. MSQ only there is a possibility like they will give lot of options. Now let's go to the actual data. What is it? Now L is regular, which is given as B power, yeah, both are there, A power 2 plus 3k union B power 10 plus 12k, where k is greater than or equal to 0, right? You can also write this as triple A whole star double A, that you can write before or after, union B power 12 whole star followed by P power 10. Now when you design the finite automata, which finite automata you have to design? You can go to minimum NFA, you can go to minimum DFA to analyze. Alright, if you want to find the pumping length, you can go to either minimum NFA or minimum DFA, both will give the right answer. The best way is minimum NFA is the best way to apply. When minimum NFA can give you pumping length and minimum DFA always can give you, because its answer is either greater than or equal to minimum NFA number of states, correct? So this is also going to satisfy. And if you design NFA for this, how do you design? Minimum string is here, so right, double A, and then you should not come here, because if you come here you will go to B side also. The next is you need, after triple A you should come back. If you go here, then there is a chance of going for the base. So take 1A, a non-final, and take the help of this state. Now every 3 A's you can come back to the final. Every 3 A's you can come back to the final. And this side 10 B's you have. 1B. 10B is a minimum string, right? 2, 3. Concept always takes time. Trick will be in seconds. 5, 6, 7, 8, 9, and then 10 base. After 12 base you should come back to final, right? Here already 10 base are there, and don't take the help of this B, and here 9 b's are there. You need 3 more b's to take the help. So 1B, second B, and third B, and then you can take the help of this state for fourth B. 4 plus 9, 13, right? I'm sorry. Yeah. This third B you can take the help of. The remaining 9 B's are here, so you can come back to final. And now you look at the cycle, you can take this side or this side, this side or this side. To understand, if you take any string, which is in the language, and the cycle length, you can go this side or this side. So you can pick, because these are union, right? If either you go this side or this side. If you want a cycle 1, 2, 3, 4, 5, so 5 length is going to be here, minimum. At this side, minimum 5 length. And here if you want a cycle, look at that, here it is 10, 11, 12, 13, and we'll make a cycle, right? 14, 15, 16, 17, 18, 19, 20, 21, 22. 22 length will be in the language, 22 length. So now if I say that 5 here minimum string is 2 length to accept, here minimum string is 10 length, and if you pick maximum, take the 10, greater than 10, you pick any string which is in the language, definitely will form a cycle. But it's a very hard concept. You know, many people teach like the number of states, find the minimum DFA, and beyond that it's always you can choose a pumping length. That's true. But here in this motion, if I pick any string which is in the language beyond 10, always create a cycle, and then the pumping length will guarantee. You can choose the pumping length greater than 10. That always proves the regular language why it is. Okay. So understand, this concept is not easy, but still I am trying to explain you. The answer is the minimum pumping length greater than 10. You can choose any value. You can prove it is regular. So here pumping length can be greater than or equal to 11, you can choose to prove every string which is greater than or equal 11 length will have a cycle so that you can pump somewhere in the machine. So your answer is 24. So that's why you see that trick 9 is given, but here anywhere 10 is not given or 11 is not given, and they chosen the 24. Okay. Anyhow, and don't worry about all this because concept always takes time, as I said. And whoever learned the pumping lemma, and उनके लिए तो ये बहुत easy है. But ये जो concept जो अभी बताया, तो वो normally हम पढ़ते नहीं है pumping length prove करने के लिए, क्यों normally हम choose करते minimum DFA, कुछ लोग कुछ choose करते minimum NFA, and actually you can also choose the pumping length. Also depends on how you design the machine. Okay, but this always proves. Fine. So if you use the concept, it just takes 5 seconds. This shortcut trick. You can apply the trick. What is the trick? If they ask which one of the following can, then choose the largest answer. Cannot be pumping length, choose smallest answer. Because MCQ, definitely only one will be right. Okay. The actual concept says pick any pumping length greater than or equal 11. You can always prove given language is regular. This is actual concept says. Okay. You understood? What is the mistake that we do? Rather than understanding the trick, we may apply, this kind of machine, because people say that design a minimum DFA. Then while designing a DFA, you will take a lot of time. So instead of solving in 1 minute or 2 minutes, you will take 5 to 10 minutes. So it's again, cost factor in actual GATE exam. Maybe I have avoided in the crash course because it takes time. Have you seen, right? To solve the one problem, it is taking more time. To teach the pumping lemma concept takes more time, so I avoided. As you see, only 3 questions are there in GATE exam in 30 years. So that's why I have ignored in crash course. अब चलते. Again, the concept is the closure property. If you have studied the closure property, this question you can solve it. Closure properties for regular languages. One more question है, फिर भी it's not that easy. ये 2 मार्क क्वेश्चन में भी पूछ सकता सेम कॉन्सेप्ट के लिए. The first one is here. This is the first one, and it is the second one. Second is very easy. The class of regular languages is closed under infinite union. Is true or false? False. Infinite union, infinite intersection, infinite followed by any property is not closed for regular languages. The first one, if L1 union L2 is regular, both L1 and L2 must be regular. Anyone? Analyze the first one. If L1 union L2 is regular, then is it compulsory L1 is regular and L2 is regular? Is this always true? Need not be, right? I can prove even L1 not regular, even L2 not regular also I can prove. Union of 2 languages regular doesn't mean that these 2 are regulars. You can see if I put L1 is A plus B whole star, L2 I can pick even non-regular like A power n, B power n. When I do the union, still I get regular only now, because A plus B whole star will come out. Then is it guaranteed L1, L2 are regular? No, right? If this statement is given here, L1 union L2 is regular, then L1, L2 must be regular, is the wrong statement. False. Because of must. If they say may, then definitely it is true. Just one word can change the answer, right? यहाँ पर अगर may दिया, L1, L2 may be regular, yes, sometimes possible, right? Then that statement will be true. So because of that must, this statement is false. Even L1, L2 are regular, if they say, it is also false. Neither 1 nor 2, because both are false. Again, what is the common mistake we do here? Mostly we apply like this. L1 is regular, L2 is regular. It's a closure property. And L1 union L2 is always regular. We know this point, and this point is a different order, converse order of this. Here these two are regular, it is definitely regular. But when union of two languages is regular, and those two languages may or may not be regular. Okay, so we know this closure property, and if you are applying here, then you will get the wrong answer. Note, this is a different statement. One of the popular kind of gate question, right? Regular expressions. Go ahead. We have three topics. One, regular languages. Second, DCFLs and CFLs. Third, Turing machine and undecidability. After every topic, I'll give you 10 minutes break. Then we will start freshly with the new topic. Again, answer is not important. Analyze the given question along with the options. If I do any mistyping here, then you should know that that is wrong. Don't just blindly assume it is a gate. Of course, even though I say gate, the typist might do some mistake. You should know which is right, which is wrong. What is the key? Odd number of ones. And how many of you have practiced odd number of ones? If you practice the odd number of ones, choosing the options would be so easy for you. Okay. And some of the gate questions, it's the MCQ, right? When it is the MCQ, always choose elimination technique, because that will work most of the times. Elimination of options. And यहाँ पर आप बताओगे यार elimination क्या है basically? TOC में ये तो popular technique है, और TOC में 50% of the questions के लिए elimination option चलता है, because easy to eliminate rather than writing it, you know, right? Or you know, you can't understand when you look at it, but if you want to eliminate, look at my approach. Most of the times it works. Look at the sigma star. You have a lot of strings, right? Epsilon, binary, right? 0 1 00 0 1 1 0 1 1. Just you need to understand what are the strings are there in the question, and the same strings are they coming from the options. If any of the option is doing different, eliminate it. So always we go in this direction, like epsilon, do you want or not? Read the question carefully. Odd number of ones, so this should not be there. Odd number of ones, yes. Odd number of ones, yes. Odd number of ones, even number of ones, we don't. You should know which is having odd number of ones, which is having even number of ones. Of course, even number of ones we don't need. Now look at this. Can it generate epsilon? Okay, we don't want. Look at that. 1. Can it generate 1? Yes. And can it generate 0 1? That will fail. Are you able to eliminate the option very quickly? Because when you look at this, it is doing definitely odd number of ones only, but we want all odd number of ones. We want every string in the sigma star who is having odd number of ones. हम ये नहीं करते. Expression जो odd number of दे रहा है, उनको हम टिक करते. ऐसा नहीं करना है. It should generate all odd number of ones. This all word is very important. If it is doing only some, don't choose it, because we need every string which is having odd number of ones. यहाँ पर problem क्या है? ये जो भी कर रहा है वो odd number of ones है, but it can't do every odd number. Example 0 1. 0 1 is having only 1 1, that is odd number of ones, but not able to generate because starting with 1. And ये जो है 0 plus 1 star, ये कभी काउंट नहीं करेगा odd number of ones. अगर कोई भी एक्सप्रेशन में 0 plus 1 whole star आ रहा है, because you are not tracking the ones, because 1 or 0 is okay for you. This will create even some of the even number of ones. You can try it. single one you want, you have it, right? But is it doing everything exactly what we want to check it? 1 0 0 1 0 1, can I do it? Impossible. See, 0 1 I'm not able to generate. Here 1 I can generate. From here I want a 0, but 1 always comes. So 0 1 I'm not able to generate. Here also not able to generate. And here same problem, 0 1, are you able to understand? The single one you are able to generate, but 0 1. And one string is eliminating all the three options. And this one, what is that? 1 0, not able to generate. Which option is right? C, is it right? C, is it right? This, all of them are again wrong. This is another version. It is proving that we are not able to understand the concepts properly. We are not able to analyze properly. Everyone, it is a gate question, but no option is correct. All are wrong. Okay. And even crash course also helped how to understand which 0 stars must, correct? See, I am saying, can you generate 0 1, man? 0 1. 0 1 is odd number of ones, and this is not able to generate 0 1. If I add here or here 0 star, this will become valid. Or if I add 0 star here, this will create valid. Here, what has happened? Out of this 2 0 stars, you have the 1. Out of this 2 0 stars, you have both. Out of this 2 0 stars, one of them is there. But from here to here, one of the 0 star must be there. Both the 0 stars are missing. That's why before 1 0, you are not able to generate. This is missing. And if one of the 0 star you keep here or here, then it will work equally. So that's what you need, the concept. You can't blindly answer C is correct, B is correct. Yes, skip करने में भी mark मिलेगा, but you should challenge it. अगर आपको भी नहीं पता ये सही है गलत है. Done? You got the point, right? There is no correct option here. अगर आप किसी PYQ solution में C बताया, कुछ और बता रहा है, please ignore it because they are also not analyzed. I'm not saying they are wrong because many of the gate PYQ solutions are not analyzed properly. They just copy from here and there. That's why you see the wrong answers, wrong solutions. Okay. And this PYQ series especially will help you what you have done in your practice. अगर आप PYQ practice में सही किया है, ये question अभी जो भी बताया, आपको अप्रोच भी समझ में आया होगा और टेक्निक भी, एलिमिनेशन ऑफ द ऑप्शंस टेक्निक भी समझ में आया होगा. सारे ऑप्शंस एलिमिनेट ही हो गया, राइट? रेगुलर क्लासेस में बहुत सारे रेगुलर एक्सप्रेशंस लिखा है, बट यहाँ पर लिखने के लिए समय नहीं था तो मैं नहीं लिख पा रहा हूँ, बट कॉन्सेप्ट तो बताया. इट इज वन ऑफ द इंपॉर्टेंट कॉन्सेप्ट फॉर द एग्जाम. Right. Number of a's in x is divisible by 2 and not divisible by 3, but not divisible by 3. And many people will do LCM of 2 comma 3, 2 multiply with 3. All will work, right? 6 is the right answer. Okay, you can correct Rohit now because you know the concept, right? Doesn't matter who thought what, correct? You should know the concept. if I am teaching wrong, then you should know that I am teaching wrong. This is what because every minute you should keep the control of your thoughts. अगर आपकी thoughts controlled है तो आपकी solution भी सही रहेगा. कभी कभी यार मैं 2 × 3 पे 2 + 3 लिखता हूं, तो अगर आप कंट्रोल नहीं कर पाया तो यही कॉमन मिस्टेक्स होता है. Trick, yeah, is 2 × 3 6, and you may do LCM of 2, 3, still it works. But understand here 2 × 3 is equal 6. I will not apply. The reason is, अगर यहाँ but not की जगह कुछ और होता और 3 की जगह कुछ और होता, then you can't multiply or can't apply LCM concept. तो यही ट्रिक है. फ्यूचर गेट एग्जाम में अगर कुछ दिया है तो ये क्वेश्चन होता है, याद रखना L is equal to X belongs to A plus B whole star, such that number of A's in X is divisible by 2 or divisible by 4. अगर यही क्वेश्चन थोड़ा मॉडिफाई करके आया, प्लीज डोंट आंसर 2 × 4 or LCM what 2 × 4, don't answer it. Here it matches with LCM concept. LCM also may not match. Let's check. Divisible by 2 means what are the remainders? 0, 2, 4, 6, 8 and so on. Divisible by 4 means 0, 4, 6 A's, sorry, 8 A's, 12 A's, 16 A's and so on. And when you do the union, this is going to dominate, right? It's same as divisible by 2 only. When you do the union, you will get divisible by 2 dominated. So answer is going to be the 2 states only in a minimum DFA. Right? GCD apply हो सकता है इधर. And दिया इधर, then this will dominate. Are you able to get this point? For OR 2 states, for AND 4 states, for but not it is going to be a different one. That you can try as homework. बट नॉट अगर लगाया, मैं तो 2 के लिए बता रहा हूं, आर के लिए 2 स्टेट्स, एंड के लिए 4 स्टेट्स, बट नॉट यू कैन ट्राई इज इट 2 × 4 और नॉट. So now this question is simple. 2 × 3 will be 6, and if you want to design this DFA, trick is just you get answer 6 easily. Now concept is you need to understand the problem. What is the concept? L के अंदर number of A's divisible by 2 होना चाहिए but not divisible by 3 होना चाहिए. तो सबसे पहले ये समझना divisible by 2 क्या होता है, divisible by 3 क्या होता है. Divisible by 2, divisible by 3. Everything is about A only, right? So 0A, 2A, 4A, 6A. You can write A power also if you want. 10, 12 and so on. And we should not be divisible by 3, right? But you want to say not divisible by 3. जो divisible by 3 होता, ये divisible by 3, divisible by 3, divisible by 3. तो आंसर आपको 2 होगा, 4 होगा, 8 होगा, 10 होगा. ये होता है लैंग्वेज में. A power 2, A power 4, A power 8, A power 10. ये तो divisible by 2 होगा but should not divisible by 3 होगा. तो अगर आप इनको समझ लिया, A power 2, A power 4. सबसे पहले A power 2 देखो डिस्टेंस मेंटेन करेगा, 2 मेंटेन करता रहेगा, एंड A power 12 नहीं रहेगा, A power 14 एंड A power 16, A power 18 नहीं रहेगा. तो यहाँ पर आफ्टर एवरी 2 एक मिस हो रहा है. 2 4 के बाद 6, 8 10 के बाद 12, 14 16 के बाद 18. तो ये एक स्ट्रिंग मिस होगा. तो इसके अंदर एवरी 2 स्ट्रिंग्स के बाद, तो ये 2 स्ट्रिंग्स को समझना इंपॉर्टेंट है. तो 0A's, 1A, 2A's तो एक्सेप्ट करना होगा, और आपको साइकिल कहाँ मेंटेन करना वो इंपॉर्टेंट है, राइट. और यार इसके बीच में डिस्टेंस 2 है, इसके बीच में डिस्टेंस 4 है, ये भी याद रखना, इसके बीच में डिस्टेंस 2 है, इसके बीच में डिस्टेंस 4 है, ये 4 आपको पता होना चाहिए. एंड 1a 4a is accepted, and after that 4 more a's you should accept. Which 4? If I put 1a here, 5th a, 6th a here, 7 8 9 10 accept होगा, 11 12 13 14 accept होगा, 15 16. तो ये है 1 2 3 4 5 6 एंड 6 स्टेट्स. ये है क्वेश्चन. और ये कॉमन मिस्टेक्स है, लोग करते हैं नॉर्मली. नंबर ऑफ एस इज डिविजिबल बाय 2 और नंबर ऑफ बीस इज डिविजिबल बाय 4. ये जो प्रॉब्लम है डेफिनेटली 2 into 4, बट ये ध्यान नहीं देते हैं. ये तो सिग्मा इज इक्वल टू ए कामा बी है, और मैं तो सिग्मा इज इक्वल टू ए के लिए बता रहा हूं. तो नंबर ऑफ एस इज डिविजिबल बाय 2 और नंबर ऑफ एस, दोनों में कितना डिफरेंस है यार, एक ही कैरेक्टर चेंज किया, राइट. इधर बी है इधर ये है, बट आंसर यहां पर 2 स्टेट्स होगा. ये डिफरेंस पता होना चाहिए आपको. लैंग्वेज के अंदर एवरी स्ट्रिंग इस कंडीशंस को सेटिस्फाई कर रहा है. देन ओवर ए कॉमा बी 8 स्टेट्स, ओवर ओनली एस इट विल बी 2 स्टेट्स. Do homework. Divisible by 2 but not divisible by 4. Do homework similar to this, right? तो यहां पर ये लगा देते, x belongs to a star. b के लिए तो डेड स्टेट चाहिए होता ना, x belongs to a star रखा है. अगर b भी है तो b के लिए एक्स्ट्रा स्टेट होगा 3 स्टेट्स, क्यों एक डेड स्टेट आएगा. एवरी स्टेट से b के लिए डेड स्टेट जाना होगा, ट्रैप स्टेट. तो यहाँ प्लीज पुट a star and write 2 स्टेट्स. अगर यहां पर a प्लस बी होल स्टार होता है, क्वेश्चन में सिर्फ एस की कंडीशन है, और बीस ओवर. यहां पर 2 टाइप की क्वेश्चंस. अगेन कैसे बताऊं मैं 2 टाइप की. यहां पर x बिलोंग्स टू a प्लस बी होल स्टार है, बीस कुड बी एनी. अगर यहां पर x बिलोंग्स टू a स्टार बट सिग्मा इज a कामा b, बीस विल गिव ए ट्रैप स्टेट. सो लेट मी फ्रेम द क्वेश्चंस अगेन. इट ऑल डिपेंड्स ऑन व्हाट यू राइट. x belongs to a plus b whole star where number of a's in x is divisible by 2 or divisible by 4. अब यहां पर 20 कितने भी हो सकता है, राइट. सो सेल्फ लूप फॉर द b इट्स गोइंग टू बी 2 स्टेट्स ओनली. बट यही क्वेश्चन सिमिलरली आई राइट x such that x belongs to a star where sigma is equal to a comma b, where question is same, condition is same, is divisible by 2 or divisible by 4. लैंग्वेज तो ओवर सिग्मा ए कामा बी है, तो बी के लिए ट्रैप स्टेट चाहिए होता, इनके लिए 3 स्टेट्स चाहिए होता. बी के लिए इधर सेल्फ लूप लगाओगे, इधर ट्रैप स्टेट. इधर बी नहीं चाहिए कभी भी लैंग्वेज के अंदर, इधर 20 चलेगा. क्यों? कंडीशन ओवर द एस 20 कुड बी एनी. काफी डिफरेंस होता है ये दोनों प्रॉब्लम्स में. क्यों? आपकी x क्या है, आपकी सिग्मा क्या है. इधर सिग्मा भी a है तो b बारे में कोई कंडीशन ही नहीं है. इधर सिग्मा क्लियरली मेंशन किया a कामा b, तो b के लिए ट्रैप स्टेट दिखाना होता, तो नंबर ऑफ स्टेट्स 3 होता. ठीक है, बहुत सारे क्वेश्चंस कवर किया इसके अंदर. एक बार रिवाइज करना इसके अंदर क्या क्वेश्चंस पूछा है. ये क्वेश्चन बहुत इजी लग रहा है, क्यों? बहुत लोग ट्रिक बता रहे हैं 2 into 3. यार 2 into 3 कॉन्सेप्ट के साथ बताना होता. यहां पर अगर 2 into 3 सेम मिस्टेक किया, लाइक 2 into 4 सेम मिस्टेक किया, तो आपके आंसर 8 आएगा, बट 8 तो नहीं है इसके लिए. तो ये मिस्टेक्स होता है. या इस टाइप की क्वेश्चन देख के हम इस टाइप की क्वेश्चन में सेम कॉन्सेप्ट सेम ट्रिक अप्लाई करते हैं, तो हमारा आंसर गलत होता है. तो ये डिफरेंस पता होना चाहिए व्हेनेवर यू एनालाइज द क्वेश्चंस. ठीक. See, some people are asking, it's easy to analyze. See, number of A's is divisible by 2 but not divisible by 4. See, divisible by 2 means 0, 2, 4, 6, 8, 10, 12, 14, 16, 18 and so on, right? Not divisible by 4, you should apply here. What happens? This should not be there. 4 multiples. Then what will be the result from here to here? You are looking for 2 A's, 6 A's, 10 A's, 14 A's, 18 A's and so on. So you need to observe the distance. Here the distance is 4. 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 And you can see that first you should accept the 2 A's. After that, every 4 A's you will accept. And you can, 1 A you can take the help of the state, and other you can go to initial state to 4 A's, and this will be the machine. So understand the concept. वहां पर आपको clearly पता होगा distance क्या होता है. यही बोलते हैं ना, over one symbol you need arithmetic progression. AP series, ये तो clearly बोलते हैं identifying languages में. अगर over one symbol है और उसके साथ arithmetic progression series form हुआ है, तो definitely it is going to be रेगुलर लैंग्वेज. गॉट इट. 4 सही है आंसर इनके लिए. यही 4 स्टेट्स है, बट कैसे बनाया? आपको सीरीज ऑब्जर्व करके बनाया हम. टेक 1 minute टाइम और 2 minutes टाइम. And concept is आपकी फाइनाइट ऑटोमेटा जो है रेगुलर एक्सप्रेशन में कैसे कन्वर्ट करना है. ट्रिक इज डोंट यूज एनी एल्गोरिथम. अगर एल्गोरिथम यूज किया यू विल वेस्ट योर टाइम. ऑब्जर्व द पैटर्न्स. Can use elimination of the states. That's easy technique. जो टेक्स्ट बुक में यहाँ पर algorithms होता है कन्वर्ट करने के लिए, अगर वो algorithm यूज किया like using cleaning method or Arden's lemma or any other technique, then that answer may not be there here. बहुत टाइम वेस्ट करेगा. और okay, first trick is, because is it MCQ, always look at when it is MCQ, elimination technique may work, and you can spend 1 minute of time because you really don't know which technique is better, and 1 minute you can, half minute or 1 minute you can give for this. If it is elimination technique you are applying, you can clearly observe what are the strings are valid here, like C, epsilon, A, B, A. Few strings you observe. Don't write like this. In exam, write directly what are accepted. Here epsilon not accepted, right? A accepted, B accepted, AA no, AB accepted, BA. So no need to write all of this in exam. BB no, and you know these points, right? The same should observe from the options. Epsilon not done by anyone. If anybody does, eliminate them. Right? Nobody is doing, so everybody doing for epsilon correctly. A, anybody? See here you are getting A, but we want A, right? Here are you getting A? No. So you can eliminate this option. Are you getting A here? From here? But see, here AB is their minimum, here BA is their minimum, and AB or BA is the minimum but not A. So A you are not able to get here, so you can eliminate. And here you can put epsilon here minimum, and you can get A from here, correct? So out of this two sorry, out of this two, you can look at the different string. Now see, left, you have left only two options, right? Then again, when you have left two options in MCQ, and just look at the difference, don't look at anything else, look at the difference, one does, other will not. Which one could be that string? You can cross check what is the difference between them. You can go with length directly if you want. Two length, everybody is same or not? One length, everybody. B, are you able to get? Here you are able to get. B, are you able to get? Here, yes. And two length, AB. AB you can get here. And here also AB you can get here. And BA you can get here, you can get here. And double B, you can't get in both of them, right? Now it looks like fine. Now you can look at this portion is repeated. Because of that, can you find any string which is different in both? You can observe here, AB star is there only with this, but AB star there with this. Because of that, can you see any difference? You can observe it. Before AB star, here only this portion is there, but here this portion is there. So what will you get the different string when you have this? Apart from this, you also have this. What else you can get because of this? Right? A, B, and if you want more A's like this, no, let me try B, double A, that can you get here? 3 A's. Before AB I am trying, before AB I am trying. Will take time, but it's easy to observe. Before AB star, that is before A or before AB, and here A, BB, triple E. Can you get A, BB, triple E continuously? No, right? But here A, BB I'll take, one B, A, B only I'll take, and other B I'll take here, and I'll take triple A and AB. So I can get it from here, but I can't get it from here. You can try this string, is not possible. Now look at this string, is it accepted or not? A, B, B, A, B, B, you can come here, and triple A. How can you get triple A? A, and one more A, B you can't get. Is there any other way that you can accept here? You can check that way. This triple A, B, B, A, B, B, A, B. So somehow you can go there for this string. So this string is accepted. So when you check eliminations, sometimes could be harder. But now again, when you observe, when you are not able to succeed, the method one, elimination. In case if you fail in a minute, then second method is you can directly observe the machine. Observe the machine, you may get directly the answer. Okay, right? D is the right answer, but elimination also gets difficult when both are almost similar. But that similarity you can understand. Here AB star is there, BA star is there, but AB star associated with this one, BA star associated with this one. But here you can see, before getting AB star, I can go here repeatedly, and finally I can satisfy with AB star. Before going to BA star and halting here, I can repeat these cycles, and finally I can come here. Because of it's both the cycles I can cover, and this will match. If somebody want directly here, how will you do normally? We'll try to eliminate this, and we'll try to eliminate back cycle. If you want to eliminate this, then you must cover this here. How do you cover here? A, B star B, A, B star B. How easy it is. If I want to eliminate this, B, A star E, B, A star E. Now our machine looks like very simple. It's a graph, right? This or this, A, B star B or B, A star A, and one side is A, B star. You will stay here, and other side is B, A star. You will always halt here. Now you can look at the option D directly matches with this. AB star B or BA star A whole star, or followed by either this one or this one, is exactly matches with. And this question is also 1 mark given, but not easy to solve like 1 mark question. Either, see, it's very simple. If you want, I'll put a numbers 1, 2, 3. How do I do this? 1 on A, I'll go to 2. 2 on B, I'll go to 1. 1 on B, I'll go to 3. 3 on A, you can stay there. Another A, you can come back to 1. Another A, you can go back to 3 on A, you can stay there. Another A, you can come back to 1. 1 on A, now you can go to 2. 2 on B, you can halt at 2. This is how, because of non-deterministic, it's not that easy to calculate the path that goes to final state. 1 double B triple A followed by AB. You can see that path. The designing could be easier, but only understanding takes time when NFA is given. So this is really 2-mark question worth. As you know, the option B, option D, not quick when you are not able to analyze or not able to observe the difference. But when you spend more time, you get more clarity. That's, you see now, when I look at the finite automata and I convert it, I'm directly getting this option. And when you got this option, there is no confusion like other options are correct. But when you are eliminating it, you need to spend a little bit of time to observe this too. Okay? Go ahead. SPQR. Many people not understood AB star and BA star. See, here actually it is self loop only. That's what you need to apply the trick. Save the time. It's actually A followed by B only. But this one you can write A, B star. It's only graph, no? Here also same thing I applied. BA star is there in the other state here. What I made is, anyhow you are going to say AB star, I've directly written as a transition edge, right? It just edge I have written. Both are same. You write AB star or put here AB star after deriving. I saved my time, you know, why should I analyze this loop, self loop? I converted to edge. Okay, both are same, right? This is not a finite automata anymore. It's a transition graph. Those who have practiced the elimination technique, here elimination of the states, the technique what I have applied in elimination of the states, this kind of techniques we apply to derive the expression using finite automata. So please read the data before analyzing it. Rohit, I explained the crash course. Removal of the package can be done many ways. Okay. By covering the self loop at first state or next state or both of them. So please watch that crash course, you may get it. Actually star, 0 star should be upside. Okay. While typing they did mistake. Likewise you see most of the stars down only. It's an expression, a mathematical equation mistake. All the stars keep as a superscript. Is it similar to the previous question? Concept is, again, given finite automata, how will you convert into expression? Technique you can follow. either elimination technique, or you can convert this motion to regular expression using elimination of the states. One technique, you can use elimination of options by using the strings. Is it MCQ? That's you know elimination of options allowed, and elimination of the states. In given finite automata, except initial and final, you can also do that. So first method I'll apply. Look at, will it take less time or not? If I observe the strings here, epsilon 0 1 0 0 0 1 up to 2 length I'll take. Epsilon not accepted, 0 not accepted, 1 accepted, 0 0 no, 0 1 no, 1 0 yes, 1 1 no, correct, 1 1 no. Now here look at epsilon no, here epsilon no, epsilon no, epsilon no, everybody doing same. 0 no, 0 is accepted right here, we don't want a 0, so eliminate. 0 not there, 0 not there, perfect. 1 we want, and 1 we want, 1 we want, everybody is doing. 0 0, only these 3 are there now. 0 1 and 1 1, if you look at here, 1 1 here, no one is doing, correct. So all the 3 are looking like, you know, they are doing generating similarly. Now if you observe them here itself, what is the difference? Here 0 or 1 1, here 0 star 1 1. What is the difference between them? Here every time 1 1 comes, here 1 1 not required. That means here I can generate 1 0 1 1. Here I can generate 1 1 1. That 1 1 1 we can't generate here. Now is it there or not? Check it. 1 1 1 is there, and it's not able to generate. So you can eliminate. And here you can see what is the difference between these two. 1 0 I can't generate here, but can you accept here? You can see 1 0 1 0. You are not able to accept. So C is the right answer. Elimination of options you can do, but with a careful practice. Correct? This is a method 1, elimination of options. Technique 2, because based on practice you can also get this. Technique 2, directly you go here and look at this state is trap state, so useless. You can eliminate them and observe this pattern. And look at this 1 and either 0 or 1 1. You can have, I'll eliminate, look at that. This state I will eliminate. How it looks like? 1, that P final state, either you will have 0 or this path will give you 1 1. So 1 followed by 0 or 1 1 whole star. Is it exactly same? 1 followed by 0 or 1 1 whole star. So directly you get this expression to take. So it's exactly similar to the previous type of the question, which is in 2023 and this is in 2022. So in 2 years you saw the same kind of pattern which is repeated. In option 1, what I was saying, I'm very sorry for that. It's not about 111. I did mistake. I'm sorry for that. Both are generated, right? 1 0 1 1. It was my mistake. So why we can eliminate that now? Let's try it. The string I have chosen wrongly. 1 1 1 0. Correct? 1 1 1 0 that we can't generate now. 1 1 1 0 if you take, 1 1 we have to take. Correct? 1 1 0 is accepted. But here it's a failing. Yeah. Elimination, why we have eliminated 1 1 0. That 0 I forgot to keep it. Thanks for identifying it. Yeah, that's what. While eliminating the options, you should be very careful what is generated, what is not generated. See, I'm going for 3 4 length. It is going to be complicated. And in this problem, directly looking at the option, that given finite beta and converting into options so easy, because it's just one cycle you have here. For that one cycle you can easily convert to self loop and observe it. Very good approach. Got it? So here I'll recommend this method rather than the first one. As you see, elimination of options is going to be complicated a little bit. Based on the practice only we'll get, is it 2 length you can eliminate the options, or 3 length or 4 length. Done. And what is the complication? If you are struck with the elimination of options, then it will consume a lot of time, and that's why after spending 1 or 2 minutes you should stop that and you should conclude, is there any other best approach? Within 3 or 4 minutes you should solve this question, right? But again it is 1 mark. So 1 0 is not generated. You can go in a sequence. You can also do this way in elimination of options. Rather than applying epsilon everywhere, you can look at here. Epsilon, you can't. 0, you can't. Both of them are same. 1, you can do it. 00, you can't. 0 1, you can't. Same, right? 1 0 we want. 1 0 we want, but you are not able to generate, so it's eliminated. And a smallest string which is 2 for 2 length, it is eliminated. And for this epsilon we don't want, 0 we don't want, but 0 it's generating. For 0 this is eliminated. Likewise you can just go in a particular order to eliminate. This will generate everything whichever is there here. But this one again you choose epsilon not generated, 0 not generated, 1 generated, 00 not, 0 1 not, 1 0 we want, but it is not able to generate. With the 2 length, up to 2 length, when you verify, A, B, D are eliminated and C is not eliminated because it's doing exactly what we wanted. Are you able to see? Some of the students are able to identify the smallest string because they are going in a particular fashion, and always when you are eliminating the options, definitely you go in this order. So take the strings up to 2 length, apply on everyone. If only one option left, you are lucky. If not, then observe 3 length, 4 length can help you or not. Because for me it will not differentiate much because we are not participating in GATE exam right now. We are only practicing. Now, which concept? DFA, minimum DFA construction, right? Any trick? Without designing DFA, can you do it? Does not contain 3 or more consecutive ones. I'm sorry, there was issue with the OBS. Now it's fine. Yeah. आज बहुत सारे streaming में issue है. Maybe because of OBS server or streaming issue. Don't worry. Whenever there is any lagging, just report in the chat. I'll take care of it. Just takes 1 minute time to come back. You understood, right? The same 4 states for even the question is W does not contain 3 or more consecutive ones. W does not contain 3 consecutive ones. Both are same. You can solve using the interchanging final non-final concept. Containing 3 consecutive ones, same machine will help you for not containing. ये तो काफी इजी है, 2023 में आया है और क्या चूज करना है? सेट ऑफ वैलिड आइडेंटिफायर्स. आइडेंटिफायर का डेफिनेशन क्या है? letter followed by letter or digit whole star. Here itself you have the answer, right? Minimum letter accept करना है, उसके बाद letter or digit, like just like a plus b whole star. You know, starting with a followed by a plus b whole star, the same concept. They have given letter followed by letter or digit whole star. If you are already solved a followed by a plus b whole star, the starting with a machine you need to choose. Where is it? Letter definitely होना चाहिए. Which machine? They did not give you directly. Here without letter also it can go to final. तो epsilon यहाँ accept होता है, तो this is wrong. And B में क्या issue है? Letter, but I can't repeat after letter digit, but I can write, I can have double A B after E. यहाँ पर letter के बाद digit आ सकता by repeating. यहाँ पर problem क्या है? This is nothing but letter followed by either letter whole star, or you can write like this, digit whole star. This parenthesis you can eliminate. Simply you can write letter star. This is a different expression, right? Now ये जो NFA with epsilon moves दिया है, यहाँ पर letter followed by ये जो मशीन है a plus b whole star का मशीन है, either letter or digit whole star you can repeat as many times you want it, right? But there is a one transition missing here. I'm very sorry for that. Yeah, this is the final, right? If you don't want this thing, you can halt here because of the final. Okay, all the transitions are covered. If you want only letter, if you want only digit, if you want both of them, letter, digit, you can come back. This exactly does our purpose. Sorry for small machine. Anybody not able to read it properly, you can see that this is epsilon, this is the digit, epsilon, and this side is given letter, there epsilon transition. And what is the concept here? Which concept we have applied? The given expression, they are constructing NFA. So directly regular expression to NFA with epsilon moves. When you are practicing how to construct finite automata for given regular expression, we do this kind of techniques. Like a plus b whole star machine, a star machine, a b machine, a plus b machine. They were just like similar to this. ये तो previous question से है, right? अच्छा, previous question मतलब क्या है वो? Okay, sir, ये भी question पूछ रहा है बहुत लोग in WhatsApp and Telegram groups. Look at, sir, I have solved the PYQs multiple times, but have you solved the PYQs the way you require to solve? As I say, right, here answer is doesn't matter. It is important to gather the data, to understand the data, और उसके बाद उनको अप्लाई करना. क्या कभी कभी ऑप्शन से आंसर हो सकता है आपके राइट आंसर, कभी कभी ट्रिक से हो सकता है, कभी कभी गिवन क्वेश्चन में डेटा हो, तो आपको समझना चाहिए किस तरह आपको इंटरप्रेट करना है. बफर के टाइम में नहीं देखा है. अरे बफर टाइम में कुछ एक्सप्लेन नहीं किया मैं. ये जो लाइन है इंटरप्रेट किया, डज नॉट कंटेन 3 or more कंसेक्यूटिव वंस. इसी लाइन को यू कैन ऑल्सो राइट 3 or more. अगर नहीं होना चाहिए, 3 काफी है बताना. 3 वंस नहीं है तो 4 वंस भी नहीं होगा ना कंसेक्यूटिवली. तो ये दोनों सेम कहते हैं हम. डज नॉट कंटेन 3 consecutive ones, same as 3 or more consecutive ones. करेक्ट. ये दोनों सेम है, अगर इनको सॉल्व करना है कंटेनिंग 3 कंसेक्यूटिव वंस सॉल्व करना है, 4 स्टेट्स है, और उसी मशीन में फाइनल एंड नॉन फाइनल को इंटरचेंज कर दो, आपको नॉट कंटेनिंग 3 कंसेक्यूटिव वंस आएगा, वही मशीन इनकी है। बस ये बताया था मैं। रिसेंट 2024 MSQ टाइप क्वेश्चन है। डज नॉट कंटेन के लिए क्रॉप स्टेट होगा, बट कंटेनिंग के लिए जो लास्ट फाइनल स्टेट है वो ट्रैप बनेगा नॉट कंटेनिंग में। नॉट कंटेनिंग में ट्रैप आएगा जब फाइनल नॉन फाइनल इंटरचेंज करेगा तो। व्हाट इज गिवन अगेन, क्लोजर प्रॉपर्टीज रिलेटेड क्वेश्चन is regular, L2 is also regular, L3 is not regular. How many regulars are there? Infinite regulars. So it might be any regular there. Even not regulars also infinite. Which not regular? It could be any. Which of the following is always true? No matter which regular you take, which non-regular you take, for the given L1, L2, L3, which is going to be true always? L1 is equal to L2 if two languages are exactly same, if and only if L1 intersection L2 complement equal to pi. And it means whenever L1 is equal to L2, it should satisfy. Whenever this is true, it should satisfy. And are they going to hold? First thing is, and how many of you know this definition is for not for the equal to L1 subset or equal to L2 if and only if L1 intersection L2 complement is 5. It's the actual definition for the subset, but they have given for equal to. Okay, which statement will be true, which statement will be false? When you are going this direction, because it's a bidirectional, right? L1 is equal to L2, definitely outside the L2 there is no L1 object, right? So this is true. But whenever this is true, L1 and L2 need not be equal. L1 can be subset of L2, like this also. If, look at that, L2 outside, L1 is not there, that means L1 might be same as L2 or could be inside. So this is going to be the false statement. That's why this is not true. Okay. Only when L1 is equal to L2, these statements will hold. Right? And that's why this statement, look at it, L1 is equal to L2 or L1 proper subset of L2. Both definitions are covered here. And next one, L1 union L3 is not regular. Regular union not regular. Can be regular or not regular, right? How can you say not regular? Its actual answer is either regular or not regular. Already given, right? If you take one of them is sigma star union L3, you will get a sigma star. That is the regular, na? Counter example, if L1 is sigma star union non-regular will be sigma star. So this statement is false. L3 complement. You know, any non-regular you take, do the complement, you will get a not regular only. So how to prove that? Not regular complement is not regular. A very simple statement. Not regular, if you do the complement, assume that you got a regular. If you get it, the regular complement has to be regular, right? These two are complement to each other. If you do not regular complement is regular, then regular complement has to be regular using the definition of DFA or minimum DFA interchanging final non-final. You have the DFA for both. Now not regular complement never be regular. The reason is regular complement has to be regular. You can't come back to this not regular. The not regular complement is always not regular only. Both will not have a finite automata. So this is always true. And next one, regular complement is regular, regular complement is regular, regular union regular is regular. It is also true. Both are true. How do you prove it? L1 is regular, we know. So L1 complement is also regular. How do you know? Regular complement is regular. Similarly, L2 is regular given already. So complement of any regular is always regular. And we have the regular union regular, and union is also regular. If you take this and this, do the union, you will again get regular only, because regular union regular is regular. All clear? What is the concept behind this question? Just properties. Closure properties, like you should know how to apply the union, complement, and relationship between the equal and subset or equal and this property. Option A. To understand option A, just you need to understand L1 is equal to L2. You find only if L1 intersection L2 complement is equal to I. It means 1, if L1 is equal to L2, then L1 intersection L2 complement pi. Second, if this is true, then you have to prove this. You know this point, right? Have you studied x equivalent to y? That's one, x implies y should be true, and second, y implies x should be true. Then only this equivalent to y you can also write another way, x by implication y. It's a definition of by implication ना. यही definition यहाँ apply कर रहा हूँ मैं बस. आपको पता है which one is true? ये true होगा, दोनों equal है, तो हमेशा L2 के बाहर L1 कभी नहीं होता, इसलिए L1 इंटरसेक्शन L2 कॉम्प्लीमेंट इज 5. जब ये L1 इंटरसेक्शन L2 कॉम्प्लीमेंट इज 5, हो सकता L1 और L2 बोथ आर सेम. L1 वो भी L2 हो सकता. और अनदर रीजन इज ये L2 हो सकता है और L1 अंदर हो सकता है. L1 could be subset of L2, तो there is no guarantee L1 is equal to L2. L1 is equal to L2 हो सकता और L1 proper subset of L2 हो सकता. इधर ये होना चाहिए था L1 proper subset of L2. Then this statement is true. तो अब this is false. Okay? ये statement बताया था मैं उधर. और एक्चुअली स्टेटमेंट किसके लिए? इधर सबसेट और इक्वल टू होता है तो दोनों सेटिस्फाई होता है. इधर सबसेट और इक्वल, इधर सबसेट और इक्वल, दोनों ट्रू होगा. बोथ विल बी ट्रू व्हेन हियर सबसेट और इक्वल टू देयर. हो गया? राइट. Subscript, please don't worry about it. Just 0, 1, 3, they assume they are subscripts. Okay. Here NFA concept depends on NFA with epsilon moves दिया है और वो table दिया है. You should understand what is given NFA. Just you need to apply the path. NFA, understand path. Nearly 2 times it was asked same kind of or similar kind of question. NFA is given with epsilon moves and they ask for the particular string from this particular state. What are the states it can halt? 2 hours completed. How many slides left for the first topic? Nearly 30 more questions are there. What do you do? For this given NFA, we just draw the graph. You will easily understand what need to be done for ABA. Correct? Okay, first design the machine. Here final states we don't need at all because we are not worried about acceptance. We are only worried about from Q2. What happens if you read ABA? What are the states we can halt? For that, to know what is the machine first. Even circles also you can avoid if you want it. Q0 on epsilon Q2. Q0 on here. Another mistake is this is A and this is B. Q0 on A, Q1. Q0 on B, Q0. The self loop, right? Done. Q1 on epsilon Q2. Q1 on A, Q2. Q1 on B, Q3. Q2 only epsilon we have to work for Q0. So from here to here. For Q3 on B it should go to Q2. That's it. Now the question is from Q2. From Q2, first you should read A, then B, then A. Then you should look at where can you halt. Q2 on A, you can see what are the possibilities. One is this one. Other one, you can also jump here. How? Epsilon A. This is another way to read A. So from Q2, there are two ways to read the first A. Directly you can read, or that's the one way. You can directly read A, you can go to Q2. Or another one, you can go here by reading epsilon. You can go to Q0. From Q0 also you can read A, you can go to Q1. Are you able to understand? अगर आपको A read करना है Q2 से, directly you can read, or you can go to this A by using this epsilon followed by A. Okay. Now this A we did, and then B. Now from Q2, here there are two options, from Q2, from Q1. From Q2 अगर आपको B read करना है तो आप इधर जा सकते, नहीं है तो ये भी जा सकते. कैसे? By taking epsilon then B. तो अगर ये B read किया तो उसके बाद A impossible है. तो अगर Q2 से B, if you go to Q3, then you will stuck because you can't read that A. अगर आप इस B को read किया by taking epsilon, you come to Q0 and take this B. Of course, you can take this epsilon B, but it will waste your time. Okay, Q0 on B, it's a Q0. And B यहाँ से भी read करना है Q1 से B. That is possible by taking epsilon B. This path, useless because after B A is impossible. Epsilon B. There is another way here. There are two ways, epsilon Q2 and there B, but this will be useless later on. And here epsilon Q2, epsilon Q0, then B Q0. Now this B is done, and finally we need A. From Q3 A impossible, there is no transition. From Q0 A is there. From Q0 A you can go to Q1. And from Q3 A is not there. From Q0 A is there. They're same as this one, right? A, Q1. Now there are two places you can halt. There's a one place that is Q1. If you are able to halt at Q1, you are able to halt at Q1, and Q2 also you can halt by reading epsilon later on. and if you are able to alt at q2 by reading epsilon, you can also alt at q0. So if you are able to alt at q1, you can alt at, here only you can see, by reading epsilon you can alt at q2, and by reading epsilon you can also alt at q0. So there are three states you can get: q0, q1, q2. That is nothing but option C. That you can do very quickly. Both people are saying wrong machine. So what did I do? Did I do any mistake? Let me check. q0 on epsilon q2, q0 a q1, q0 b q0, q1 epsilon q2, q1, okay, yay, I missed it. B, oh, the q1, then what did I do? Oh, for this I kept. So anyhow, the machine I made it wrong, but you got this answer. Let me change the machine and then conclude it again very quickly. Sorry for that. One mistake leads to a lot of mistakes. Carefully I could have done. What mistake I did? q1 transitions I took for the q2, correct? q2 only epsilon is there. For q1, on A it should go to q2, on B it should go to q3. So that mistake is done. Okay. Now q2 is done. q3 on epsilon q2, correct? q3, sorry, again mistake, B. Now it's done correctly. Instead of taking q1, I have taken q2. That was blunder mistake. Anyhow, for any machine is given, you understood how to take the transitions, right? You cannot look at the table, which takes a lot of time, but finite automata will be easy to cross check. Now can I do it directly? You understood, right? q2 on ABA. What are the possibilities? We'll do it directly. Okay. Now you know step by step how to take q2 ABA. So A I should find, where is it? I have one A here, I have another A here, but directly I can't go here, but I can go here. How? By taking epsilon and A. So q2 epsilon q0 and A, you can go to q1. So A is done. Next B. From q1, if you want to do B, see that I can take this B, but the problem is next has to be B, but यहाँ पर next जो है ये है, तो ये पाथ नहीं ले सकते. और दूसरा क्या है, ये भी रीड कर सकते. कैसे? एप्सिलॉन एप्सिलॉन बी. तो q1 on epsilon q2, q2 on epsilon q0 and q0 on b q0. तो ये भी रीड कर दिया. और q0 से a रीड करना था. q0 से a रीड करना है. तो look at all the possible options. One, you have a here, q1. q1 पे हाल्ट हो सकते हम a के बाद. Then q1 is the one answer. अगर q1 में हाल्ट हुआ, q2 में भी हाल्ट कर सकते by reading epsilon. अगर q2 में हाल्ट हुआ by reading epsilon, you can also halt at q1. Anyhow, you got the same answer, luckily. Right? Sorry for that machine transitions. Still you got the same answer, luckily. So here what is the concept you should apply? एग्जाम में अगर सिमिलर क्वेश्चन आया तो प्लीज एप्सिलॉन NFA जो टेबल दिया है, प्लीज डोंट रीड डायरेक्टली. ट्रांजिशन टेबल जो है तो उनको डायग्राम में कन्वर्ट करना, देन एनालाइज, रन ए मशीन और रीड पाथ. ये अप्रोच आपको फॉलो करना होगा. ठीक. और एक और मिस्टेक किया है इधर, एक्सटेंडेड सिंबल लगाना भूल गए टाइपिस्ट. ये रीसेंट क्वेश्चन था 2024 में और बहुत लोग इनको बहुत टाइम लिया है करने में. क्यों? इनके अप्रोच ऐसे है, जल्दी आपको करना है, अप टू 5 लेंथ तक आपको एनालाइज करना है, अप टू 5 लेंथ देयर आर लॉट ऑफ स्ट्रिंग्स बट एवरी स्ट्रिंग नहीं लिखना है, ये स्टार सारे जो है ऊपर लगाना ताकि ये सब सुपर स्क्रिप्ट है, 0 1 स्टार, यहाँ 1 0 स्टार, एक बार लिख देता हूँ, r इज इक्वल 0 स्टार और 1 स्टार, s इज इक्वल 0 1 स्टार और 1 0 स्टार। Yeah, PDF will be shared with you. You can access on GFG website. Oh, don't worry about final state. वो क्या है, यही तो है प्रॉब्लम, आपका क्वेश्चन में कहीं पर भी फाइनल स्टेट की मेंशन नहीं किया, जरूरत ही नहीं है, इनिशियल स्टेट भी जरूरत नहीं है, क्वेश्चन में कुछ अलग है। फ्रॉम स्टेट क्यू टू व्हाट विल हैपन और व्हाट आर द स्टेट्स दैट यू कैन हॉल्ट आफ्टर रीडिंग एबीए स्ट्रिंग, ये क्वेश्चन को समझना, इनके लिए कोई फाइनल स्टेट जरूरत नहीं, यू डोंट नीड एनी फाइनल स्टेट फॉर दिस प्रॉब्लम। गेटिंग? इट्स वेरी सिंपल, फ्रॉम क्यू टू आफ्टर रीडिंग एबीए स्ट्रिंग वेयर डू यू हॉल्ट? आई कैन हॉल्ट एट Q1, I can alt at Q2, I can alt at Q0 because I have the path for the same string but 3 different states. It's working now, right? Coming, the same issue coming regularly. So look at, it's a 2 mark, a numerical answer type. So definitely, you know, it may take time as it is numerical answer type and 2 mark. 1 mark के लिए क्वेश्चन स्ट्रेट फॉरवर्ड हो सकता है, 2 मार्क के लिए थोड़ा घुमा के देते हैं, तो आपको कहीं ना कहीं शॉर्टकट हो सकता है टाइम सेव करने के लिए। अगर नहीं हो पाया देन यू शुड डू वेरी क्विकली, इवन मैनुअली आल्सो यू कैन डू बाय अंडरस्टैंडिंग द क्वेश्चन। अब क्वेश्चन में क्या है, टोटल नंबर ऑफ स्ट्रिंग्स ऑफ लेंथ लेस देन और इक्वल टू 5, तो 5 से ज्यादा लेंथ की जरूरत ही नहीं है इधर, तो आपकी जो स्ट्रिंग्स है, लेट्स से लेंथ ऑफ द स्ट्रिंग 0 हो सकता, 1 हो सकता, 2 हो सकता, 3 अप टू 5 ओनली, राइट? लेस देन और इक्वल टू 5, 5 लेंथ तक होना चाहिए, करेक्ट? ये 0 लेंथ है, राइट? अप टू 5 लेंथ, विच आर नॉट इन और ऑल्सो नॉट इन एस। तो ये जो स्ट्रिंग्स जो है बिलोंग्स टू 0 + 1 होल स्टार होना चाहिए, बट W should not be in L of R and W should not be in L of S. Remember this point, W दोनों में नहीं होना चाहिए। इसका मतलब ये है, अगर R ये जो है, मान लो ये S है, मतलब लैंग्वेज ऑफ S मान लो, और इसकी ये तो पूरा सिग्मा स्टार ही मान लो, अप टू 5 लेंथ एवरीबडी, सिग्मा स्टार तो बहुत काफी है, राइट? आपको 5 लेंथ तक ही चाहिए। तो पूरा ये लेना होगा आपको, स्ट्रिंग्स ये फाइंड आउट करना होगा। सबसे पहले क्वेश्चन समझ में आया सबको? ये वेन डायग्राम एप्टीट्यूड क्वेश्चन जैसे है एग्जैक्टली, ये टीओसी क्वेश्चन ही नहीं है, इनडायरेक्टली। अगर आपको आर एस दो सेट्स दिया है, ये वेन डायग्राम क्वेश्चन है। सबसे पहले आपको आर में जो अप टू फाइल लेंथ ही फाइंड आउट करना है, फाइल लेंथ से ज्यादा नहीं करना है। यहां पर अप टू फाइल लेंथ ही फाइंड आउट कर लेते। एप्सिलॉन है, 0 है, 1 है, 0 स्क्वायर, 1 स्क्वायर, 0 क्यूब, 1 क्यूब, 0 पावर 4 मैनुअली लिखना होगा ताकि इजी होगा आपको समझने में। कितने स्ट्रिंग्स है इधर बाद में देख लेते। और इधर 0, इधर 1, इधर 0 1, इधर 1 0, 0 1 स्क्वायर, 1 0 स्क्वायर, 0 1 क्यूब, 1 0 क्यूब, 0 1 power 4, 1 0 power 4, and 5 length over, right? 0 is 1 length, 1 power 4 is 4 length, total 5 length, and 6 length आपको चाहिए नहीं। अब ये दोनों चेक किया, कॉमन स्ट्रिंग जो है 0 1 है इधर, right? You can check that 0 and 1 are common, remaining all are different। यहाँ पर 0 होगा 1 होगा, 0 होगा 1 होगा, बाकी स्ट्रिंग्स इसमें होगा और इसमें होगा। तो बाकी कितने हैं? 1 2 3 4 5 6 7 8 9। आर में 9 स्ट्रिंग्स होगा, एस में 1 2 3 4 5 6 7 8, यहां पर 8 स्ट्रिंग्स होगा। 1 विच इज इक्वल 2 पावर 6 माइनस 1 विच इज इक्वल 2 पावर 6 is 64 माइनस 1 63। तो टोटल आपको 63 स्ट्रिंग्स होगा इधर अप टू 5 लेंथ। तो ये क्वेश्चन दिया है आपको, W belongs to 0 plus 1 whole star, but W should not be here and that too up to 5 length ही फाइंड आउट करना है। तो यहां जो 0 plus 1 whole star है अप टू 5 लेंथ कितने स्ट्रिंग्स होगा? 63 है, और ये दोनों में नहीं है, वो कितने होगा? आपको ये चाहिए ना W, तो 63 माइनस 19 स्ट्रिंग्स दोनों में है, ये आएगा आपको 44। अगेन रिपीट हो रहा है क्या? बफर हो रहा है, वेरी सॉरी, आई वाज नॉट चेकिंग। ये वेन डायग्राम क्वेश्चन है, एक बार रिपीट करता हूं। आर में कितने स्ट्रिंग्स है? अप टू 5 लेंथ फाइंड आउट करना। कितने स्ट्रिंग्स है? 1 2 3 4 5 6 7 8 9 10 11 स्ट्रिंग्स है। और एस में कितना है स्ट्रिंग्स? टोटल 10 स्ट्रिंग्स होगा, और उसमें 2 स्ट्रिंग्स आर में है, एस में है, तो इंटरसेक्शन में आएगा। और टोटल आउट ऑफ 10 2 बीच में आएगा दोनों इंटरसेक्शन में, और 8 इधर है, और सॉरी एस का है, आर का है, तो 9 इधर आएगा, 2 इधर, तो टोटल 11 स्ट्रिंग्स है आर के अंदर। तो ये जो है आर है, ये जो है एस है। तो अब इनको चाहिए जो आर एंड एस, आर यूनियन एस की बाहर जो जितने स्ट्रिंग्स है उनको वो चाहिए था। तो व्हाट आर द स्ट्रिंग्स विच आर नाइदर इन और नॉर इन एस? तो दोनों में जो नहीं है वो उनको चाहिए था। वो कितना है? टोटल 63 स्ट्रिंग्स है, और इसमें जो आर एंड एस दोनों मिला के 19 स्ट्रिंग्स है। तो 63 से 19 हटाया तो 44 स्ट्रिंग्स आर नॉट देयर इन एन आर एज वेल एज नॉट देयर इन एस। 19 कैसे आया यार? देखो, आपको अप टू 5 लेंथ ही फाइंड आउट करना है ना, अप टू 5 लेंथ यही तो कैलकुलेट करना है। ये आर एंड एस में देखना होगा 0 स्टार और 1 स्टार। 0 स्टार में क्या क्या है? एप्सिलॉन 0, 0 स्क्वायर, 0 क्यूब, 0 4, 0 पावर 5, 0 6 नहीं लेना है कि वो 6 लेंथ बनता है। 1 स्टार में एप्सिलॉन ऑलरेडी कवर्ड है, 1 1 स्क्वायर, 1 क्यूब, 1 पावर 4, 1 पावर 5, यही तो है स्ट्रिंग्स। और ये आर में 9 कैसे आया? सॉरी, टोटल आर में 11 आया, 2 कॉमन है और ओनली आर में 9 है। ठीक, अरे इधर 8 स्ट्रिंग्स है, इधर 9 है, इधर 2 है, 19 है ना टोटल। स्पैमर है क्या दीपक? तो इसमें क्या खास बात है, कॉन्सेप्ट कहाँ से लेके आना है इसको? कॉन्सेप्ट इज डिपेंड्स ऑन योर एप्टीट्यूड नॉलेज। ये टीओसी की कॉन्सेप्ट ही नहीं है, बट लैंग्वेजेस जो सेट फॉर्म किया है टीओसी से, और आपको पता होना चाहिए वेन डायग्राम की कॉन्सेप्ट्स, राइट? अगर ये वेन डायग्राम की कॉन्सेप्ट्स पता है आपको, ये आर है, ये एस है, ये जो है आर इंटरसेक्शन एस है, ये जो है इधर से इधर तक और माइनस एस, इधर से इधर एस माइनस आर, और टोटल जो होता है ये पूरा मिलके आर यूनियन एस होता है, करेक्ट? इनको जो क्वेश्चन में पूछा है, आउटसाइड आर एंड एस कितने स्ट्रिंग्स है अप टू 5 लेंथ? एस पे पावर 4 नहीं। अरे थोड़ा भी दिमाग यूज नहीं करते, मैं क्या बोलूं इनको। ये 0 1 पावर 5, 0 1 1 1 1, ये 5 लेंथ ही होता है ना? आपको 5 लेंथ ही चाहिए ना, 6 लेंथ नहीं चाहिए ना? अरे ऊपर तो अकेला 0 था, 0 पावर 5 तक जाना होता, कि 0 से पहले 0 के बाद कोई नहीं था। इधर 0 एक लेंथ है, फॉलोड बाय 4 लेंथ चाहिए होता, तो 0 1 पावर 4, अगर 0 1 पावर 5 लिया वो 6 लेंथ बनता है ना? तो इतना तो डिफरेंस पता होना चाहिए, राइट? ऑलराइट, हाँ, बेसिक डाउट को डाउट बनाया तो ये कर पाएंगे। ये तो बताया, रिपीटेड क्वेश्चन मल्टीपल टाइम्स, लास्ट ईयर में, दिस ईयर में भी क्वेश्चन आया। कितने बार आया मुझे भी नहीं पता, बहुत बार आया क्वेश्चन। सेम एनएफए टू डीएफए कॉन्सेप्ट। आपको फॉल्स चूज करना है, ठीक? Please try everyone. Do not wait for my explanation. NFA दिया है with n states, यहाँ पर क्या क्या फॉल्स होगा? Slides I'll share in Telegram group. Okay. Another, you can go to GFG website. There is a 𝐂𝐤𝐴𝐻 videos. There you can also download the PDF. This video also streaming on Geeks for Geeks website. So if you can find this video, definitely you can find PDF there. Okay, every statement a MSQ है, and definitely you are proving that MSQ not easy for you. सबसे पहले क्वेश्चन को एनालाइज करना आना चाहिए। देखो इधर एवरी सम, MSQ में यही थी कंफ्यूजन है, एवरी सम। तो वहां पर देखो ये में दिया है, सबसे पहले ये समझना बात को, देयर एग्जिस्ट एवरी, यही वर्ड्स आपको पकड़ना होता, क्योंकि इसी वर्ड से आपकी मीनिंग बदलता है। यू अंडरस्टैंड दिस पॉइंट? Okay, maybe digital logic they might be uploading or not uploaded, or uploaded, I will check, but I will definitely find maybe today or tomorrow. Yeah, रात को class हुआ, right? Maybe you know that conversion of PDF and compressing might be delayed. I've given my Telegram QR code, right? You can go there and you can find the PDF. I'll immediately upload there just after the class. L may have an accepting NFA with less than n states. Is it true or false? See, I have an NFA. This is NFA, right? Now the same thing I can also design less than n also. Empty language, correct? Even I can design with one state if I want it. In case NFA has n states, they did not say minimum NFA. Remember that they only said NFA. Minimum NFA, if they say, then you may not find less than n states, correct? L may have an accepting, right, NFA with less than n states. That's a true, but we want a false one. L may have an accepting DFA with less than n states. See this, I have a 3 states. If I want a DFA, I can also design a DFA like this. It is one state. Yes, it is also true. There exists a DFA with less than or equal to 2 power n states that accepts L. Yes, if NFA has n states, we have the algorithm that can show 2 power n state a DFA is there. When you minimize, either 2 power n or less than will be happening. It is true that even option C. And last one, every DFA that accepts L has greater than 2 power n states. Already we are saying our minimum DFAs are having less than or equal to power n. Now every DFA, how can you go for greater than? This is going to be the false one. The C is already proving that D is false. Now you might be wondering, sir, it is the MSQ and you are predicting like more than one option is going to be false. But actually only D is false here. It is another trap kind of question where people always choose more than one is the right correct option in the gate, but ऐसे भी हो सकता तो एक से ज़्यादा होना जरूरत नहीं, कभी कभी एक भी सही है MSQ के लिए. ठीक, go to gate set go CSCRDA, then go to practice and previous year questions. You will find the PDF. So it's very easy to find on GFG. Here most of the MSQs will trap, you know, using this kind of statements. Every may there exist some. Go ahead. In 2025 we have another question here. How do you solve this question? Anybody is having the knowledge of combinatorics, combinations with repetitions? Concept is, to solve this you don't need a TOC, basically you need discrete mathematics knowledge. They use the combinatorics. without repetition, how many strings are there? You think opposite. You want contain at least one occurrence of 2 consecutive symbols, and आपको 5 लेंथ स्ट्रिंग चाहिए था, strings of length 5. आपको ये फाइंड आउट करना सबसे पहले, the repetition is not there, like 2 consecutive is not there. If the 2 consecutive is not, very sorry again, lagging is an issue. To 43 total strings. तो ये फाइव लेंथ स्ट्रिंग का कॉन्सेप्ट क्या है? टोटल नंबर ऑफ फाइव लेंथ स्ट्रिंग्स कितना है इधर? 1 2 3 4 5, राइट? So 3 possibilities, 3 choices. There are also 3 choices, either A or B or C, right? You got 3 power 5 strings are there. This is nothing but how many? 243. Here again 5 length strings only, but should not have a repetition. Suppose here you have A. First we'll talk about A. Then here you have a B or C. So only 2 choices are there. If it is a B, again you have a 2 choices, right? So 2 choices, 2 choices, 2 choices. Similarly for the B, you have a 2 choices. For the C, you have a 2, 2, 2, 2. Because you should not repeat the same symbol. If I keep the B here, here you can't keep the B. So A or C you will have. So 2 power 4 into 3. So 3 into 2 power 4 strings, the 48 strings here. 3 power 5 is equal to 43. And this one 48. And 243 minus 48 total is equal to, is it 195? Great. Have you seen, if you have not studied the combinatorics, like this problems we could have solved, like how many 3-digit numbers are there, how many 5-digit numbers are there without any repeating digits. This kind of concepts already solved here and there in discrete maths. That's why the discrete maths, some of the topics will be covered in other subjects, like in TOC, many of discrete mathematics concepts will be covered. Like in data structures and algorithm, graph theoretical concepts, graph theory concepts are used much. In TOC, mostly set theory concepts, like set concepts, and combinatorics. Combinatorics permutations can be used in any subjects too. How much time? It's almost 3 hours, right? You need a small break, 5 to 10 minutes. Or shall we continue? Yes, I'll immediately share the PDF. It will be uploaded today or tomorrow itself. Okay, just small break. So time. What is too much? Just 2.5 hours, right? Just 5 minutes break. 7:45 p.m. will begin. Directed dinner. Just I'll have water too. I'll come back when I can change the cells and I can save the file. I can do lot, right? Meanwhile. Yeah, am I audible? Hello. So let's for the remaining. Recent question this year. Very easy. In the earlier gate question, this question was asking like W, X, W. Now they change the pattern, alpha, beta, alpha. Right? It's the same, right? The concept is used identifying languages. We have done hundreds of questions in identifying languages, regular languages. In similar pattern, I think I have given you nearly 30 questions in the class in regular batch. In crash course also have given a lot of questions too. So options are easy to identify. Regular or who is regular just need to be identified. L1 analyze it. Alpha, beta, alpha. If any problem happens because of alpha only, right? Now beta is a plus b whole plus. Alpha is also a plus b whole plus. Now, is it similar to the practice that we did W x W, where W comma x belongs to a plus b whole plus? And we know this language is not regular. What is the reason? Because there is no finite automata, there is no regular expression. It's not easy problem. Like without a memory, you cannot solve this question. There is repetition. These two alphas need to depend on each other. इसलिए वो regular नहीं है. और second one, यहाँ भी ऐसे alpha लग रहा है. But we'll just understand again what is this problem about. Alpha belongs to a plus, means a. What is beta? Beta belongs to a plus b whole plus. So beta is not repeated, so I can put all the options which are there, right? A, comma. When I put double A, beta can be anything. Of course, beta you should put one by one, but all the possibilities I am keeping here. Double A should be same, right? And a power 3, that beta, a power 3, a power 4, beta, a power 4. If you observe it, all these strings, is it already covered here? Because only one here, at least one length. And that at least one length can cover even a followed by at least one followed by a, right? And this portion, this a and this a is matching. Remaining, this a plus b whole plus can cover this, and also remaining like ab is covered here, and many other options are covered. And this is also covered here. This is also covered here. So answer is going to be a plus b whole plus. Assume sigma is a comma b, or you can write a plus b. It is definitely regular. And L2 is regular, L1 is not regular. Where is that option? L1 is not regular, but L2 is regular. So C is the right answer. Go ahead. This year gate question, how easy they are, and recent gate questions are numerical answer type are time consuming, remaining are easy to solve them. which of the following languages are accepted by given DFA? Set to right. A's are covered in L2. I'm solving this, he is solving this one. How A's are covered? Here beta is always there, A plus B whole plus. How only A's are there? No, right? If you want only A's, what even a single A is there? No, right? A, B should be at least, beta should be at least one length. 3 length is the minimum here. Only A's means single A is not there. How can you say only A's? Don't waste the time. You analyze later, we'll see if anything goes wrong. Everybody got the answer? I no need to say that. B or C? The set of all strings ending with the pattern AB, BAB. Some are answering B, some are answering C. Which one is right? Okay, let's analyze. The set of all strings containing even number of bits. If you are looking at even number of bits, look at odd number of bits. 1B, second B, A, third B. So that odd number of bits should not accept, right? Even number of bits everybody accepted. Look at 2 bits. Is it accepted? 1B and 2B is not accepted. Yes or no? 2B is here. So 2B is failing. Epsilon is failing. When epsilon is missing. The set of all strings containing the pattern BAB. Just if it is having BAB, then look at BAB. Before that, let's say A comes, it accepts. After that A comes, will it accept? It is having BAB but not accepted. The set of all strings, where is all strings? One string I am giving counter example. Set of all strings ending with the pattern BAB. You can look at final state, last 3 symbols always having BAB sequence. So look at last 3 symbols. Here I can come from here BAB, or I can see from here BAB. I can see from here BAB. So this machine is actually to accept all the strings ending with BAB. The set of all strings not containing ABA. If it is not containing ABA, you should not accept any string which is having ABA, right? A, B, A, B. Is it accepting now? It's having ABA but accepting. Failed. Again, it is given as MSQ, but we have only one option is right. So it's another trick in the GATE exam. Some of the questions are played well. Only one option is correct for MSQ2. Okay, so keep that in mind. Don't always choose MSQ means more than one. So MSQ means greater than or equal to one correct option. So MSQ, but still one option is correct. Minimum number of states required to realize this FSM. Anyone tried? ना प्रॉब्लम क्या है यार, ऑप्शन भी रिपीट, वीडियो बाद में देख सकते हैं ना. The set of all strings containing the pattern BAB. I have given one string. This is having BAB, right? BA. Is it accepted? BA. Not accepted. That means this sentence is wrong now. If it is BAB accepted, here you will see A comma B. अगर आप अच्छा से practice किया, if you have well practiced, you will know if it is containing BAB, after going there, you will have a self loop. Right? You should have practiced this kind of machines already. Okay. Total how many states? 8, no? Now I'll just try to modify here itself. It will take time to design again. So I'll do here itself. Look at is a table, right? In table, minimization algorithm is so easy to apply. Look at the state A. Is it similar to any other state? Like you see FB. But their outputs are different. You can see that for F0, for B0, and here for F1 and for B1. So you cannot combine these two states. And B, is it same as any other state? DC, right? B and E. Can we combine? Check. I'm asking again, can we combine? If you can combine, the outputs also should be same. DC and 0, 0, 0, 0. Is it same? The entire two rows are exactly same or not? So I'll combine. So by deleting one of them, first I'll put here. I'll write here BE. That's it. And we'll delete this one. And wherever you see B or E, put a BE. That's it. B is there, put a E. E is there, put a BE. Anywhere, B is there because E is merged with the B now. Done. Now one row is deleted. Similarly, is there any other row which we can delete? For the C, FBE is there. For F also FBE is there. And output here 0, 0, here 1, 1. So we cannot merge. And any other GA and GA. Can you see these two rows? D and H. These two rows. Can we merge? GA 1, 0, 1, 0. Exactly same output. So I'm going to merge DH. And I'll delete this H row completely. But wherever you see H or D, put a DH because now both are same. D is there, so I'll put DH. H is there, I'll put a DH. That's it. Let's check again. H and D should not be alone. Now I'll just put complete blank. Because if it is visible, you will see. Two rows are eliminated. Now any more rows which are same, just check once. Exactly same output. No? Output should be same. Same, check. A and B. Can we match? F, B, 0, 0. Match these two. Now this will become, let's say, AC. Now we can delete this 0. This is same as A. And wherever you see A or C, write AC. AC, AC. That's it. Now check. easy technique to club the two rows. FBE is there here, but outputs are different. DH is not there anywhere. G is there here, but this is different. That's all. 1, 2, 3, 4, 5. Got a 5 states? Is it same? What you have said? And this technique you can also apply in DFA, but it takes a lot of time. Not easy. Everyone, same technique you can also apply in minimum DFA also. If you want to get a minimum DFA from DFA, you can also club this rows. But the problem is you need to rename, you need to remove that. That's why we apply the partition technique, we'll get very quickly. Same technique you can also apply in DFA. Finally got 1, 2, 3, 4, 5 states. Okay. This is combination of all the concepts, right? Closed under, context-free languages, recursive. Anyhow, we are going to do all of them, right? No need to draw table. You can use the shortcut like observe it, club it, and do it. One table and you do everything there itself. Just I did, no? You're not going to explain anyone, so you do very quickly. Maybe MSQ. My God, have you seen? I've seen first time that MSQ is like matching the pairs. Context-free languages, are they closed under union? Well, one. In options, A, B only there for one. P also check. Not closed under complementation. Correct. So you can choose one for A as well as one for B. So one A is there, one B is there. In all of them you have it. So possible that all the four are going in right direction. 2, you have a B, C, A, C. So A, B, C you have to check. Recursive languages closed under union. Perfect. Not closed under complementation is wrong. Closed under intersection. That is right. So A, C correct. So B is wrong. C is correct. A is correct and C is correct. So we eliminated option A. Now for the 3, you have A, B, C. All of them you have to check. Regular languages closed under union. Closed under complementation. So don't choose B. Closed under intersection. Very, very easy. So now A is right. C is right, but B is wrong. So eliminate D. So C and B are correct. But carefully you choose the options as they were confusing with MSQs, but easy to answer once you know which of them are correct. Go ahead. All the stars keep as a superscript, just they were typed after the character itself. Again, concept is identifying regular languages. It's very popular question. Identification of regular languages. Practice more for this identification. Some are saying AC, some are saying AD. D, you have the issue with A's equal to B's, correct? Number of A's equal to number of B's, that we cannot have any method to check in the given language using finite automata. What is the issue with the B? Most of you are doing it. Here, this M should be greater than or equal to this number of A's greater than or equal to number of B's. And the C is nothing but number of A's minus number of B's. The number of C's matches with M minus N. And first, do you have any method to check A's greater than or equal to B's when you have A power M, B power N? There is no way to check using finite automata, right? There's no way to write regular expression also. The reason is, if you write one B, I have infinite choices for the A. Every count for the B, you have infinite choices for the A, correct? So this B and D we can simply eliminate. It's a remainder based problem, right? Number of A's, if you can check the divisible by 7, there 7 remainders are there, 0 to 6. And if you keep the remainder 2 as a final, it will become 2 mod 7. Similarly, if you go for a divisible by 9 concept, there are 9 remainders are there. In that, if you keep remainder 3 as the final, you'll get 3 mod 9. And also, you know, 7 multiply with 9, 63 states are there for this problem, correct? And it is regular, and it is simply A star, B star. It is clearly shown that it is a regular language. Done? Set 2, right? One of the interesting problem. Sigma is given 1, 2, 3, 4, where x belongs to sigma star. That means that x is a string, which is just, you need to use the 1, 2, 3, 4 symbols. Here, prod of x be the product of symbols in x modulo 7. We take product of epsilon is equal to 1, where epsilon is the null string. For example, the product of 1, 2, 4 is nothing but 1, 2, 1, 2, 4 multiplied with mod 7, which will give you remainder 1. L is the language where all the strings in a sigma star, their product of x is equal to. That means their remainder, you will get 2 after dividing with the 7. The number of states in a minimum state DFA is dash. My chart is disconnected. Let me check. Okay, I'm clear, right? Issues today. The question is like sigma sigma star. Understand what is sigma star first. Epsilon 1, 2, 3, 4. Now you know BC. Now we have 1, 2, 3, 4. Like 1, 1, 1, 2, 1, 3, 1, 4. 2, 1, 2, 2, 2, 3, 2, 4. 3, 1, 3, 2, 3, 3, 3, 4. You understood, right? How to form the, just for understanding I'm writing it, because many people practiced with ABC. Now they have to come for 1, 2, 3, 4. They don't switch immediately. So that's why I'm helping you. What is sigma star? Now they have defined what is the product of X. This is X, right? If you want to find the product here, let me write a product. If you want to calculate here, what happens? For epsilon, product of epsilon they have given 1. Product of 1 mod 7 is also 1. 2 mod 7 is 2. 3 mod 7 is 3. 4 mod 7 is 4. 1 1. 1 multiply with 1 mod 7 is 1. 1 multiply with 2 2. 2 mod 7 2. 1 multiply with 3. 3 mod 7 3. 4 mod 7. 2 mod 7. 2 2s are 4. 4 mod 7. 6 mod 7. Now 2 4s are 8 mod 7, definitely 1. 3 1 3. 3 2 6. 3 3 9 mod 7. So 2 is the remainder. 3 4s are 12. 12 mod 7 5. 4 1 4. 4 2s are 8. 8 mod 7 1. 4 3s are 12. 12 mod 7 is 5. 4 4s are 16. 16 mod 7. It's a 2, right? You understood what is the product calculation for every string. If you assume they are X belongs to sigma star. When you apply the product on every string, you will get this remainder that is calculated by the product. Now the question is very simple. What is your L? L is your language. The X belongs to sigma star. Its product is 2. The product is 2 here. You can see whichever the product is coming to, that should be in your language. Like 2 and 1 2 and epsilon. No, it's a correct. 2, you got a 2 here also. I'm sorry, I'm missing some of them. 2 1 and 2, that's 3 3 and 4 4 and so on. Understood what is L? The number of states in a minimum DFA to accept this L. If you observe all of them, you can see, observe all of them, you never have a 0 here. Yes or no? So 0 state will not be there at any cost, because 0 is not there. Only you have digits 1 2 3 4. You will go to 1 2 3 4 anytime, correct? And sometimes you will get a remainder 6, you will get a remainder 5, and 7 is not there. Now tell me how many states will have? Can we design the table for this? Reminders 1 2 3 4 5 also there. Yes, 6. That's it. Because 7 impossible to come, so remainder 0 also will not come. And product of epsilon is 1, so we'll start with this. And you have the symbols 1 2 3 4, and you can calculate for this to understand. Okay, 1 1's a sorry, 1 on 1 1. From state 1, when you get a 2, the product of 2, that's 2, right? And 3 4, and you are going to the states. Remember that you are going to that particular state also. State numbers also you are giving the same. And from the state 2, you are doing it, right? From the state 2, if you get a 1, what is the meaning of it? Anyone? What are the remainders you should get? If you are coming to the state 2, that's 1 multiply with 2 you got 2, and from 2 whatever you do, you should multiply with the 2. Understand what is happening. From 1 you came to the 2 because you got the product of 2 is the 2, you got the product of 2 is the 2, and from here whatever you get, if you get a 1, 2 multiply with 1, if you get a 2, 2 multiply with 2, 2 multiply with 3, 2 multiply with 4. Understand this point? 2 multiply with 1 is a 2, 2 multiply with 2, 4, 2 multiply with 3, 6, 2 multiply with 4 is a 8, 8 mod 7. Always you should apply mod 7. Here when you apply mod 7 you don't see the effect, but here 2 4 is 8, 8 mod 7 is 1. So 2 4 6 1 it should come. 2 4 6 1. Similarly, when you are applying from the 3, you can just start with the 3 only. I'm just applying with the 3. 3 1 2 3 4 because we have only 4 symbols. 3 1s are 3, 3 2s are 6, 3 3s are 9, 9 mod 7 is 2, 3 4s are 12, 12 mod 7 is 5. So 3 6 2 5. So similarly, can you try from the 4? 4 1s are 4. Directly I'll do now. 4 2s are 8, 8 means 1. 4 3s are 12, 12 means 5. 4 4s are 16, it will be 2. And 5 1s are 5, 5 2s are 10. So when you apply mod 7, it will be 3. 5 3s are 15. 5 4s are 20. 6 1s are 6, 6 2s are 12, 12 means 5. 6 3s are 18, 18 mod 7 is a 4. And 6 4s are 24, the 3. Just cross check, is everything correct? I'm showing exactly what's going to be our machine. Now here you want a remainder 2, so this will be final. And this is what happens. In a sigma star, what other strings are there? And the product means what? On every string when you apply, the product of x, how did they calculate? They have shown for 1 to 4, but you should do for every string. And actually your languages, whenever you get a remainder 2, the string will be in your language. So your string will be like 2 and 1 2 and 2 1, double 3 and double 4 and so on. Now once you got a DFA, is it easy to apply minimization or not? Just check, are there any 2 rows are same? We are already 1 2 3 4 5 6, all are different. So when you look at it, nobody is equivalent to other. In a table itself you can understand you can't minimize it. Why do you take remainder 0? Anyone? Will you ever get a remainder 0? Question is very simple here. Sigma is 1 2 3 4. If you are multiplying only these 4 digits in any order, you will never get a multiple of 7. That is the concept. Everyone, multiple of 7 is 7, 14, 24, 21. Is it possible to prove with them? Can you get a 7 by multiplying these 4 digits only? Can you get a 14 by multiplying any of these 4 digits by repeating or non-repeating? That's why 0 never comes. Because multiple of 7 impossible with this 4 digits. There's a mathematical concept behind why remainder 0 not comes. Okay. Always, the question is always, once you know the solution, it looks very simple. But the way you need to interpret it decides everything. The data that you have seen, right? Sigma is given. X belongs to sigma star. Every question, X belongs to sigma star only if X is your string. They are interpreting to help you in a simple lines, but we make complicated because we assume something else. And product of X is, they mentioned product of symbols. Symbols are 1 2 3 4 only, but you should apply n to you, don't calculate, because epsilon is a very special string. And for example, any X you take, its product nothing but the digits you need to multiply and apply the mod 7. Correct? Now L is defined like that. There are a lot of gate questions so far. Okay. This type of questions you can solve if you are comfortable. There are a lot of gate questions are there similar to this. If you could have done them, this could have been easy for you. It's again I'm saying what will they give? They'll give a sigma. They'll tell you x belongs to sigma star, and they'll apply some f of x. That's like x mod 7, and then they will give you L. Now you need to find minimum DFA for L. This is the order. Many questions are there. I'm telling you again. Sigma will be given. X belongs to sigma star, they will mention, and they'll do some operation like product of x. And they may give you any other name. And L, they will define now what are their strings, how their x is. Like here they mentioned x such that the product of x is equal to 2, and in some places some other definition will come. And minimum DFA for this L, this order is there. Like similar to this order, there are many gate question already. Input symbols are given. Without giving, how do you calculate? Okay. Input symbols should be given. If they give 0 to 9, then all of them will be possible, right? If the sigma is given 0 to 9, like sigma is equal to 0 to 9, then 0 to 6 will happen. Okay. Every time may not be required. Sometimes states also will be sufficient, like DFA also you can design. One of the time they have given like bijective functions. Sigma is given set of bijective functions. We'll see that too. All these questions are recent, so you can predict the similar type of questions in future GATE exam. Some of the patterns are repeating, that's why I am helping you. If any question comes similar to them, please practice and solve them. Again, this is a standard pattern only. Finite automata given, regular expression, all were having similar connection to. Concept is repeating again. Finite automata is given, you need to convert into regular expression. And look at, if it is MCQ, so easy. If it is MSQ, little bit complicated. So first look at, it is MCQ, so only one option is correct. You can eliminate the options. As I said, technique, epsilon 0 1 00 0 1 1 0 up to 2 length would be sufficient initially by looking at options. Now look at your machine. Epsilon accepted, this is epsilon only, right? Accepted. 0 epsilon followed by 0 followed by epsilon accepted. 1 epsilon 1 accepted. 00 epsilon 0 0 accepted. 0 1 epsilon 0 epsilon 1 no. Any other way? Epsilon 0 1 not accepted. Check it once again. 1 0 epsilon 1, you are not able to go that side. From 0 you can come to one side, but from 1 you cannot go to 0 side. 1 epsilon 1 1, you are not able to accept. This is the pattern for your machine. Now look at which options are able to do this. Epsilon, oh, we want it but not able to do it, eliminate. Epsilon, it's able to do it, keep it. 1 is there always, so you can't do it. 0 is there always, so over. Epsilon only deleting this. Really, do you need to put an effort? And I'm not verifying others because epsilon I got all false. B is also false. 0 you are able to do it. 1, oh, 1 you are not able to do it. Somehow this is failing. Okay, when I'm verifying this, blindly I will go to option B because only one left as per MCQ, but this is also wrong because here some stars might be missing, we don't know exactly. So B is also wrong. The reason is when I'm verifying one, I'm not able to prove it. Got it? Okay, what could be the right expression? Because some people want to understand what could be the expression, right? Let's try it. I'm just eliminating the states. I'll eliminate this state 3. I'll eliminate this state 4. I'll look at the machine. 1. I'll go to this side. Epsilon. First I'll keep the 4. I'll later do it. I'll eliminate this. 0 epsilon. That's a 0. 0 0, the self loop, 00, eliminated. Now I'll eliminate this. I'm eliminating this. What things should be covered now? Epsilon 1, it should be 1. And then 1 1, that's a self loop, 11. That's it. Yeah. Now we have two finals, right? Either you will go this side or you will go this side. If you go this side, 1 followed by 11 whole star, or if you go this side, epsilon, no need to write, 0 0 whole star. You can stop there, or that parenthesis we can let. You can stop there, or you taking this, you can stop there also, and you can read this once, or 0 0 whole star followed by 0 followed by 11 whole star. You can understand what happens? This expression is valid. No one is matching to. Okay. Otherwise, you can take 00 star common here, epsilon or 0 followed by 11 whole star. You can also do that. Any of 00 whole star is there in both the paths. So either you can stop there or you can go here. Fine. But when you take epsilon, the B looks like correct. If I am writing the gate exam, I could have chosen the B. After coming out of the exam, B is wrong, then we could challenge it. 2024 set 2 numerical answer type. Have you seen this kind of questions are there? Length kind of question. Again same, length up to 5 is solved. Now length up to 4 length. Length up to 4. What is L1 and L2? L1 is given here. B star A, B star, A, B star, A, B star. When I see this question, I did not click first time. The reason is I did not interpret it. I was only looking at L2. L2 is nothing but set of all strings up to 4 length. A very simple line, up to 4 length, set of all strings over A and B. Now, okay, this is same as what the bar of W is nothing but length of W. Number of strings in L2 which are also in L1. Number of strings in L2 which are also in L1. That means simply L2 intersection L1. Anyone? What is the meaning of it? This represent set of all odd number of A's, right? Set of all strings which are having odd number of A's. Now the intersection when you do, set of all strings up to 4 length and which are odd, which are having odd number of A's. Now you need to identify two things. Up to 4 length we want, and having odd number of edges. Okay, let's start with up to 4 length. How many strings are there which are having odd number of edges? If the length of the string is equal 0, there is no odd here, right? Epsilon, but 0 is. Length of the string is equal 1. We have only one string which is having odd edge. Length of the string is equal to total 4 strings. Among them, AA is not having odd edges, AB is having, BA is having odd edges, and double B is also not having. So here one string, here 2 strings, and length of the string is equal 3. You will see exactly 4 strings at odd number of A's, like 1A, 3 A's. 1A if you keep AB or BA. If you keep 3 A's, oh sorry, 3 length, right? I'm very sorry. A double B, B A B. This is a 1A, right? B B A. And then with 3 A's we have 1. Total 4 strings. The pattern is same. 2 power 3. The 2 power 3 strings are there. So now just you need to do 8 plus 4, 12 plus 2, 14 plus 1, 15. The answer is the 15 strings are there. Right. Actually effort is not needed if you understood. I'm solving slowly so that you will understand each step clearly. अगर आपको डेटा समझ में आया है when you are reading it, you will do very quickly, right? It's not needed even you to write it like 1 length, how many strings are having odd edges, 2 length, 3 length, 4 length. You can get in terms of 2 power. Done? But when you are not able to understand this, maybe not easy to find out all of them, because here you have all strings, here you have the strings which are having odd number of edges. If you don't know, sorry for that, there is a server issue again. 30 questions left, 25 questions left almost. So do you want to do after the break? We'll do as many as possible. Can I do a little bit quickly so that we can shift to other 2 chapters also? Okay. In these 2 kinds of patterns, counting 110 and 011 relation is possible. The reason here, 110 pattern, 011 pattern, other pattern is versus 000 and 111. Out of these 2, which pattern you can design a finite automata? The first one. Second one you cannot. The reason is very simple. If you are getting 4 zeros, you will have 2 times 3 consecutive zeros. But when you are counting 2 times, the 111 is not appeared here. So you need to maintain this 000 for arbitrary count. Even 100 times 3 consecutive zeros comes, you should remember it. And there is no connection with the 111. But when you look at this, 110 is one time happen. If any time see 110, you see 110, definitely 011 also appears. Let me write 110 again. Second time appeared. But you see 011, even though you were not considering, it was there. So the relation between 110 and 011 is so simple. Either both will be equal or one will happen more than other. But the 110 appears 2 times, 011 will never appear. That case will not happen here. If 110 appears 100 times, then other pattern will appear, or either pattern will appear 99 times or 100 times or 101 times. Only one difference will be there. Not only this pattern, when you see the patterns like 1 0 versus 0 1 and 0 0 1 versus 1 0 0, and all these patterns are possible to understand using finite automata. Okay? All these are regular patterns. That's why L1 is regular but not L2. Okay? Yes, we'll have a dinner break, and what time we'll meet back? At 8:40. Please come by at 9 p.m. Let me keep the empty slide. Class will resume at 9 p.m. Yeah, I'll wait for 10 minutes. 9, 10, 9, 5 is fine. Okay, bye. So, worried for the break also. You ready? Please let me know, am I audible to you? तो बहुत सारे लोग क्वेश्चंस पूछ रहा था. In case if you need any tips, I'll discuss with you at the end of the session. शुरुआत में डिस्कस करने से डिले हो सकता प्रैक्टिस, इसलिए मैं वो डिस्कस नहीं करा. I'll definitely take up your questions at the end of the session, ताकि आप जो भी क्वेश्चंस होगा at the end of the प्रैक्टिस में आप पूछ लीजिए. What is W equal to? Length of the string is equal to n. No? Length of the string less than or equal to n. Then DFA has, minimum DFA has n plus 2 states, including trap state. Right? So you are actually writing the wrong answer there. (2010) MCQ 2 marks. Very good question too. Right. What is given, and this is one of the closure property question. And if you practice one of the proof like the substring operation proof, this could be easy to understand. Because if you want to prove substring of regular is regular, you need to understand the proof of the operation, why it is closed. Anyhow, I'll explain. Let W be any string of length n. Just give an example. 0, 1, 1, something like 0, or 0, 1, 1, or 1, 1. Let L be the substrings of W. L is all the substrings of this W. Find all the substrings. You'll get epsilon 0, 1, 0, 1, double 1, 3 length, 0, double 1, triple 1, and 4 length itself. The minimum number of states in non-deterministic finite automata that accepts L. To accept this L, how many minimum states you require in NFA? There was a proof called as, to understand this, you can design this NFA, and the same NFA will help you to accept all the strings of this L. See, to accept epsilon, now you can I don't know what is happening. So let's just saw it. You understood, right, what I'm saying? Right. First, you design an FA for given string. Now you need to accept every part of the string. So what you do, you can start anywhere. If you want to start anywhere, in the string. So everybody accessible to initial state, like you can give epsilon transition from initial state to everyone, so that you can start from any, and you can also end anywhere to accept the part of the string. So from every state you give to the final state to alt final. You can alt final by reading epsilon. I'm not writing anything, means it is epsilon. And now you can look at all the strings. Every string is accepted now. Look at epsilon directly you can accept. 0, you read 0 and go to final. And 1, you can go to here and read 1 and go to final. 0 1, you can read 0 1, go to final. 1 1, you can go to the state and read 1 1 and go to final. Similarly, every string you can accept, and every substring of the given string is accepted here. Now you have epsilon transitions. If you want to eliminate them, you have an algorithm NFA with epsilon transitions to the NFA without epsilon transitions algorithm. You can use that, you will get the same number of states. So answer is n plus 1 states. For 4 length you need 5 states. For n length you require n states. Sorry, n plus 1 states. The concept of this is depends on the substring proof. If anybody designed the machine for the substring of the regular language, the substring proof can help you to understand. You can make all the states are final, not an issue. If you want to apply another way, you may try it. From every state you are going to the final means everybody final indirectly. That's also correct. Another popular model question, which is there almost in every year in some form, either regular form or regular non-regular form or CFL regular relationship. Which of the following is always regular? Here P is given as regular, and Q be context-free language, such that Q is subset of P. Just example they are giving, what is the Q and P relation. Which of the following is always regular? P is regular and Q is CFL, and CFL, that is subset of regular only you have to take. When you do intersection, can you guarantee always regular? This example itself proves that P star Q star intersection P power n Q power n, you will get the P power n Q power n, which is not regular. So you cannot guarantee always regular. From the P, if you delete the Q, when itself, this given example itself will prove non-regular. And sigma star minus P is same as the P complement. And P is already regular, so regular complement is always regular only. The sigma star minus regular is nothing but regular complement. Regular complement is nothing but regular only. We have proved it always regular. The sigma star minus CFL, and that we cannot prove. Even P power n Q power n, if you take an example, sigma star minus P power n Q power n, which is not regular only. Let's see is right. Go ahead. In introduction to theory of computation itself has some of the questions. One of them, just to identify the different expressive power of different machines. Like DFA and NFA, are they having a different expressive power? Check it. They are having equivalent, right? They are having same expressive power. DPDA and NPDA, they have different expressive power. Same expressive power will give you the same class of languages when you collect, and different expressive power will give you different class of languages. Deterministic single tape TM and non-deterministic single tape TM, and here DTM NTM will have the equivalent power, so they are same in expressive power. Single tape TM, multi-tape TM, NTM, DTM, any kind of TM which is going to be equivalent in terms of power. Don't restrict them. Only second option is. Another interesting question which was asked in 2011, and the options are also giving you confusion, like the answer should it be N or K dependent, because see, some of the options are depending on N, some of them are depending on K. What should be it? The question has already clear. K is greater than 0, N is positive integer constant. So who is the constant? N is the constant. Normally we assume K is the constant, but in this data N is the constant. So depends on N, the value keep on changing. So constant, positive integer constant, you can start with 1. What happens to the language? L is equal to A power K, where K greater than 0 means K greater than or equal to 1. And that is equal to A plus, how many states required for A plus? 2 states, right? And the number of states you got here, 2. Similarly, when N is equal to L is equal to A power 2K, where K greater than or equal to 1, which is same as AA whole plus. How many states will take? Minimum 2 A's. Then after that you can take the help of the previous state to maintain the even A's. So 3 states required. And based on this observation, if N is 2, you got a 3. N is 3, you should get a 4. And that is depending on N only. So this one you can write as N plus 1. Right? So independent of K, the answer is going to be N plus 1. You can also try N is equal to 3 when you are not having confidence. Very easy. Like everything is given in front of you. Machine is given and minimum DFA is also given. Just you need to observe it. And it's 2-mark question, and it's eligible for only 1-mark question, but still it happens sometimes. The 1-mark questions will be there in 2-mark, 2-mark questions will be there in 1 mark. So always in GATE exam, you start with the 2 marks so that you will spend more time on 2 marks. And if you are solving, let's say 4 minutes 1-mark question and 4 minutes 2-mark question, you will get more marks with the 2 marks only, correct? So spend more time on 2 marks, or initially better to solve 2-mark questions to get more marks in the GATE. But if you are not having in a sequence, then go as given sequence. If you are preparing for 2027, you can connect with us, on Geeks for Geeks, we have the Connect platform. So go to the Connect platform and you can wait, you can raise a request, or you can send a request. We will be connecting with you. So mostly I'll be there around 5 to 6 p.m. every day. Some days I'm not available. Whenever I'm available, you can catch up me. By looking at itself, what will be combined? These 2 states will be combined because they are having the same kind of behavior, like self loop A comma B, self loop A comma B, both are final. So if you look at this on right, the same you have, and on both A's you are just combining S and T, This exactly looks like after minimization. Okay, if you are not able to understand this option A, then you can easily apply the minimization algorithm either using table approach or using partition sets approach. Go ahead. A, and this is final. Okay. The question is very clear. They want a complement of language, but NFA is given, not a DFA. Remember this point? When NFA is given, please don't interchange finals and non-finals. Finals and non-finals interchanging only you can do for DFA, not for NFA. Okay. Now NFA is given. What is the language accepted by it? You can accept A. You can accept epsilon followed by a square, a power 3 and so on, which is same as a plus. And if you want a complement of L, that is sigma star minus L. What is sigma? A. And what is L? A plus. From A star, when you delete A plus, only one string left, epsilon. So that is nothing but option B. Some are doing switching final non-final. That will not work for NFAs. Okay. That concept is only applicable for DFA. NFA may or may not work, depends on the type of NFA. The concept is very simple. Given NFA, you convert, you get a language and do the complement by looking at the language. Another easy question in the gate, which is given for 2 marks. The reason is you need to verify the strings in the given expression. What is the language? Which of the following strings are in L star? Go ahead and please complete it. We are very near to the end of the first chapter. What is L star? L is equal to AB plus AA plus BAA in expression form if you want, right? L star. So your string could be in any form, any power, like L power 0, L power 1, L power 2. You should do everywhere. Look at that. AB is there already. And then AA is there. BAA, AB, AA. So you should repeat 1, 2, 3, 4, 5. So 5 times when you repeat, you will get that string. Similarly, try further. AA is there. AA is there. BAA and then AA. So if you repeat 4 times, you will get this string. And next BAA, then AA, AB is also there, and AA is there, AA is there. But this B is leave, we are not able to cover, so it's not belongs to L star. And next B double A double A B double A 1 2 3 4. When you repeat 4 times, it will cover. So except 3, every other string is there in L star in some L power. 3 is not able to. So we want which of them are in L star. 1 2 4. That is option C. Most of you are right. One of the interesting question. Maybe I have not seen this kind of question earlier in the GATE, and in 2012 they have asked this question. Maybe you can solve very easily, but they were given a different representation in the options. Normally what you do when you design a finite automata, you always do something like this. P on 0, you will go to some q, and instead of doing that, they have done something else. You can see here the symbols they mentioned in the table. So this q they have kept here, and 0 they have written inside. And now the people gets confused because q is here, sigma is here, and q is here. So the way you should look at this table will change now. Now from 0 0, when you read 1, it will go to 0 0. From 0 0, when you read 0, it will go to 0 1. This way you should read. EFA not visible. Ratio. Wait. Is visible, right? Only the transitions 1 0 0 1 0 0 1. Here it is 1. And all are finals except q. It is the machine, second symbol from ending is 0, third symbol from ending is 0. That kind of machine only. The last 2 symbols, if you track, this kind of machine will be with you. My typist has made this so. Now the question is, first read the question, you should follow that. Consider the set of strings in which every substring of 3 symbols has at most 2 zeros. If you are reading 3 symbols, like you should have at most 2 zeros. You read 3 symbols, you should never see more than 2 zeros. That means either no 0, fine, or 1 0 is also fine, even 2 zeros fine, but you should not have 3 zeros consecutively. Right? Even if you see 0 1 1 1 1 0 1 0 0 0 0 1, all of them are having more, at most 2 zeros. If you look at this, 1 0 0 is fine, but 0 0 is going to fail because it has more than 2 zeros. So there should be no such 3 zeros in every string that you look at. Now all strings of length less than 3 are also in the language, because less than 3 you will never see 3 consecutive zeros. And this is a partially completed DFA. Now you should complete it. Now you can see from 0 0, 0 is missing. When 0 comes, 0 0 0 will definitely have what? 3 zeros. So we should go to trap. After 0 0 1 comes, then last 2 symbols become 0 1. We will go to 1. 0 0 1. You can see 0 0. If 1 comes here, the last 2 symbols are 0 1. Now for 0 0 we have covered. You can see that from 0 0, 0 you should go to trap. From 0 0, 0 you should go to trap. That is a Q, state Q it is. And who is having that? From 0, 0, 0, you are going to Q, the state Q. Here a small q is given, here capital Q is given. Okay, here small q is there. And from 0, 0, here 0 is not mentioned. So when you look at this, the option C is exactly what we need. Remaining all are eliminated, but still we'll check is it correct, because sometimes the typing mistakes could be there. Now for 0, 1 we'll also cover. For 0, 1, on 0 already there, on 1 it will become double 1, right? Because last two symbols are from 0, 1, if you get a 1, last two symbols are double 1. From 0, 1, if you read the 1, you should get double 1. And here, so here the typing mistake already happened, that's why now we should go to B. And anyhow, we'll see remaining two. 1, 0, for 1, 0, 1 is covered. For 0, it should be double 0, right? 1, 0, for 0, it should go to double 0. 0, double 0, and we'll check 1, 1, 0, definitely it is 1, 0. And 0, it goes to 1, 0. From 1, 1, if you get a 0, you go to 1, 0. Got it? Yeah. C is also false because I did not check the remaining. I was thinking this was the right because 0 was not there. It was a mistake by who made this PPT. But question was having a right data. There was no issue with the data. It was typo. Why TOC you will see a lot of even compiler also. Why you will see a lot of mistakes in the gate? Because typing those symbols and verifying them is not easy, because typists may not aware what is exact expression, and for us very difficult without evaluating it. If we don't evaluate, you will see a lot of mistakes in the question itself. Okay, then very limited. See, few closure properties, few undecidability and decidability properties by understanding. Remaining automatically will get in practice. Because many things you are trying to remember, it looks difficult, but half of them you try to understand, half of them automatically will be added. Okay, let me do it, because you see that the difficulty of regular expressions is not much compared to other chapters. So I'll try to complete the remaining questions as quickly as possible. Consider DFA given, and which of the following are false? Complement of L of A is context free. See, L of A is definitely regular, and complement of L of A definitely regular. So this is true only. Language that you have written here, is it matching with this or not? Just check it. What is this basically? 1 followed by 1 star 0 followed by, you can take the two options like 1 1 star 0, or directly you can take a 0 followed by 0 plus 1 whole star. If anybody matches with this, that is also right. It's exactly same 1 1 star 0 or 0 followed by, and definitely this is same as 0 plus 1 whole star only. The 0 star 1 star is there after 0 plus 1 whole star. You can put epsilon always, so you can delete this whenever you want it. They don't need. So this is exactly same, true. For the language accepted by A, for the language accepted by A is the minimal DFA. And if you want to design minimal DFA, what is this problem? Basically, when you take a 0 common, it's a 1 plus, right? 1 plus 0 plus 0, and this is sigma star anyhow. When we take a 0 common, 1 plus 1 plus epsilon, you have a 0, and this you can write as 1 star 0 followed by sigma star. It's a containing zero problem. It is the first zero you are waiting. It's a containing zero problem. And contain zero, you can have just what? Two states, right? You can design, because these two states can be clubbed. One, after getting zero, you can go to final. And this definitely false. For the language accepted by A is not a minimum DFA. False. A accepts all strings over 0, 1 of length at least 2. Okay, I don't know what is written here. At least 2 is definitely wrong. The false. Because 0 length is accepted. And which are going to be false? 3 and 4 is there. There is option D. Let's move on to the next question. The length of the shortest string not in the language over A comma B of the following regular expression is A star B star BA whole star, and it has happened 2 times in the gate. So you can also practice this kind of questions. Now the shortest string not in the language generated by this expression, and shortest string, if you want to identify, you should try 0 length first, then 1 length first, then 2 length first, then 3 length, and so on. So whichever is not there, then take that as the shortest. 0 length, can you generate epsilon? Yes. 1 length, you will have A, B. A you can generate, remaining you can put epsilon. B you can generate, remaining you can put epsilon. You can generate. 2 length, double A you can generate, AB you can generate, BA you can generate, double B also you can generate. And when you go to 3 length, triple A, you can generate AAB, AAB you can generate, ABA, ABA, remaining put epsilon, ABB you can generate, B double A, B double A, remaining you can put epsilon, BAB. B, if you take A, B is not there. If you take this BA, then BA will come again, but not BAB. So 3 length string that we found first, which is not generated by the given expression. In exam, you don't write this. What you do, you take this expression, just look at it. Epsilon, yes. A, yes. B, yes. Double A, AB, BA, BB. You need to verify that without writing all this. But understand which string you are doing every time, the order that you must follow with the systematic approach. And L1 is n greater than 0, which means A plus. L2 is B star. And L1, L2, definitely, because both are regular, and both are regular, concatenation is also regular, is true. And L1 dot L2, you cannot write A power n, B power n. What you can write? L1, L2, even though it was A power n, B power n, but now what you can write? A plus B star, which you can write as different powers, A power m, B power n, where m greater than 0, n greater than or equal to 0. This way you can represent, but you cannot write as this way. So which one of the following is correct? Only one. But we have seen the concept, right? This concept is just languages are given, they are doing concatenation operation. So look at so far, intersection, concatenation, or even reversal, prefix, suffix, substring. These operations were asked so far. Which one of the following is true? A power n, B power n definitely is not regular. So here is given as regular, so false. The language L, A power n, where n is prime, A power prime is not regular, so it is also false. The language where W has 3k plus 1 base, like 1 modulo 3. Some k belongs to n, it is definitely regular. It is true. Where WW such that W belongs to sigma star, where sigma is 0 comma 1, which is regular. Now you can see it is MCQ type, and this sigma is 0 comma 1 mentioned, and W belongs to 0 comma 1 whole star. This WW is not regular, so it is also false. So only one true statement we have, that is C. Good. Not readable, let me know. One. I don't know what is that. Can anyone tell me what is there at Q2 self loop? So comma 1 or sorry, what is the metaphor? Let me know what is the self loop at Q1. Sorry, at Q2. This is Q2, right? This is Q3 and final state. Remaining all are non-final states. So from what is the set of reachable states for the input string 0, 0, 1, 1, and the starting state is not given, so by default Q0 you will take 0, 0, 1, 1. What are the states? Yeah, now it's connected. Can someone? Now it's fine. Can someone found what was it here? What is the actual? Was one? Not aware what is there, but we'll see. Will it impact or not? From Q0, 0 if you want to read, there's only one option that you have, 0. And again 0 you have to read same. There is no other option for you, right? Now 1, 1, either you can read here and finally you can halt there if you want. That's a one way. And otherwise you can alt it even Q1, and this 1, 1 you can read this 2 and you can halt it Q2. Q0 on 1 you can go to Q1, on 1 you can go to Q2. At Q3 it's impossible to reach, even doesn't matter what is here, and Q0, Q1, Q2, they are only possible states where you can halt. Okay, so Q0, Q1, Q2, that is going to be option A. You can also all set Q2 how? 0, 0, 1, 1. Have you seen the importance of even odd number of zeros and ones? So please learn properly even number of zeros, even number of ones, odd number of zeros, odd number of ones, regular expression over the binary strings. Now we got again similar to the previous one, even number of ones. Which one of the regular expression below represents L, which is MCQ? So MCQs, it will be easy to identify, but MSQs only you should understand the each one. And even number of ones, epsilon should be valid, single 0 should be valid because no one, and 00 should be valid, 11 should be valid. Up to 2 length, these are the strings which are valid. Like 1 is 0, 1, 1, 0, they are invalid. The reason is they have odd number of ones. And now first we'll verify the strings. Epsilon you can generate, 0 you can't generate here, you can eliminate. Epsilon you can generate, 0 you can generate, 00, and 11 also you can generate. You keep this. And this one, epsilon you can generate, single 0 you can generate, 00 you can generate, and 11 you are looking for even number of ones, but because of this 1 and 1 star, you can get even odd number of ones. 1 1 1 also you can generate. So this will generate because of 1 star, because 1 star you will never see when you have the condition over like once, right? It can generate even odd number of ones. This one, epsilon itself is failing, so we can eliminate. Option B is going to generate what? Even number of ones, where you can see out of this 2 0 stars 1 is there, and out of this 2 0 stars 1 is there, out of this 2 0 stars 1 is there, and out of this 2 0 stars 1 is there. That's why it's going to give you the right answer. Here why not B is in QT is not there. Subset you can't answer. We want set of all reachable states. Okay, half of the states you can't take. Which is another similar question. So far we practice. Quantity is given, expression is given, you need to match them. A very popular question, right, in TOC. Now what is this problem? I have missed it. Let me check what is this. Ends with 1. So here it is. Final state they have missed. It is ends with 1 machine. They have missed it arrows. Here it should be 1. Here it should be 0. And it should be final state. I guess I'm thinking it is right. It ends with 1 machine. Very easy to observe. You can see ends with 1 machine. You already know ends with 1 over the binary strings. What what is the expression? 0 plus 1 whole star 1. And it is very easy machine for you. It's a very easy expression for you. And that you can easily identify here. But out of this two, which one will be equivalent to this? You know, if you try to simplify this, how can you write 0 star 1, 1 plus 0 plus 1 whole star? If you take a 1 common, 0 star 1, take a 1 common, epsilon plus 0 plus will be there. Star, this will become 0 star 0 star 1 whole star, looks like x star, which will become 0 star 1 whole plus, and this is same as the 3 only. 1 and 3 are same, they're representing the same language, right? That is 1 and 3. The two regular expressions are same. They are left now. Few more. If not visible, let me know. It's a B, A, B. Now we have two machines. You need to identify language of M intersection language of N. For that, the minimum DFA number of states. First, what is this? It ends with A, ends with B, and now very easy to understand what M does, what N does, and what is L of M intersection L of N. L of M is equal to ends with A. You can write sigma star A. L of N is ends with a B, sigma star B. When you do intersection, that is L of M intersection L of N, you will get empty set. And for the empty set, how many minimum states or how many states in minimum DFA? You will have only one, that is प्रीवियस वन एलिमिनेशन ऑफ स्टेट्स चाहिए नहीं, अरे साइकिल है, साइकिल को अगर आप एलिमिनेशन ऑफ स्टेट्स यही रहना है इनिशियल एंड फाइनल, जस्ट यू नीड टू डिलीट दिस एज. व्हेन यू डिलीट दिस एज, this loop you can cover here, or this loop you can cover here. So there are two ways to write an expression. That expression may be there, may not be there. Don't waste the time using the state elimination technique, which is complicated here. Go ahead. Again, identifying concept is very simple. Again, identifying regulars. So many types discussion is there in the exam. Wx w power r, where wx belongs to a plus b whole star, but w and x at least one length. So this will become w comma x belongs to a comma b whole plus only. A plus b or a comma b whole plus. Instead of whole star, you will have now a plus a comma b whole plus, and it is going to be definitely not regular. If it is, this condition is not there, then w comma x belongs to a plus b whole star up to here only given, then it could have been regular. Because of you have put the condition that w is at least one length, x is at least one length, will become not regular. And the condition is it is m not equal to n, where m comma n greater than or equal to 0. And if it is m not equal to n, and you should verify if a power 2 is there, then b power 2 should not be there. A power 100, b power 100 should not be there. So, and what is the power of a is arbitrary, unknown. Then in general you cannot design a DFA for this. It is also not regular. And there's no other condition for this L3. So a power p, b power q, c power r is same as a star, b star, c star, because all the three are independent. So this will definitely regular, this will be regular. And which of the following are regular? You have L2 only, L2 and L3, and option D is L3 only. Okay. So that's the same options are written here. You heard the number of states in minimum DFA that correspond to regular expression 0 plus 1 whole star 1 0. It's nothing but ends with 1 0. How many states ends with 1 0? Minimum string is 1 0. To understand 1 0, you require 3 states and no trap states, so 3 states sufficient. L1 is CFL, but CFL need not be regular now. What is this 4? Who is that? Why L1 is not regular? Anyone? Oh, I'm very sorry. I'm only wrong sometimes. My mind here and there. Where am I? It's regular. Thank you so much. It's the only one which you need to remember, right? W x w power r. My mind went out of the box. This is only the expression when you write all the possible out of this 3. This is only the regular which was asked 2 times the gate so far. But still, when you don't analyze it, there is high probability that you will do the mistake. Now I am just proven that L1 was regular, still I was going wrong. L1 and L3 that are option A now. Good. Thanks for identifying. And I thought it is hundreds of times, but still thinking something else. And we know, right, how that was regular discussed in the regular classes also. not applying mind sometimes. Is done? There's no issue with ends with 1 0, right? Ends with 1 0. This is minimum string. How do you accept? And remaining missing transitions you need to cover. Like 0 comes, you should wait, as you can't remember, you don't need to remember. After 1, if the 1 more comes, you can stay there because you are in right track to end with 1 0. After 1 0, if 0 comes, you should start again to look for 1 0. If 1 comes, you can come to the state and wait for the 0. And this is the motion that ends with 1 0. Can someone try? The grammar. Equality is just like deriving concept. What is given? The set of strings x0, x1 and x2. Everything is about grammar only, right? Where did they mention? Here, corresponding grammar, right? Now here it's simply like x0 derives 1x1, x1 derives 0x1 or 1x2, x2 derives 0x1 or epsilon. Now I'm going to solve. The question is very simple. What is x0? If you want to solve x0, you need x1. If you want x1, you need x2. We'll start from x2. And look at that. We always solve bottom to up. What is x2? x2 is given as 0x1 or epsilon. And as we don't know x1, so we assume this is the final answer. Now x1, while you solve 0x1 where 1, x2 is already solved, so we will put there. And what will you get? 0x1, after 1, 0x1 or epsilon. When you put here, you'll get only 1. Now you can see there is a right recursion. You can easily get a string that is x1 is equal to 0 or 1 0 whole star. The one you will stop with x1, right? And x1 we got this. In case if you want now x2, you can put this in x2, right? You will get the x2 expression, but we don't need x2 expression, so you can ignore it. x0 final answer is 1x1. x1 is already solved, 0 or 1 0 whole star 1, and this is the final answer what we need, right? And which one is it? 1 followed by, is anybody matching? Because sometimes MSQ is there, then you should be careful. Here only MCQ. So which one is going to match? Just check. Starting with 1, ending with 1. 0 or 1 0 whole star. 0 star plus 1 0 whole star. Because I don't know whether it's typo or not, but still, will it get same answer or not? 0 or 1 0. Even I write 0 plus here or 0 star here, still you get the same answer, right? And this 0, if you want epsilon, I can take it from here. Now you can also take it from inside. If you want 0 0, I can repeat twice. Now you can directly go inside, you can get 0 0 there. But this is exactly the same set of strings generated by option C. ये 25 का हो गया ना ऑलरेडी, लेट हो गए क्या आप? Some of the questions already done. AS or BS or epsilon, is it A plus B whole star? Grammar, right linear grammar, right recursive grammar. Which one will be the same as A plus B whole star? This is A star B star. So this is only subset of the language, and here a plus b whole star, and all are wrong, right? All are different concepts. Only D is the right answer. Go ahead. Oh, a decision problem. This is the last topic, but still we can discuss now. No issue at all, because it's a revision for a practice for every topic, right? Which of the following decision problems are undecidable? See, when it comes to decidable, undecidable, the question will become so easy. Remember that question will become so easy. If you have the properties table with you, you can answer very quickly. If you don't have it, you should analyze it. Now, the first one, for given NFS N1 and N2 is intersection of two regular languages is empty. This is a disjointness problem. Remember that two regular languages are given and their intersection is empty or not is a disjointness problem. And this problem is already decidable. We know in the table disjointness, set containment, emptiness, finiteness, totality, equivalence. All the problems are decidable for finite automata or regular languages. So this is decidable. Problem name also I have given CFG and a string x belongs to sigma star, does x belongs to L of G. That means is that x generated by the language of the context-free grammar. So it's nothing but membership problem for context-free languages. Membership problem for CFLs is decidable. You have a CYK algorithm for this. And this is equivalence problem for CFLs. Equivalence problem is undecidable for CFLs. It is undecidable. We want undecidable problems only. So this problem is undecidable so far. And emptiness with a given Turing machine accepts nothing. That's called as emptiness. Emptiness problem for a TM is undecidable. So 3 and 4 are undecidable. And what I recommend, if you have a time, attend the live. If you don't have the time, attend the recorded. That's what always happens. Those people who don't get the time, like those college goers and jobbers, what they do basically, they go with the recorded lectures. When you are having much time, then attend PYQs, because attend live sessions. Live sessions will give you what more interesting. You can ask more doubt and you can look at others, what they are answering, what are you answering, right? Are you able to understand the question in a given time or not? While I'm reading the question and explaining it, if you are able to understand, that means you are in right track. But if you are not able to understand even after explanation of all these things, that means you are lacking with the basics, right? Both are two different columns. PDA and DPDA, both are different columns in table. Second and third column in the decision properties table allotted for DCFLs and CFLs. Another interesting question. I've seen a lot of questions, they interpret in different way. A set of all binary strings having 2 consecutive zeros and 2 consecutive ones. Okay, here 2 consecutive zeros followed by 2 consecutive ones means 0011. But now this is not given to you. This means 2 consecutive zeros followed by 2 consecutive ones. But here they did not mention followed by, they mention and, means both are present, 00 and 11. Which order we don't know. So 00 might be here, 11 might be here, 11 might be here, 00. And in your string, this kind of appearance will be there. If it is your string, somewhere 00, somewhere 11 is there, but who will come first, will come later, that depends on the type of string, that depends on the string. Now, which one is going to match with this? If you look at this option, containing 0011, containing 1100, you are demanding both are there, but you are demanding both are there one after other. So that's not said here. 00 is there, 11 is there, but they need not be. Like if I say 00 1 0 1 1, and 00 here is there here, and 11 is there here, and this string is not covered here at all, because you are demanding 0011 as together, and it looks complicated. We'll see that later. This one is containing 00 or containing 11, but they didn't mention or, they mentioned and this one starting with 00 and ending with 11, or starting with 11 or ending with 00, but this is not start sense problem. Now when you look at this here, assume that is a sigma star, easy to analyze, 00 sigma star 11 or 11 sigma star 00 sigma star. Then when you apply sigma star from both the sides, here you will see properly sigma star 00 sigma star 11 sigma star 11 sigma star 00 sigma star, and is exactly what we are looking for, right? Containing both 00 and 11 in the given string. Okay. Again, number of states in a minimum DFA. What is given to you? What is the meaning of it? Is it same as 0 plus 1 whole plus only? When it is whole plus, you will require just 2 states, right? Very easy problem. Just only 3 problems are there. People are answering 3. Is it 3? 0 plus 1 plus, it's only 2 states, right? Why it is 3? Anybody tried this? If all states of NFA are final states, then the language accepted by NFA is sigma star. No need to be right. If I take something like this, okay, now see all the states are final. That doesn't mean A star, right? Sigma star is not guaranteed. So this will be failing. There exists a regular language A such that for all the languages B, can you prove A intersection B is regular? Can you find some A? Some A you have to find that some regular. And when you do intersection with any B, result has to be regular. Always regular. Can you prove that? Any, every that you, right? Every B you can write, or any, but understand every. Some regular, can I do that? If I take a pi, you put any B here, the result is always pi or not? When it is pi, that means we found some A which can prove always the A intersection B is regular. This statement is true. Which one of the following is correct? Only the second point. Okay, if they ask for every regular language here, then we can't prove this. So that's what, when you are going for MSQs, especially you will see this kind of the sentences which you need to identify. Very easy. Second symbol from ending is B, right? Second symbol from ending is B. And 2 square states required for minimum DFA. If it is NFA, you just need 2 plus 1, 3 states required. It just takes seconds to solve this kind of questions. In case if you see questions that we already did in the class, you just do it like ends with BA or BB problem. Ends with BA, B followed by B. And just you need to cover the missing transitions, like here A, what should I do? Here A, what should I do? Here B, what should I do? That we have done in the regular classes also. The same 4 states will be enough. G is a grammar. You have the grammar with 5 productions. Which of the following strings not generated? If we look at the grammar, you may have see equal number of A's and B's, and this one is special where you can get any number of A's by looking at it. So A's can be more, but B's will never be more. And the question is MCQ, which is not generated only, you have to look at. So is anybody having more B's? Just cross check. If you see here, it's impossible. More A's is fine. Equal is also fine. And more A's is fine. But here you have more B's, but more B's is not possible to generate. Here more A's you can generate. Here equal, here equal. So more B's concept is not there in this. So this is only string which is not possible. Using trick you can identify. With this we have completed the regular languages. Now what did you observe the regular languages? Let me conclude it because concept is important, right? Concept 1. Have you seen finite automata is given and you need to identify regular expression. You can use the elimination technique or you can use algorithm, that's a state elimination technique. Other one is option elimination technique. Second, what is other pattern we have observed apart from finite automata? NFA is given and they may ask you extended transition from any state for any W. What will happen? We have observed multiple times. And finite automata is given and they can also ask a language identified. What is the language? Not only regular expression, they can also ask a set definition for the given finite automata. And likewise, you can observe all the concepts that we have discussed so far, like regarding regular grammar, regarding tables, regarding minimization concept, and many questions we have seen, and identify the patterns. We have completed the lecture chapter 1. We'll move to the chapter 2 after the break. How much time you need a break? Closure properties. You learn a lot, right? Identifying regulars. I'm not writing all of them, but you can write all of them and practice more. we'll start here. Anybody is not joined in my Telegram groups, you can join where you can LinkedIn and a Telegram group. So I will share the PDF in my Telegram group also. You can download from there. So what time will it now? It's 10:30, 10:45. Fresh break. 10:45 p.m. We'll start the session. We'll resume. Yeah. How to remember? Okay, you can ask me at the end. I'll just explain. You need to understand the properties. Like remember or understand the algorithms for all the important operations. Then automatically will remember. I'll make you practice the important operations at the end of the session. In your Maha Marathon is there, right? That revision sessions. There I will help you how to remember also. If they always going to the same, otherwise you can build a table, you will get the rows, right? If the two rows are same, you can club them. Both are finals, both are going to the same states, you can merge them, right? Or you can apply the algorithm. Yeah, it happens. Forgetting is the common property of the human being, right? When you don't practice regularly, there is high probability that you will forget. Connection is very important. Are we ready to begin the next one? Again, it's identifying the language type, correct? Previously, identifying regular or non-regular was there. Now, identifying CFL, DCFL, not CFL, not DCFL, this kind of questions will be asked in exam. So, अब L जो है A star union A power n, B power n, where n greater than 0, correct? So I can write as L is equal to A star union A power n, B power n, where n greater than 0 or greater than or equal to 1. It is given to you. L is deterministic context free. How this can be deterministic context free? Because first A's, what you do, you push. Directly end happens, what do? You accept. If the B's comes, then you start popping the A's, and at the end of the input, you should have Z0 on the top of the stack. This is how you can understand deterministically without any doubt. And remember, many people looks for the shortcut to identify. There is no shortcut. You understand how you operate this stack. If there is no confusion to operate the stack deterministically you are able to do, then that is DCFL. Right. So now L is DCFL, it's true. L is context free but not. If it is already DCFL, you cannot say not DCFL, right? If it is DCFL, no doubt CFL, but you cannot say not DCFL. Because of this not, we'll say it is false. L is not LLK for any K. If you look at this two, if you want to generate these two kinds of strings, now can you write LLK grammar for this? LLK means you should not have the common prefix. And here the strings are different, here the strings are different. To generate this, you need a different production. To generate this string, you need a different production. Like if I start to generate this, I need A, and to generate this, I may need a B. From this A, beginning you will see definitely A's. From this B also you will see A's. Because here also A's are there, here also A's are there. So common prefix you will find always to generate this language. So L is definitely not LK language for any K, going to be true. And you need to identify the true statements. This LLK grammar is there in compiler, but TOC, once you study entire syllabus, doesn't matter operating system comes in TOC or TOC question comes in algorithms, all you have to solve it. Now 1 and 3 are going to be correct. It's almost 6 hours, and then in 5 hours we have covered much content, the first topic, and we'll see how much we can cover today. And there's only one PYQ session. We will try to complete as much as possible, remaining that you try on your own. And if you reply very quickly, we'll answer very quickly, right? अगर आपको जल्दी कंप्लीट करना है तो जल्दी रिप्लाई कर लीजिए, विल गो फास्ट. L1 is WW where W belongs to A plus B whole star. L2 is A's and B's equal followed by the any number of C's. Here any number of A's followed by B's and C's are equal. Which of the following statements in exam, don't waste the time to understand them. First look at what you need to do. Are you going for regulars? Are you going for context free? Are you going for deterministic? Based on that you analyze it. So this is a trick for the exam point of view. Do not analyze the languages first. The reason is, look at the options what what they want it. If they don't want what is L1, sometimes they ask L1 and L2. Then no need to understand what is L1, right? Now you need to identify the false. L1 is not context free. Now you need to know is it context free or not. But L2 and L3 are DCFLs. Now we should know L2, L3 DCFL or not. But if you look at all the options, they are talking about context free and deterministic context free. Now understand, the L1 is not a CFL, but its complement, if anybody does L1 complement, is definitely CFL. It's a very popular language WW where W belongs to A plus B whole star. As it is not in the stack order, whatever the W symbols are there, you are not going to maintain the stack order. So if you have a memory, you require a memory, but it is not in stack order, so definitely PDA cannot solve it. Now here only A's and B's are equal, C's anything, A's anything, B's and C's are equal, both are DCFLs. Deterministically you can do push A, for B pop A, and C's you can ignore or skip. And now false one, L1 is context free. L1 is not context free. This is a true. But L2, L3 are DCFL. This is also true. And overall, if you look at this, option A is a true statement. Now, option B, L1 is not context free. L2 is also not context free. Here, L2 is not context free. You are saying that's why this is a false statement. Half of the statement only true. L2, L3, they are context free because DCFL, and their intersection is context free. Look at their intersection. What is the intersection of these two? Here A is B is equal, here B is equal. Overall, L2 intersection L3 will be all the three are equal. And this is not a context free. Because of this, the entire statement is false. And L1 and also its complement are not context free, because neither L1 nor its complement is context free. If you look at L1, it's not context free, but L1 complement is CFL. So D also false. Only the first option is true, remaining all options are false. Okay. After the first chapter, if you face any kind of questions, then that kind will be similar to this one. And mostly if you want to prepare from the second chapter, focus more on this kind of questions like identifying the CFLs and applying some of the union, intersection, complement operations. Okay. It's a recent GATE question. You see that again the grammar is given and they're talking about NA, that's number of A's, number of B's, number of C's, denote the number of times they occur. Which one of the following statements are true over the A's and B's? The grammar is given AS or AS, BS or C. They're talking about W, which is generated by the grammar, and what relation that maintains here. It is MSQ, so many statements could be true. Okay, please analyze the strings. What strings you can generate here? C you can generate, AC you can generate, AC, BC you can generate, and if you put on A, S if you put again, AAC will also come. Even AAAC also comes. And after A, if you put here, what happens? A, C, B, C. And likewise, many strings are there. Whenever you see A's and B's, look at that. Whenever you see A's and B's, will this relation always satisfy number of A's greater than number of B's? Is there any time that B's can come without A's? No, right? And this statement is going to be true, but not all the time. If you see here, A's and B's are equal, but here you are saying A is greater than B's. Whenever you take this, then only this will happen. If you don't take this, A's and B's equal, and S you can put with the C. Here this condition fails. But even C also, this condition fails. So when you take the C, number of A's equal to B's happens. So this is going to fail. Similarly, you just look at the strings and verify it. Number of A's greater than number of C's minus 2. So apply everywhere. Number of A's 0, which is greater than number of C's 1. 1 minus 2 is minus 1. So 0 greater than 1. And apply here. Both are equal. So 1 greater than 1 minus 2. 1 greater than minus 1. Perfectly right. AC, BC. And how many A's? 1A. How many C's? 2. 2 minus 2, 0. So 1 definitely greater than 0. And look at all the options like 2A's, 1C. 2 greater than 1 minus 2, 3 greater than 1 minus 2, and here 2A's, 2C's, 2 greater than 2 minus 2, and it is going to be true for all the strings. We checked some of the strings here. The property is satisfied. MSQ, right? And number of C's equal to number of B's plus 1. Is it always? Here no B, so C is there, definitely true. If you look at the C's, number of C's 2 and number of B's 1. So 1 plus 1, 2. Here number of C's only 1 happening. Here number of C's 2 and 1B. Is it true that whenever you see 1B that represent the 2 C's will happen? If you have 1B, this 2S should end with definitely C's only. So whenever you take this, then B and C's will have a connection. This S, even though you take this, again this has to end with C. So somehow every time you take this, every B will give you the 2 C's, correct? And if you substitute one more time this S with, let's say, AS, BS, now this time this B will give you 2 C's, and earlier we have already 1 C. Now you can understand this relation also holds. And number of B's multiplied with 2 is equal to C. Is this true? And let's take number of B's here, where you have 0. 0 multiplied with 2 is 0, but number of C's is 1 here. So this relation is not satisfied, even single C will fail. So B and C are going to be. And it is just one way. In the strings, these 4 properties given, which properties are satisfied in the strings? (2025) question. I'm sorry, this is a compiler question. So I'm ignoring right now as we don't need to solve a compiler question here. I'll be covering it in TOC. Go for this. G1, G2, 2 context-free grammars, and R is a regular expression. For the grammar G, L of G denotes the language generated by G. Which one among the following questions is decidable? It's the last chapter, but still we'll do here. Decidable. L1, L2 or CF, you can say L of G1, L of G2 are CFLs, and L of R is regular language. 2 CFLs is the CFL and CFL. You're talking about equivalence. Equivalence problem is undecidable as we don't have the algorithm. It is undecidable. We need to choose a decidable only. This is undecidable. intersection of two CFLs is empty. It's a disjoint problem, right? First intersection of two CFLs, we get always CSL, maybe it may not be CFL, and emptiness for CSL is already undecidable. So it's, you can also call as the disjointness for the CFLs. And now this is a CFL, this is a regular language, and with the given CFL the same as given regular, that we have no algorithm to decide, it is undecidable again. It's just like I will give you finite automata, I will give you PDA, are they equivalent or not? So for that you don't have any algorithm. And emptiness of the CFL, emptiness for the PDA or CFL is decidable. You have a simplification of context-free grammar. So given context-free grammar, you can simplify if you have at least one production. So definitely it is generating non-empty language. So this is decidable. Emptiness, finiteness, membership, halting, these problems are decidable for context-free languages. Okay. Which one of the following languages is accepted by DPDA? You can see which is going to be the right one. Any context-free language, every context-free language you can't. Any language accepted by non-deterministic PDA same as any CFL. These two are same statements. Any decidable means any recursive language that we can't. So only which one? Every regular language is going to be. Every regular language has the DPDA. So we can always design a DPDA to accept a regular language. Very easy statement. It's given for 1 mark in this year itself. All these are 2025 gate questions only. We've seen the CFLs is going to be in set 1, set 2. We have both sets, right? Here and there you will see 1 or 2 marks. Again, we have 2 languages. You need to identify are they CFL or not. Here you can see A power M, B power N, A power M, B power M, C power M plus N. And when you look at this, what is the relation that you are holding? A's and B's must be equal, and whatever the count you see for the A's and B's, the C's count has to be greater or equal to B's count, or you can say A's count, because the C is depending on B's and A's indirectly. And if you push A's, if you pop A's for the B's, C's will lose the connection. Example, if you have A power 100, then B power 100 will be there. C power at least 100 should be there, because plus N will create 0 or more concept. Now here A's, B's and their sum should be equal to C's. So what you can do, you can push X for A, then X for B, then X has to be equal to the number of C's. So every C you can pop the X. It is in fact a DCFL2. And this one, not CFL. And which one of the following statement is correct? The L2. L1 is not CFL, but L2 is a CFL. It's MCQ, so only one definitely right. L1 is a not CFL, but L2 is DCFL, we know, so you can call it as CFL also. Yeah, L1 is, we can also call context sensitive language. Another 2025 gate question for you. You have given a G and they are asking about language. Can you find the language? What B does? B plus. What A does, A plus. And now what is your language? A, B is B plus, union, capital A is A plus, B square. So now which one is going to match? It is A square, B plus, union, A plus B square. Where is it? A square B plus, A plus B square. This is what we are looking for, right? Is there anybody else matching here? No, right? Yeah. So only option A. So easy. Okay. In this chapter, just you need to identify, and for learning it may take time, but once you learn, it's very easy to identify. There's another easy question which you need to find in Chomsky normal form. In CNF, we have a concept CNF and GNF. Here for n-length string, two n minus 1 steps will take in CNF. In GNF, for n-length string, in exam don't prove it as you have less time, n steps you will take. Now it's about the Chomsky normal form, so you will apply this concept, and here you want to derive these are 90 length string, right? A power 30, B power 30, C power 30, which is nothing but 90 length string, 30 followed by 30 followed by 30 length, 90 length. So you will get here 90 multiply with 2 minus 1, which is same as 180 minus 1 is equal to 179 steps will take. One of the easy question in the exam too. It's a second last, like last year gate question. Looks very big, but analysis takes less time. I think they missed. Okay, I think it's missed. Can you read question? If anybody knows PDA definition, there mostly PDA definition is given, but the PDA accepts by empty stack mechanism is mentioned. This is just like a symbol, which is a bottom symbol, which is also similar to Z0 only. Let's read this question once. Consider PDA which runs on the input alphabet A's and B's as a stack alphabet. This A is a symbol that you will push for somebody. It's just like a Z0 bottom symbol, and has three states S, P, Q, which is mentioned there. With S is a start state, a transition from state U to state V labeled as, look at that, state U to state V labeled as C, X and gamma. C is an input symbol, X is a stack symbol, and gamma is a string of stack symbols. Normally the same definition we follow, but the three parameters they use a slash, we may use the comma, arrow, something like that. Represent the fact that in state U, the PDA can read C from the input with X on the top of its stack, pop X from the stack, push in the string gamma on the stack and go to the state V. In the initial configuration, the stack has only the symbol bottom. Now you can observe what is given here. A, initially you can look at this bottom and A is pushed here, right? Here A was the top of the stack, now A extra pushed because double A is there. Now here what is happening in this, you are going to push A. When the small a comes, when the input is A, you are going to push A, correct? And here when input is B, you are popping the A. Here we are popping the capital A, but for input B. And this epsilon represent, without reading input, you are popping the A. Pop A even without reading any input. And this one, pop A by reading a B. and this one, you right, sometimes buffering, and pop A without reading. And what is the meaning of this? This is pop A without reading input. There's a pop bottom of the stack without reading input. Now the question is, where is the option? Which one of the following options correctly describes the language accepted by the P? Same question, right? Now we have the options here. Before going to the options, we'll just understand it is using empty stack mechanism. At the end of the input, the stack should be made empty. So for which strings we can make the empty, you can read the transitions. You can push the A's, pop the A's, pop the A's, and now without reading input, that if A's are more, then without reading the input, you can pop the capital A, and same we can pop the capital A. At the end, you will see Z0 will pop A. So when you come this path, the A's can be greater than B's. So A power M, B power N, where M can be greater than, of course, equality will not happen because at least one A should be there on the stack after reading the B's, because B's we are not reading here. M greater than N will happen. Only A's can you accept that I am trying. A's you will push without reading. You can pop the A's and you can come here. So only A's can happen. And in this path, this will be there. And anything else that you have apart from this? Only A's is also covered here. Only B's will never happen here. That's all. If N is equal to 0, then only A's will also be here. Epsilon, will it accept? Impossible, right? Epsilon. See, at least one A should be there in the stack. You don't want to read and come and make the stack is empty. If you want to pop the bottom of the stack, they should come here somehow. Which one will match here? M greater than N. This one, M greater than N, where M is greater than or equal 1, no doubt. When N is equal to 0, obviously M is greater than or equal 1, right? So that's option A. Very easy, but the thing is you should understand every transition. That's it. I did nothing, right? Even I did not read one string also. You can just understand by flow, how do you pop, how do you push, then it's easy to understand what's happening. Okay. In GATE 2023, grammar is given and just you need to identify what strings it will accept or what is the language represented by the grammar. You know what is X here? AX, XB, A or B. We practiced, right? X is equal to here, the A star, B star, and this X will end with either A or B. If you want only A's, you can cover here. If you want only B's, you can cover. If you want both of them, you can cover using this two recursive productions. And this X, when you put here, what happens for the language? Language is equal to A power N, B power N. That X you will write here, but X already we computed. That is A power N, B power N, A star, B star, in between A or B. Now this N you can eliminate because A star, B star can dominate that N. Is even if you see when you put N is equal to 0, that A star and B star can cover everything which you want, equal or not equal, both can be happening. So you can simply assume A star, A plus B, B star, and which is going to match with your the option B. And you can see it is MCQ only, but if it is MSQ, you are getting doubt. The language generated by G is not a regular language. It is actually regular language. When you look at here, A power and B power N looks like not regular, but when you understand by substituting values of N, you will get the regular concept. Can you solve the questions of the second chapter on your own? Some of the questions you have seen, right? Similarly, just identifying the languages. Can we go to the last chapter directly? Because I'll go to the Turing machine undecidability questions. I'll wind up the POC in case if you are okay with this chapter, because most of you are pointing out like they're not able to remember undecidability and decision properties. Answer it, but also let me know whether will you do remaining questions or not. Remaining questions will be shared. The intersection of two regular languages is regular. It is true statement. So we will pick. The intersection of two CFLs need not be context free. Here if you see need not be context free, this could have been correct statement. So it is false. Intersection of two recursive languages is recursive. That means intersection of two decidable languages is decidable, because union, intersection, complement are closed for recursive languages. The intersection of two RELs is also REL. It is also true, because union, intersection both are closed for RELs. Okay. Done. Go ahead. I'll keep solving till I have the patience. We'll focus on the last chapter after this. We'll solve more questions there if you need. And how many of you know this is when you put n is equal 0, it will cover a plus b whole star all the strings, correct? When you put n is equal 1, a followed by a plus b whole star, a union a square, that w followed by a square, and if you do it, which is same as the a plus b whole star only now, it is regular in fact. And the second one, just now we seen, right? It's just repeated question, right? Wx w power r, where w comma x belongs to a plus b whole plus, it is also regular. Have you seen that same data repeated? And which of the following are true? Both are regular, true. Both are CFL, true, because every regular is CFL. L1 is regular and L2 is CFL, that is also true. L1 and L2 are context free but not regular. Context free is right, but don't say not regular. That's why this statement is false. It is MSQ type. Even though both are regular, can choose other options because both are CFL. You can call one is regular, other is CFL, because every regular is CFL too. Done? Just repeating concept. As I said, right, this kind of questions are very important, which is given to you again. So which of the following are context free? And identify each pattern, understand, is there any possibility of not CFL? Now you have something to push, and reverse you need to pop, and reverse we need to pop. So you have the connection between them. So non-deterministically you can understand, as you don't have the marker to identify difference between W and X, correct? So non-deterministically you can understand it. So it is CFL. And it is already a regular language. Every regular is CFL. And this W when you push, X when you push, but W power R wants bottom of the stack, so you will lose the connection, the X power R, because if without popping the X, W power R cannot understand the W. If you delete the X from the stack, then X power R will lose the connection. So this is a not CFL. And here push and pop immediately. When you get a Z0, push and pop immediately. But it's a non-deterministically you can do, because you don't know how many symbols you will push, and when you start pop, these things is non-deterministic here. Anyhow, it is CFL but not a DCFL. Now the question is about CFL. So A is a CFL, B is a CFL, and D is a CFL. At the end of the input, if the capital A is there, keep there and go to final. This will demand that this A's are more than the B's. Without A on the stack, you can't go. This indicates A's can be more than the B's. You can see again, A's can be more than B's. From initial to there, if you want to go to final, see, I can go here without doing anything, but without A, I can't. So without B, is it possible? Like only A's can I? Only A's can I? Check here again. A's I push capital A and I'll jump. I did not get a B. I can go to final. Correct? Is it buffering? Just check, is this motion given correctly here? Once. Now fine. Can someone check this PDA? Is it drawn properly as like exact gate PYQ? If any symbol mismatch, then our answer definitely going to be different. I'm just reading the machine. Now what is mentioned here? Without reading anything, just push hash. Do nothing here, right? By reading small a, you push A. Without doing anything, jump here. By reading B, you pop the A. And when end of the input, this represents end of the input. How you know it? Because there is no transition here. End of input, the top of the stack should be A, which represent A's more than the B's, no doubt. Okay. So if you look at previous one, A power M, B power N, where M greater than N, is it the same motion or not? Only A's can come as per the data. You can go to final. The question यहाँ पर है, the number of strings of length 100 accepted by length 100 only. 100 length, how many strings are accepted? The language you are very clear. A power M, B power N, where M greater than N. Now how many 100 lengths are there? Anyone? Okay, let's start with N is equal to 0. When you put N is equal to 0, what do you get here? A power 100. Will it be 100 length? I want only 100 length. Remember that? When I put N is equal to 1, B power 1, A power 99. N is equal to B power 2, A power 99. And likewise, N is equal to, let's take 50, or 50, no, 49 will take. When you take 49, here B power 49 will be there, A power 51 will be there, because you need 100 length, right? Now N is equal to 50 you can't take because both will be equal. Now total 0 to 49, how many strings are there? Did I miss anything? Equal is possible. Something is missing, I feel, because I'm getting less number of strings based on this data. Yeah, based on this machine, you are getting a 50 only, correct? 0 to 49. Just check, is there anything missing in the data? Because I always follow the data, I don't remember the PYQs. Somebody answer 51, somebody answer 98. Okay. If any change in the data, please solve according to the given motion. But this motion is very clear. You push A as many as you want for the small a's and jump here. For every B you pop the A. At the end of the input, the A should be there on the stack. It means that A's are definitely greater than the B's, right? If this is not going to happen, you can't reach the final. Question correct? A power 50 will not happen, because if I take 100 length, A power 50, then B power impossible to take because you need 100 length. Great. You got the 50 strings. Only the thing is, understand the finite, understand the PD. Right? There is nothing mentioned here. You just need a flow, like how to understand this transition. In the previous one, they mentioned everything is slash. Sometimes they'll mention comma only instead of slash. Everywhere they mention comma. It's their notation. You can just follow based on their understanding. Go ahead, another question. See how many context-free languages are there identification? Previous one not able to understand. Should I repeat one more time? The question is very simple. Are you able to understand this finite automata? If you can't, then you can't do it. Then this motion is very clear. From Q0, without reading anything, without looking anything, push hash. We did it. There's nothing to do with the hash, correct? From here, for A, without reading, without looking at the stack, push A. Every A, push 1A. And just jump here. Don't read, don't look at, do nothing. Just jump here. For every input B, pop the A. And understand, here push A for A, pop A for B. And now at the end of the input, the stack should contain a capital E. How many capitals we don't know. Then you go to final. When will this happen? See, epsilon, impossible to accept because there is no way to reach final without that A on the stack. Single A is accepted because for single A, you push hash first. What do? You push hash first, and then for A, you push capital A. For A, you push capital A and just go to Q2 because there is nothing after A. Without, there is nothing after A, and A is on the stack. At the end of the input, A is on the stack, then go to final. So A is accepted. Double A will accept same. For each A, it will push double A and it will come here and it will go to final because after double A is nothing. And double A B will accept. How? Double A it will push, thus capital A will push, and 1B will pop 1A, that's one capital A, and at the end of the input you will definitely see capital A because this A has already pushed 1A. So this is also accepted. The language is the more A's than the B's. When A is followed by B's, more A's than B's will happen. That's all the motion. This will guarantee number of A's more. This will guarantee number of A's more. You can watch the video one more time, right? You will get it. Rather than forcing me to explain again, it's better to watch the video of those questions you don't understand. Which one of the following is true? Okay, first, have you understood what is it? 𝐻𝐸𝐬𝐸. Okay, this is only repeating now. Like normally we repeat W, here X is repeated. So when X is repeated, is the same as when you put that X is one length, what happens? WA, YA or WB, YB. Will it cover everything where W and Y are 0 plus 1 whole plus? Now put any X that is already covered by X is equal to A or B. So this is same as that sigma plus A, sigma plus A. In fact, it is regular language, right? It is regular. Writing here. Here you need to put minimum X because X is repeated, not W and not Y. And the second one, XY, where XY belongs to A plus B whole star, length of X is equal to length of 5, but X is not equal to Y. And is anybody studied the concept of WW complement? If you study it, and every even length, if you want to prove that X and Y, where X, Y are both same length, but they are not equal to. So that is covered by this concept only. Anyone? What is that L2? This L2 is CFL. It's a very interesting concept which is covered in complement of WW kind of thing. L1 is context free. Oh, what is context free? L1 is regular, right? Which one of the following is true? There is a third language. Third language is missing. Oh, I'm sorry. What is the third language? Something else is there. Third language. It's not given from here. Yeah, it happens sometimes. Not option. This options not belongs to here. Okay. Okay. Leave this options because they are talking about even L3 also. Leave this. L1 is regular and L2 is CFL, whichever it matches, and pick the options. You may find out GATE 2020 what are the options are there. Go ahead. It happened maybe while typing, even I did not check that. Consider the languages L1, L2, L3 as given below. PQ and belongs to N, so P and Q are independent, which is definitely regular. If N starts from 1, 0 plus 1 plus, it is definitely regular expression, so regular language. 0 power P, 1 power Q, PQ belongs to N and P equal to Q. So both are same. Zeros you can push, 1 you can pop the zeros. At the end of the input, it should be top of the stack should have the Z0. In fact, it is a DCFL, but not regular. L3, so these options were copied there, correct? If you see, these options are only there, correct? I think could have been something else. L3, 0 power P, 1 power Q, 0 power R, where PQR belongs to naturals, P equal to Q equal to R, it is context sensitive language because all the three should be equal. Now we have the concept, but always look at the option and identify it. Which of the following is not true? PDA can be used to recognize L1 and L2. That's true, right? So don't pick. L1 is the regular language. That is also true. All the three languages are context free. Wrong, right? So it is the false. It's not correct. Turing machine can be used to recognize all the three languages. Yes, Turing machine is a very powerful machine. You can understand regular, DCFL, CFL too. And it is MCQ, so we already got the answer for 2 marks. Go ahead. Which one of the following languages is not context free? Look at always clearly mentioned not context free. The first one, set of all even length palindromes, CFL but not DCFL. Now what is the meaning of this? W, you will push, even A also you can push, but the reverse, when will it begin, we don't know, and that should match with before the A's, and B should match with here. But when all the symbols, if you are matching with this, the A's you are going to lose, but then B's you cannot compare with the A's. It means you don't have the logic using stack, so it's not CFL. Now we look at, is there any other language? Here I belongs to n, 3n, 5n. So I is going to be n or 3n or 5n. It could be like this: a power n, b power n, union a power n, b power 3n, union a power n, b power 5n. And this is a CFL because you can generate using one set of productions, second other set of productions. You can even write a context free grammar too. It's a CFL. And this one you have together, right? You push everything. When B comes, you can see that non-deterministically you can pop with them. You can pop with them because all of them going to match if it is in the exactly same form. It's the non-deterministic CFL. Now the question is, which of the following is not CFL? That is the second option. Yes, CFL you can write even not DCFL, not regular. All are correct, no? Go ahead. It's another interesting question. 2018 2-mark question it is. And this kind of questions you are able to understand. If you are able to understand, then you will get a grip on the CFLs. You will understand the stack logic. You will understand the PDA construction. So many are there. Should I leave the remaining questions to you in this chapter? Because many of them I have already solved in the even last year PYQs also. In case if you get it out, you can do them too. Can we go to the last topic? It's already getting nearly 7 hours. So in next 2 hours, I'll complete the topic. Question is also missing. Which of the following are CFLs, or which of them are CFLs? I think. Identify who are CFLs. Yeah, that's it. Okay. M plus P is equal to N plus Q. These are opposite side. So what you do, you will push A. For B, you will pop the A. Remaining B's, you will push it. Right? There are many ways here to do this logic. And C comes, if here already A's are left on the stack, you will push a C's. But if B's are there, you will pop the B's. So it depends on what symbol, how many you have it. It is, you are having the logic, so it is CFL. And M is equal to N. These two you need to be checking. These two. Very easy to check. B's, you pop the A's. For D's, you pop the C's. So first push the A, pop the A's, push C, pop D. It is also CFL. In fact, even DCFL also. Here, this two you have to check. This two you have to check. M equal to N, P not equal to Q. Even this is also CFL. You can check equal, not equal, any condition between two symbols, like equal, not equal. Mn, the multiplication is not possible in stack logic because Mn can give you any value, and that value you have to check sum of this. Right? Sum means you can do it very easily one after the other because number of C's, number of D's you can compare with somebody. But how do you get M multiply with N? That many symbols on the stack? We don't have any logic. Right? Not CFL. So which are CFLs? Is it CFLs or DCFLs? Even options are not matching here, right? Can someone check about? Okay, leave that question again. Just look at the question carefully. If it is DCFLs, definitely 2 and 3. There's no 3 options, right? Is asking. You got the answers, right? These 3 are CFLs and the last one is not CFL. Is anybody there is not CFL in this? Let me check again. Sometimes I may do mistakes if they don't write. It's okay. M plus P is equal to N plus Q. No problem, right? M is equal to N. P. If they have done any typing mistake here, I'm not responsible, but check it once. So as per the given data, so don't look at the options again as we miss the data. It was solved in the last year gate questions. There also you can see you have the gate PYQ, I guess, too. No? Anybody? Oh, M equal N equal P. This is what happened. The typing mistake happened here. Third one, M is equal to N is equal to P. This is missing. So this will become not CFL. Thanks for that correction. Now this time, which are CFLs? Here M equal N equal P. That makes already this 3 you have to check and this 2 you have to check. So both of them not possible at all. Even 3 of them you can't check. It's a not CFL already. So 192, that's going to be option B. Thanks for identifying. All are DCFLs. I'm saying already. The fourth is not CFL. Not CFL means not DCFL. No? Here we found some typing mistake here. Somebody corrected it already. The complement of language is regular. Complement of language is regular. It is necessary that language is regular. Need not. Yes. If somebody complement is regular, then that has to be regular, right? Because non-regular complement never be regular. Yes or no? Regular complement is regular, non-regular complement is non-regular only. Because they have, by implication relation. If you are talking about L and L complement, if any one of them regular, other definitely regular. Options, did they copy the same 1, 2, 3, 4? Okay, check. In revision session, we will be discussing a lot of closure properties. Now, at this moment, I was assuming that you have the revision on your own, but any of the concepts you are not able to recall, I'll definitely make a different kind of revision this time. PYQs, it's a common thing, so I am not doing anything new in this. But in revision, I'll help you to remember a lot of important and interesting points so that in exam, even though you are not understood some of the concepts, by tricks also you can answer them. You need to go for context free and regular, right? So let's DCFL also concept is there. So look at what is this A power P. It is going to be context sensitive language, even not a CFL, not DCFL, not regular. A power N, B power M, C power 2M. A's you can skip, B's you push, C's you pop the B's. Every 2 C's you can pop 1 B. Otherwise, every B if you push 2 B's, then every C you can pop 1 B. It's in fact DCFL. And this one, all the 3 are depending on the same N. It is not possible even in CFL. And it is DCFL. A power N, B power N. Very popular DCFL. Like A's you push, B's you pop the A's. Which of the following are correct? L1 is context free. It is not correct. L2 is not context free. L2 is actually context free. L3 is not context free but recursive. True. Even it is also context sensitive. L4 is deterministic context free language. That is also true. So 3 and 4 going to be correct. In exam, these things keep on changing. But if these languages are repeating in the future, so don't do any mistake, because you already seeing in the PYQs, now the same questions comes or same languages may come in the future, but these options will change. They might talk about regulars, they may talk about non-regulars, they may talk about CFLs, they may talk about recursive, anything is fine. E5, we have 10 more questions. Okay, I'll do it fast. L1 is a power n, b power n, c power m, right? These two are equal. L2 is b and c are equal. Now, which of the following are context-free languages? When you do the union, CFL union CFL is definitely CFL, right? No issue. But intersection, what happens? When these two are equal, here these two are equal, to satisfy them, you need to say a power n, b power n, c power n, where n greater than 0. This is not CFL, right? It is a context sensitive. So statement 1 only correct, context free language. L1 union L2 is definitely CFL. You have the grammar and just need to identify which is correct. Very easy, no? What is y? Y is equal to a power n, b power n. What is x? X is a plus. And what is your L? L is equal to a plus a power n, b power n. And this concept says that a power I, b power j, and by looking at this, plus always there whether n is there or not. Like n can be 0, but only a is also allowed, right? I greater than, equal, will it happen anytime? Never, right? So I greater than j. Which one is going to match that? I greater than j. M greater than n. This is n greater than j. What is that? N greater than j. Now j can be 0 also, right? This greater than or equal to 0. M greater than n, where n greater than or equal to 0. This C is going to be correct. And I'm just checking, equal never happen here because a is equal to b is impossible because x is always giving more a's. And greater than, you have only two options, that C is going to match. Okay. Now you look at L1, L2, two CFLs. Are we regular? This question came already? No? Okay. Data is similar. Which of the following is correct? Union of two CFLs is a CFL. It's correct. Complement of L1. Context free? False, because need not be context free. CFL complement may or may not be context free. CFL minus regular. What happens? CFL minus regular? CFL intersection regular complement. Regular complement is regular. So CFL intersection regular is always CFL. This is true. And CFL intersection CFL need not be CFL. So only we have the correct statement is 1 and 3. Yeah, closure property kind of question it is. And many of the questions in this chapter depends on the types of languages only. Go ahead. First time I see it, I really misunderstood the data. Data is very easy, but the options, these two options B and C, were confused me a lot because they looks like same, but actually there is a difference between them. Okay, that you will understand slowly. Go ahead. Have we solved this? What is T here? T is equal to B plus, and when look at S, S derives A, B, S, C, B plus, or A, B, C, B plus. And simply what you have, this AB and CB plus will repeat it equal number of times. This one will stop the recursion. What is your language? AB power n, CB plus power n, A, B, C, B plus. This is the right answer, where n greater than or equal to 0. But is it asked as it is? No. And there are two options for you. You know, b plus you can write as b power m, but when you have b plus above somebody, that n is already connected with somebody, you can see that you know cb plus is connected with already, you know, here a with ab. Now this may not be equal to b power m power n when already somebody is having n here. To understand this point, this one, do not put m here. The reason is it is not alone, it's with somebody else. Okay, keep that in mind. Now if you put m, what happens here? M and plus, what is the difference? Here m is fixed outside. If m is 2, then all the n, that the b is going to be like cb power 2, cb power 2, cb power 2. But what is the b plus here? That you can take first time cb, next time cb power 100, next time cb power 3. But that option is impossible here, because all the time m only will be taken for each n. So this is going to be fixed for the n. If n is 100, then all the 100 repetitions, the b power will be fixed. And that's the main difference between the b plus and b power m. So do not assume this is just plus. Here m is not same as the plus. Okay. Now here what you can understand, here ab is there, here cb plus is there. So this one you can write as ab power n plus 1, cb plus power n plus 1. That means instead of writing greater than or equal 0, you can write as ab power n, cb plus power n, where n greater than or equal to 1. How did I do it? This ab, I just did a plus 1, cb plus I did a plus 1, because the same term. And instead of putting greater than or equal 0, that plus 1 I have deleted and I have written n greater than or equal 1. It's the same. If you want to write a 0, what do? You put a plus 1 here. If you want to put a greater than or equal to 1, both are same. Either you put plus 1 here and write greater than or equal 0, or greater than or equal 1, put a plus 1 here. This is your choice. Now this one only is written here, ab power n, cb, it's a m1, m2. m1, m2 means individual variables. So they are same as the cb plus, how many times? N times. See here, m1 to mn means n times. The cb plus is repeated n times. And each plus is written with the variable m1, m2, mn. All m1, m2, mn are greater than or equal to 1. So this is what mentioned here. And the B is right answer. Yeah, we have the revision class. There I will help you how to remember all the closure properties. अभी तो PYQs practice कर रहा है, right? तो जब practice कर रहा है तो why are you worried about how to remember closure properties? All this we'll have in the revision. L1 is very simple, a power n, b power n, where epsilon comes in between, no need to write. L2 is ab whole star. Did they talk about L1, L2? Yes. L1 is regular wrong, L2 is regular correct. Which of the following is true? You need to identify the true only. P is false, Q is true. P is false, Q is true. So you will pick the option C. Oh, this is a very easy. 1 mark will cost you. And this kind of 1 mark question, yes, this is a 1 mark question. And if you're not able to identify, you are so confused, then you have the negative marking, you may leave it. But you are sure that, you know, you identified the difference, you can pick it. And first time you have that kind of questions in the exam. But don't predetermine like 1 mark I will leave, 2 mark I'll do it. You don't know really 2 mark will correct all the time. So give a little bit of effort while reading the question and just fight with the question sometime for a few seconds. You may get an approach quickly. While doing this question, your mind, I've seen a lot of people, right? So they were talking about the previous question, they were talking about the previous doubts, and that's what you need to understand. अगर आप इस क्वेश्चन को प्रैक्टिस कर रहा हो तो आपकी पूरा दिमाग, पूरा फोकस इसी क्वेश्चन पर होना चाहिए और इसमें डेटा जो दिया है आपको याद रखना है while answering the question. तो जो लोग, कुछ बहुत लोग ऐसे जैसे रीड करते हैं यार उनको सब याद रहता है, जब ये याद रहेगा यहाँ अप्लाई करना बहुत इजी होता है. ठीक है, push, push, and for the C's you pop what you have pushed. For A you can push X, for B you can push X, for C you can pop the X. If you see the number of C's is sum of this A's and B's, definitely matches, right? Deterministically you can do it. I'm just writing DCFL. And all the three are actually depending on the same n, but A power 100, B power 100, C power 200, but 100 will decide all the powers. It is not a CFL. If you want, it is context sensitive. And which of the following is true? L1 and L2 are CFL, false. L1 is context free while L2 is not a context free, it is true. L2 is context free, wrong. Even that is also wrong. L1 and L2 both are not context free, this statement is also false. L1 is context free while L2 is not context free. Another PDA question. Again, when you see the PDA, first target is to understand every transition. What is the meaning of this? Push X for what? A. Push X for each A. And this is pop X for the first B. For remaining B's, you are going to pop X. And at the end of the input, the stack is left with only Z. Here, what is the Z? Clearly, you see that mentioned Z is the initial stack symbol like Z0 only. Okay. Instead of Z0, they have mentioned Z. So push X, pop X, pop X. Every B you are going to pop X. And at the end, the stack should have a Z. That means all the X must be popped. Now, to reach there, at least one B. Oh, here is there. Your final state is there. I forgot it. Okay. Now, which of the following is true? Anything is mentioned extra? What is the L is denoted? L is denoted as the language accepted by the PDA. Now L we need to identify. So now we have two finals. Not only there, that is going to accept A power n, B power n, where n greater than 0. This final state. What are the strings they reach? What are the strings will be reached there? A power n, B power n, where n greater than 0. This one, you read any number of A's, that means push X for every A, then you can hold there. That means A star will accept here. So A star union A power n, B power n. Which one is that? A power n, B power n, n greater than 0, perfectly right. It is not accepted by finite automata. But languages, oh, only half of the language mentioned. The A star, they forgot it. Okay. It is not accepted by finite automata, no doubt, but L is not equal to A power n, B power n, but also union with A star is important. Like this is A plus, and please take this n as superscript, A power n, B power n. Okay. So many typing mistakes. Here union should be there. N greater than 0. So epsilon is missing here. Correct? It is even accepted by DPDA. This statement is wrong. Any typing mistakes, please take care of them. A lot of typing mistakes here. L is not accepted by Turing machine. This is DCFL, even DPDA. It's definitely accepted. So all the three false. The fourth one, the A power n, where n greater than 0, you will get A plus here. Union. Here, n greater than or equal to 0 should be there. That was a typing mistake they did here. Here also there, I think. A power n, B power n, union should be here. And this language, A power n, B power n, is, here actually n greater than 0 required, but equal to, why did they keep? Epsilon we are removing from here. So it should cover any one of the place. So epsilon is kept here, it removed from here. So answer is A star union A power n, B power n, where n greater than 0. But this can be written many ways, like A star union A power n, B power n, where n greater than or equal 0 you can write. because epsilon I can also cover here because it's there in the language, and I can write a plus union a power n b power n where n greater than or equals 0. This epsilon already there right side, so no need to put this side. You can say that the L is a plus or a star union a power n b power n where n greater than or equals 0, and it is deterministic context free. D is the right answer. Okay, you have G1 and G2. What is G1 and what is G2? That's all mentioned, right? Can we find out what is B? B is a B plus. What is L here? What is the language here? A star, because this will repeat, and this B you need to substitute. What is the B? B plus. Here L is A star B plus. Here B is equal to B star, and A is equal to is missing while copy paste. This is given as a complicated in the exam, but it was so easy to identify. And or they might be misjudged. And if you look at that, m greater than or equal to 0, not there anywhere. Okay, so please copy the actual gate questions and please do it. No buffer, no? No, fine. So again, the options, please cross check once. I don't find there's a typo here because I don't want to correct them because options were complicated. So I feel how many questions left? Only few questions. Okay, just correct them and choose properly. You already got the answers, right? If the grammar is different, then please correct it. But still, every new question you need to do it properly. So only few questions I'm leaving to you. The one finite beta question. Options are there. Which string you need to keep after this string so that it will accept. So half of the string is given, the remaining half string that you need to attach, and then you should look at in this motion. And other question is identifying the context free, very popular, right? Two questions only I am leaving. In this chapter, the one point that I observed, you need to understand what are CFLs and what are not CFLs. Okay. Second, union, intersection and complement. These three are regularly were asked in the many operations. And closure properties, mostly union, intersection, complement. Remaining we did not see even cleany star, cleany plus, subset. These questions were not there. And many questions. And third type is sometimes they have given PDA identify the language they asked. Recently in the few years this was repeating question. And that's all you see in the entire the topic. We'll take a break and we'll start the Turing motion and undecidability, and we'll see. Definitely in undergraduate level, we may not go for understanding this next topic, but we should answer many questions. That's why decision properties table you require. Very interesting questions are there. We'll see how to solve them. Meanwhile, in case anybody is not in the Telegram group, you can join me here, and LinkedIn you can also join. We'll meet in 15 minutes. Now it's 12:10, so 12:25 a.m. we'll start our session. Okay. Yes. You will get the PDF. Only two questions were left now. Yeah, are we ready? Is it ready? Are we ready here? Go ahead. You see, in 2022, the question was which of the following is undecidable? Like they may ask you decidable or undecidable, and could be many types of questions. And in undecidability, you have, if you could have remembered in revision also, I will do it. Like you remember the order, like halting, membership, emptiness, finiteness, totality, equivalence, disjoint, and set containment. What happens is all of them are decidable for regulars, and from year 2 except last 2 are decidable for DCFLs, and except last 4 and first 4 that we are talking about decidable for CFLs, and the first 2 are decidable for recursive languages including CSLs, and all of them are undecidable for Turing machine or RE languages. And it's very easy to remember, like all are decidable for regulars. It's about regular expression, regular language, finite automata, regular grammar, all of them. And for DCFLs, except last 2, for CFL, except last 4, for recursive, only first 2. And for given 2 Turing machines, whether can we decide if L of M1 is equal to L of M2, it's the equivalence of 2 Turing machines or 2 RELs. This problem is undecidable. Of course, any problem that you talk about here is undecidable for Turing machines. Given TM, and this is not included here, regularity problem. Given TM, is it accepting regular or not? Can you decide? It is also undecidable because TM may accept regular, may accept non-regular. We don't know that. Of course, if you want to design a Turing machine, अगर आपको Turing machine design करना है A star के लिए, you can do it. But यहाँ पर आपको डिजाइन नहीं करना है, मशीन दिया है, इस मशीन ये रेगुलर होता नहीं होता आपको आइडेंटिफाई करना है. ऐसे कोई एल्गोरिथम नहीं है दुनिया में ये ट्यूरिंग मशीन रेगुलर को एक्सेप्ट करेगा, नॉन रेगुलर को एक्सेप्ट करेगा, ये नहीं पता है. तो ये क्वेश्चन ऐसे वाली है, फॉर अ गिवन ट्यूरिंग मशीन कैन यू डिसाइड इज इट डूइंग रेगुलर और नॉन रेगुलर. ये नॉन ट्रिवियल प्रॉपर्टी है. राइस थ्योरम अप्लीकेबल अप्लाई कर सकते हैं आप. अगर आप सेमेस्टर पढ़ लिया ये पता होगा आपको. ये राइस थ्योरम बोलता है एनी नॉन ट्रिवियल प्रॉपर्टी इज अनडिसाइडेबल. ये नॉन ट्रिवियल प्रॉपर्टी है. वेदर m accepts regular or not is a non trivial property is always undecidable. then ट्रिवियल क्या होता है? अगर यही क्वेश्चन रेगुलर की जगह रेगुलर की रिप्लेसमेंट में रिकर्सिवली एन्यूमरेबल पूछा है, आपको पता है दुनिया में एवरी ट्यूरिंग मशीन इज डूइंग रिकर्सिवली एन्यूमरेबल, वो ट्रिवियल होता है. उनके लिए एल्गोरिथम बहुत इजी है. Don't say all problems related to Turing machine is undecidable, only these problems, all these problems, okay. But trivial problems होता है वो decidable होता है. जैसे Turing machine के अंदर 10 states है नहीं, वो तो decide कर सकते हैं हम. ट्यूरिंग मशीन्स के अंदर कितने ट्रांजिशन है, 10 ट्रांजिशन है नहीं, ये वो भी डिसाइड कर सकते हैं। गिवन ट्यूरिंग मशीन डिसाइड इफ m एक्सेप्ट्स ऑल स्ट्रिंग, ये तो टोटालिटी प्रॉब्लम है, ये भी यहां का है अनडिसाइडेबल। और यूनिवर्सलिटी, अनदर नेम इज totality, universality, is it accepting everything, is also undecidable. So far all the three are undecidable. Let's go for D. For a given Turing machine, M decides if M takes more than 1073 steps on every string. What is the meaning of this? यहाँ पर बहुत लोग ये सोचते हैं यार एवरी स्ट्रिंग पर 1073 से ज्यादा लेना है, मोर देन 1073, तो आप एवरी स्ट्रिंग वेरीफाई नहीं करोगे, तो व्हाट विल यू डू, यू आर गोइंग टू चेक अप टू, अगर आपको मोर देन 1073 जाना है तो 1073 लेंथ तक वेरीफाई करना, कितने स्ट्रिंग्स होगा, अप टू 1073 लेंथ स्ट्रिंग्स, फाइनाइट नंबर ऑफ स्ट्रिंग्स होगा ओवर एनी सिग्मा, और यहां पर एवरी स्ट्रिंग इज टेकिंग मोर देन 1073 लेंथ, इसका मतलब इसके बाद भी उससे ज्यादा ही होगा, राइट। ये प्रीफिक्स कॉन्सेप्ट प्रॉपर्टी है, ये सारे प्रीफिक्स होगा मोर देन 1073 लेंथ के लिए। तो ये क्वेश्चन है, ये देखो ट्रिवियल नॉन ट्रिवियल कॉन्सेप्ट नहीं है, ये प्रॉब्लम ऐसे है, you no need to verify every string but you can decide is anybody halts within 1073, ये क्वेश्चन है। instead of verifying every string will take 1074th step, we are verifying is there anybody taking less than or equal to 1073 steps, and don't verify every string, not required, up to 1073 length only। तो इसके बाद जो भी स्ट्रिंग होगा इन ये 1073 प्रीफिक्स होता है उसके लिए भी, है ना। राइट, तो ये है डिसाइडेबल, तो ये काफी इंपॉर्टेंट है, ये रिपीट हो रहा है कॉन्सेप्ट एग्जाम में। यहां पर अप टू 1073 लेंथ स्ट्रिंग्स वेरीफाई करोगे इफ every string every string in this length, if every string takes 1074th step, that means remaining more than 1073 length also will take, because they also follows the 1073, definitely after that some more length will be added. If some string halts, if it is not going to take, if some string halts from this strings only, not sigma star, only from this strings, if some string halts in less than 1074 step, that means less than or equal to 1073, then definitely you will say no. So this is for S, means everybody will take a more than 1073 step. No means somebody halting in less than or equal to 1073 step. Okay, so this is what SI no concept for this problem. Both are having logic, just you need to look at total strings up to 1073 length, and answer is A, B, C. These three problems are undecidable. But here every question may take a lot of time to analyze, so do that. Don't blindly answer it's a decidable, undecidable. Some of the questions we need to analyze. Which of the following statements are true? True only you need to identify now. You know, subset property definitely is not closed for many languages, but the subset of regular non-regular हो सकता, subset of CFL not CFL भी हो सकता, subset of recursive not recursive भी हो सकता. यहाँ पर every subset of recursively enumerable, can you guarantee it is recursive? या सबसेट ऑफ REL नॉट रिकर्सिव भी हो सकता है ना, क्यों REL के अंदर बहुत सारे प्रॉपर्टीज है, इवन REL के अंदर सबसेट नॉट REL भी हो सकता है. ये इंपॉर्टेंट है, एवरी सबसेट, सम सबसेट ठीक है, बट एवरी सबसेट ऑफ REL इज रिकर्सिव इज रॉन्ग. और यू कैन से सम सबसेट ऑफ REL is recursive, that can be allowed, correct? So this is a false statement. If a language and its complement are both REL, then L must be recursive. This is true. The reason is L is REL and its complement, that's L complement, is REL. It means valid of L will have a logic. Here valid of L complement will have logic. So valid of L complement means this valid of L become invalid of L, both are having logic. So valid of L, invalid of L is nothing but valid of L complement. So valid of L, invalid of L, both are having a logic, which means recursive. And this is the true statement. If it is MCQ, we got the answer, but it is MSQ, we'll look at. Complement of context free must be recursive. A CFL complement, we know it is need not be CFL, but always context sensitive language. Because in context sensitive language, the complement property is closed. This CFL is definitely CSL. So its complement, you can always prove it is context sensitive language. So we can say must be recursive. Every CSL is also recursive. So it is a true statement. So we need to pick the true statement. So far BC. If L1 and L2 are regular, then intersection of those two regular must be regular, we know. So we can pick deterministic context free also. It is true. So B, C, D are correct. Actually, intersection of two regulars is regular only. But instead of regular, they said deterministic context free. You can say regular is deterministic context free. Must be, we know regular. Every regular is deterministic context free. So it is one direction. Right. And for most of the people, they don't understand what is the language also. They don't know where to look at. So that's the one problem. Second, even though they understand, they don't know how to interpret them. The many problems happens because of, must is written. It is must be, right? L1 intersection we know must be regular. If it is must be regular, then it is must be DCFL only now. What is the problem with the must? There is no problem. Intersection of two regulars must be regular. If they are must be regular, there must be DCFL too. Direction. We are not saying DCFL is regular. We are saying regular is DCFL. That's correct. If you are in Delhi, I can damn sure I can say that you are in India. Correct? That's what happening. If it is already regular, you know it, then I can say it is always DCFL. Go ahead. Which of the following languages are not recursive? Means undecidable only. Right? Not decidable, undecidable, all are same now. The word not recursive means not decidable, means undecidable. this language is nothing but collection of DFAs, where you need to understand that DFA, is it or its language empty or not. It's emptiness problem for a DFA. You know, emptiness for regular languages, it's decidable, right? It is recursive, or you can say decidable. And this is a DFA. Totality problem for regular languages is also decidable. And it is a PDA, emptiness problem. M is a PDA here. So language accepted by PDA is empty or not. That is emptiness for PDA. You can use the simplification of context-free grammar concept. It is also recursive. You can call it decidable. And M is a PDA such that the L of M is equal to sigma star is totality. Totality equivalence problems are undecidable for PDA. It is a not recursive. That means verify that PDA accepting every string, we don't have any algorithm, right? Particular string we can verify using CYK membership algorithm, but every string in the world is accepted or not, that we can't verify in a PDA. So it's undecidable. This is only MSQ if I ask which of the following languages is or are recursive. If I delete this not, then answer will be ABC. You see that MSQs may be tough, but if you understand how do they ask, then it will become easy. Actually, no, will not come, but you should know about CYK. It's a membership algorithm, uses bottom-up parsing concept, dynamic programming concept is used in it. Because one time it was asked, it takes order of n cube time. Yes, it takes order of n cube because of dynamic programming concept. अगर आप डाउट पूछा है तो डेफिनेटली आई डिस्कस इट. अगर डाउट ही नहीं पूछ रहा है तो मैं क्या करूं? एंड स्पेशली क्वेश्चन शुड बी प्रैक्टिस्ड इन इंग्लिश. अगर आपको कॉन्सेप्ट समझना है तो दैट शुड बी इन योर लैंग्वेज. तो ये मेरा प्रिंसिपल है, इसलिए मैं क्वेश्चन हमेशा इंग्लिश में डिस्कस करता हूँ ताकि आपको फ्लो समझ में आए. गेट एग्जाम में आपको इंग्लिश ही इंटरप्रेट करना है तो वहाँ कोई बताएगा नहीं आपको हिंदी में कैसे कन्वर्ट करें. अगर यहाँ पर भी हिंदी में आप सॉल्व कर रहा है देन डेफिनेटली यू विल सफर इन एक्चुअल गेट एग्जाम. द रीजन इज नोबडी देयर टू हेल्प यू इन इंग्लिश, है ना. तो मेरा रिक्वेस्ट ये है, प्लीज सॉल्व ऑल द क्वेश्चंस इन इंग्लिश एंड इंटरप्रेट इन इंग्लिश एंड ट्राई टू अंडरस्टैंड इंग्लिश. कॉन्सेप्ट तो ठीक है, रिविजन भी ठीक है, समझने के लिए वो तो हिंदी में, इंग्लिश में और कोई भी लैंग्वेजेस में चलेगा, बट क्वेश्चंस को जो है आपकी स्टैंडर्ड पैटर्न जो है इंग्लिश में रहता है ना. इसलिए मैं कभी भी क्वेश्चंस को प्रैक्टिस करता हूँ मोस्टली फोकसिंग ऑन इंग्लिश ताकि आपको फ्लो समझ में आए, है ना अभिषेक. अगर आपको किसी क्वेश्चन में डाउट लग रहा है देन यू कैन आस्क द डाउट, सर इस क्वेश्चन का एक्सप्लेनेशन जो है तो हिंदी में कर दीजिए. चलिए, अब have you done this problem? Which of the following languages are undecidable? क्वेश्चन ऐसे ही होता मोस्टली, डिसाइडेबल अनडिसाइडेबल. नोट दैट इंडिकेट्स इनकोडिंग ऑफ टीएम. सो आपको एम को एनकोड करना है. सेट ये तो एनकोडिंग है. कलेक्ट ऑल द मशीन्स. हियर एम इज ट्यूरिंग मशीन, राइट. कलेक्ट ऑल द ट्यूरिंग मशीन्स, देयर लैंग्वेजेस आर एम्प्टी. तो एम्प्टी लैंग्वेज जो होता है दुनिया में वो सबको इधर रखना है. जो नॉन एम्प्टी होता है इसके कॉम्प्लीमेंट में रहेगा. So this is nothing but set of all Turing machines which are accepting empty language. ये क्या होता है? ये ट्रिपलेट है. इसमें ये ट्यूरिंग मशीन है और W इनपुट है, Q स्टेट है. ये तीनों आपकी इनपुट में रहेगा और जो ट्रिपलेट में आपको ये कंडीशन सेटिस्फाई होता है वो इस लैंग्वेज के अंदर रहेगा, जो सेटिस्फाई नहीं होता इसकी कॉम्प्लीमेंट में रहेगा। ये क्या है? गिवन ट्यूरिंग मशीन ऑन W रीचेस स्टेट क्यू इन एग्जैक्टली 100 स्टेप्स। तो 100 स्टेप्स के बाद तो कभी नहीं जाओगे, तो ये फाइनाइट अमाउंट ऑफ टाइम में डिसाइड होता है। तो ये प्रॉब्लम जो है कॉन्सेप्ट ही डिसाइडेबल है, क्यों आपको एग्जैक्टली 100 स्टेप्स, लेस देन और इक्वल 100 स्टेप्स, लेस देन और इक्वल टू 20-23 मूव्स, all of them are possible in the world, right? समझना पहले। एंड लैंग्वेज एक्सेप्ट बाय टीएम इज नॉट रिकर्सिव, ये तो नॉन ट्रिवियल प्रॉपर्टी है। क्यों? सम ट्यूरिंग मशीन्स एक्सेप्ट रिकर्सिव लैंग्वेजेस, सम ट्यूरिंग मशीन्स एक्सेप्ट नॉट रिकर्सिव। तो which ट्यूरिंग मशीन्स यू विल कीप हियर? दे आर एक्सेप्टिंग नॉट रिकर्सिव, बट आइडेंटिफाई कैसे करोगे वो नहीं पता, इसलिए ये प्रॉब्लम अनडिसाइडेबल होता है। और लैंग्वेज एक्सेप्ट बाय ट्यूरिंग मशीन कंटेन्स एटलीस्ट 21 मेंबर्स। यहाँ पर देखो इसके लिए भी इसके लिए लॉजिक होगा कि 21 स्ट्रिंग्स को आइडेंटिफाई करना इजी है एटलीस्ट, राइट? तो बट इन केस ये एटलीस्ट 21 मेंबर्स को एक्सेप्ट नहीं कर रहा है, देन यू डोंट नो, सपोज ओनली 3 स्ट्रिंग्स आर एक्सेप्टेड, so you don't know how to say that 3 strings also, because you need to verify all the strings in the sigma star. इसमें क्या क्या प्रॉब्लम्स undecidable है? emptiness is undecidable, and second one is decidable, and L3 non-trivial property is undecidable, and L4 is undecidable but partially decidable. If you want to identify this L4 you can do, but L4 complement you can't have a logic. That's why all the 3 are undecidable, but L4 is partially decidable. They did not talk about is it partially decidable or not. Okay, so L1, L3, L4 are undecidable. Then see, the question has nothing to do, very easy. Only the problem is how do you interpret this data? Set of all RELs over the alphabet 0, 1, and it's about countable, uncountable. So you should know what is countable and uncountable. This is derived, this definition is derived from mathematics. If anybody want to say countable, the definition of countable language or countable set, you should prove that X is mapping with known bijective function, known countable set. Known countable set forms bijective. Remember, if I want to say X is countable, you should show a bijective relationship with some known countable set. Then this will become the unknown X is also countable. Okay. The set of all RELs over alphabet is countable because every REL you can map with a TM that is going to be countable. Set of all syntactically valid C programs. Every syntax will represent a program, but anyhow, the set of all C programs which are syntactically valid also countable. Set of all languages. They did not say what kind of languages. If they say regular languages countable, if they say finite languages, if they say DCFLs, if they say CFLs, if they say any type of language that you take, especially up to REL, all are countable. But when you mention set of all languages is equal to 2 power the sigma star, where sigma is 0, 1. This is going to be uncountable. But remember, set of all regulars countable. Set of all non-regulars also uncountable, because non-regular you may not have a logic to map sometimes, correct? Uncountable language also can come here. Uncountable. And which of them are uncountable? S3 and S4. Here S1 and S2 are countable. Set of all valid C programs which are syntactically correct. Set of all REL, set of all recursive, set of all CSL, set of all CFL, set of all regulars, right? All of them are countable. Set of all RELs abhi to aaya, just now asked, right? 2019 it's there, but before that 2018 this line was there. The same thing is given in the 2019 again. Okay, so there is a repetition in this chapter especially. To solve all the PYQs, the set of all RE is countable. If anybody not aware, that's why you have a special class for each one, right? But don't say set of all not RELs, set of all not regular, set of all not CFLs. That is uncountable. And also set of all languages is also uncountable. And set of all RELs is MCQ type, only one is correct here. You can see closed under complementation is wrong because RELs are not closed under complementation. Closed under intersection definitely, because union also closed. A subset of the set of all recursive languages. The set of all RELs is the bigger one, right? And recursive is this much only. And now here this box is inside this box. How can that happen, right? It's a superset basically. This is the wrong line. And it is already countable set, we can't call uncountable set. So only the right one is closed under intersection, closed under union. Right. I'll give a time to analyze. Anyone? Okay, let me analyze it. Now consider the following problems. L of G denotes the language generated by grammar G. L of M denotes language accepted by machine M. For unrestricted grammar, there is a recursively enumerable grammar and a string W, whether W belongs to L of G, is definitely a membership problem for a Turing machine, right? Or RELs. The membership problem for RELs is undecidable. So let me write is UD. Second one, given a TM, whether L of M is regular, it is a non-trivial property, is also undecidable. Whether given Turing machine accepts regular, whether given Turing machine accepts CFL, whether given Turing machine accepts finite language, whether given Turing machine accepts only one string. All these problems are non-trivial problems. Given two grammars, name is not given. They are just is mentioned L of G1 equal L of G2. It's equivalence problem for Turing machine or equivalence problem for two RELs, right? So because two grammars can be in general unrestricted only. It is again undecidable. Given NFA, whether there is a DPDA such that N and P are accepting the same language, because every NFA in the world can convert into DPDA. How? NFA you can convert to DFA, DFA you can convert to DPDA. It's very easy to do the process. If you ask me, sir, how you do it? See, if you have this is NFA. I'm just helping you. Assume that this is NFA, you have it. Now, NFA we will do some other way, right? It's a concept of what? The A star. Now, this one will convert to first DFA. It's a DFA for it. And DPD, how do you convert it? Very simple. A comma Z0 slash Z0. Just you write in every DFA, you can add additionally 2 parameters Z0 slash Z0 after every input symbol. Then that will looks like a DPD only. Now, it's easy to convert every NFA into DPDA. That means for every NFA, you will have the DPDA existence. So this is decidable. Which one of the following statements correct? 1 and 2 are which one only? MCQ, right? MCQ means you have to choose only one. 1 and 2 are undecidable. 3 is undecidable. Only word is there. I'm sorry, I'm not reading it. Only 1 and 2 are undecidable. Wrong, right? 3 also there. Only 3 is undecidable. 1 and 2 is there. That's why this statement is false. The only is not there, right? It will become MSQ. Understand again, if this only word is not there, then this 2 could have been correct. Okay. Only 2 and 4 are undecidable. That is also wrong. Only 1, 2 and 3. 1, 2 and 3 are undecidable. The last is correct. And it's easy to make MSQ. If I delete only, then many options could have been correct. Similar to that question, can you try it? L of R be the language represented by regular expression. L of G be the language generated by context-free grammar. Here G is the context-free grammar, R is the regular expression. L of M be the language accepted by Turing machine. M is a Turing machine. Which of the following decision problems are undecidable? Given a regular expression and a string W, W belongs to L of R, means it's a membership problem for the regular languages. Membership problem for regular languages is decidable. The question is, we need undecidable. This is decidable. And 2, given a CFG, language generated by context-free grammar is empty. That means it's emptiness problem. How can you solve it? Take the context-free grammar, simplify it. If you left with any one production, it generates non-empty. If all these productions are deleted, means all are useless productions, it generates empty language. The emptiness problem for CFLs is decidable. And is a given CFL sigma star, that is given PD accepts every string, totality problem is undecidable for CFLs. Given Turing machine and given string, now we should verify the membership property. Membership property is also undecidable for Turing machine. So 3 and 4 are undecidable here, remaining 2 decidable. Again, D is the right. Most of the times the questions repeats, like the standard problems like membership, emptiness, finiteness, totality. Have you seen, right? Totalities keep on repeating. Into yeah, you can use which, this one or previous one? In previous one, 2, yeah, Rice theorem you can apply. Rice theorem says that any non-trivial property is undecidable. How do you know it is non-trivial property? Look at, if I give you M, if all the Turing machines in the world they are doing regular, then it's not a non-trivial, right? Non-trivial means some does it, some will not do it. Like whether given Turing machine accepts a regular, how do you know it accepts regular or not? We don't know. So some Turing machines will accept regular, some Turing machines accept not regular. So this kind of property will create a non-trivial. Over. This is completed, no? Go ahead. Totality means universality. Let me write that first. Many problems are there. one problem is totality. If you are applying for Turing motion, it's nothing but is language accepted by TM equal to sigma star. It means is TM accepts everything or every string. That's nothing but totality you are talking about. With a given TM accepts every string, this question is called as totality. In simple terminology, M accepts sigma star. This is the problem name. M accepts every string. This is a problem name. P is a problem that M accepts every string. S means M accepts every string. No means M might reject one string at least. A reject, or what do you say, it may go to loop also. And this is what totality problem talks about. Okay. So should I stop here because no interaction? You can practice on your own. Will you practice here onwards? This question was already solved in the PYQs in case if you want to access, but if you want to now, please interact. Please. Okay, let's understand line by line. Okay. What is the first line? Let A and B finite alphabets, just like a sigma 1, sigma 2, correct? And hash is a symbol which is not there in A and B. So it's another symbol extra, but not there in sigma, but you are taking as a symbol only. F be a total function from A star to B star. What is the total function concept? F is a function from A star to B star. Total function means for every element in this domain will have a mapping. So for everybody you will see the mapping. Right. Partial function means some of them you may not have a mapping to. Right. So it is a total function, like every string you know what it computes, just like the halting Turing motion. Every string it halts clearly. That means every string it has a logic. Same way here every string the function is well defined. So we say that f is computable if there exists a TM, which is definition also given. What do you mean by computable? Okay, input x in A star. So for every x in A star, there exists a TM, means you have a logic for every string in A star. Okay. Always also with f of x on its tape. If you want to understand clearly, if you take f here, and it goes to f or what, x, right? Sorry, if you take x here, it also with f of x. So understand, x belongs to A star, f of x belongs to B star. Every x in A star, you will have some f of x in B star. That's the meaning of total function. For all x belongs to A star, you will have f of x belongs to B star. Now the new concept is, let LF denote the language. That language is mentioned here, x hash f of x, where x belongs to A star. That language also I'll note here. What is that language? X hash f of x, that x belongs to A star. Which of the following statements is true? So understand what is A star, what is B star. They are sigma simply. Now the new language is framed with the help of those A star and B star sets. The new member of the language is x hash f of x. X is taken from A star, f of x is taken from B star, and in between hash is added to you. Now f is computable if and only if LF is recursive. What it means? If f is computable, then LF is recursive. If LF is recursive, then f is computable. So you have to prove this way. Is this correct or not? First we'll check. Suppose here two statements you have to prove. The one statement is f is computable if f is computable. We have to prove LF is recursive. Second statement is, if LF is recursive, then you have to prove f is computable. First one, if f is computable, can you collect all the members of L? Like this A star, right? It's A star is always computable, countable, computable, because a regular language, right? So I will pick every string in lexicographical order, and I always get f of x. So every x I will get f of x because it's a computable function, and I'll just take x and f of x and put hash, and I'll collect the language. So if f is computable, the first point, I can find L. How? x1 hash f of x1, comma x2 I'll pick from A star hash f of x2. It will compute because f is there for you as f is computable, and every x in A star I can do this. Now I'm able to enumerate lexicographically, so this is also recursive. Now when you have this second point, when you have this, can you prove that f is computable? This is given to you. It's a recursive, right? Recursive means it's a lexicographically enumerable. And now using this knowledge, what you can do, f you have to prove that it is computable. How? Put x1 here, and definitely it maps to f of x1, and put x2 here, and definitely it maps to f of x2, because every element of domain you are able to find the well-defined function in codomain, and using this L I can find f that is also computable. So now this is the valid statement, and you need to identify the true. Now we look at others, why they fail. If f is computable, then I can call it as LF is REL. First line will satisfy. The first point is, if f is computable, then LF you have to prove RE, because already we proved LF is recursive, so definitely this holds. Here the two holds, no doubt. Second point, if LF is RE, we cannot guarantee that f is computable. This statement is going to fail. The reason is, there's no guarantee. Whenever LF is REL, there's no guarantee that you get it is lexicographical order, okay, and no guarantee every x you have the computation in the codomain. So the second statement, we cannot guarantee Whenever LF is real, this F may or may not be computable, because F can be even partially recursive function, and that's why B will fail, A is true. And C, if F is computable, then LF is recursive, but not conversely. But we know already conversely true, so this statement we don't choose. And last one, F is computable, then definitely LF is RE, but not conversely. Conversely, LF is REL, we cannot guarantee F is computable. This statement is also right, but most of them don't know, so only they are assuming that A is the correct. So here A and D are true statements. Right. And obviously in this chapter, the every word is going to be important. The representation of the problem, first understand what is given to you and what are they talking about. What do you mean by computable? What do you mean by A star? What do you mean by B star? What do you mean by X? What do you mean by F of X? Every terminology you need to understand. Okay. This D, that's what happened here, right? This is only I'm saying, if F is computable, then LF is RE, that's true, but not conversely. Yes, this is a converse statement. If LF is REL, F need not be computable. So this statement only given here, right? The understanding of this 1 and 2. Halting problem for Turing machine is undecidable. Halting problem for a halting Turing machine is decidable. Okay. Fine. For every NTM, there exists equivalent DTM. We know DTM, NTM are equivalent. So every DTM, every NTM, you can find DTM, because you have an algorithm from NTM to DTM conversion similar to NFA to DFA algorithm. So it's a true statement, but we need false only. Turing recognizable language. Recognizable means RE. Remember that RE languages. RE are closed under union and complementation. Union is right, but complementation is not closed. This statement is false. Turing decidable languages means recursive languages only. Recursive languages, simply decidable languages, are closed under intersection and complementation. Yes, true. It is closed under union, intersection, complementation. Turing recognizable languages means RE languages are closed under union as well as intersection. It is also true. So which is a false? Only 2. Who is halting on tape? Yeah. Ask me the whole data properly. Another interesting question for you. This was repeating question in many years. Like what do they write? Now in 2025 they say 2025, 2026 if they are going to ask, they'll say 2026. And in future if they are asking, then they'll change the number, but it's almost same as the PYQ. M takes at least 2016 steps on some input. On some input, if it is taking 2016 steps, then definitely for some string it will halt in less than or equal 2016 steps. If it is nobody taking, then every string will take 2017 step up to, you can verify 2015 length strings. And these two problems will depend on the same logic. M takes at least 2016 steps on all inputs. We have practiced the same question here. If you see in the beginning, first question itself, we did that. Here, if you look at this same question, M takes more than it means at least 1074 steps on every string. Exactly same question which is repeated here, but with a different number. It is asked in 2022 and that is asked in old gate. You see that? Same question. And these two problems are decidable, and it is a membership problem. Membership problem is undecidable. M accepts A, M accepts epsilon, M accepts A, B. They're all membership problems. Right? No guarantee whether the given M accepts epsilon or not. Right? If it is accepting, it will alternate final. If it is not accepting, it will go to infinite loop, or it may alternate non-final. So whether given M accepts epsilon or not is undecidable problem, but partially decidable because S you will have a logic. And L1, L2 are recursive, but L3 is not recursive. And it is one of the important question, and many times these languages will repeat here and there. Consider the following types of languages: L1, L2, L3, L4, regular, CFL, recursive, REL. Which of the following are true? Regular complement union recursively enumerable. Regular complement is regular. Sorry, ये recursive है ना? Recursive complement is recursive union REL. Recursive union REL is REL. This is true. L2 is CFL. CFL union recursive. Definitely recursive. So true. L1 star, regular clean star is regular. Regular union CFL. Regular union CFL is always CFL, but may or may not be regular. Okay. L1 is regular. Complement of CFL is, you can guarantee CSL. C2 complement. So regular union CSL need not be context free. So this is false. And we need to choose the true or false. What did they mention? So choose the which of the following is true. 1, 2, 3 are true. Please don't practice. Now it is out of syllabus. Many people may not be aware. But if you are going for the ISRO exam or other exams, maybe you can study, as they may ask complexity theory. This question is from complexity theory. Now in this GATE syllabus, the complexity theory is not there. Okay, but it will help you if you study like in algorithms and in TOC. It will help you in advanced topics. I'm not talking about, there is a relationship between recursive languages, that's a decidable languages, RE languages, CSLs, P, NP, all are having relation somehow. Even it's out of syllabus now right now, and don't practice. When you are going for old PYQs, you should know which is in syllabus, which is not in syllabus. Okay. In future, if they include again, I'll start solving it. But now you can save the time by avoiding these questions. Go ahead. For any two languages, L1 and L2, that L1 is CFL, L2 is REL, but not recursive. L1 is CFL, L2 is RE, but not recursive. You can also call SDUD. SD means RE, UD means not recursive. The short form of this one is RE, you can call SD, not recursive, you can call UD. So SD but UD, you can call SDUD, short form. Which of the following necessarily true? When you take complement of L1, you will get recursive. It's true. If you know RE but not recursive complement, always not RE. because here logic exists for only valid strings. Invalid, we don't have a logic. So when you do the complement, the invalid become valid, valid will not have a logic. When you don't have the logic for valid, then that is not RE problem. So complement of L2, here recursive is wrong. Instead of recursive, if they give not RE, then definitely L2 complement is not RE right statement, but it is mentioned recursive. L1 is context free. Why did they mention L1 is context free? It's already context free, right? Sentence. Something is missing. Okay, that's L1. What? Okay, 3. I'm not able to understand. Because L1 is already given, so I don't think they will give like that. So some expression is missing here. Put a question mark and solve it by using actual gate question. Okay. L1 complement, that is CFL complement is CSL, union SDUD. CSL and SDUD both are REL, right? CSL is also REL, SDUD is also REL, and REL union REL is REL. It is true statement. Now I'm not able to understand 3. There's some missing expression is there. So 1 and 4 definitely, and of course 3 statements are not there. So I'm ignoring that. 1 and 4 I'm taking. The reason is the 1, 3, 4 is not there. That's why I'm going for 1 and 4, because 1 is already right, 4 is already right. So 3 statements are not given, any one of them. So please correct this statement. It's actually not there. Something else should be here. L1 complement already given here, right? Okay. L1 complement is CFL, then that's fine. If L1 complement is CFL, this is also false. If L1 complement is there, this is also false. M is a Turing machine that accepts a string of 2014 length. See, whether it's length, particular string is given, or any particular length is given. So how many strings are there in 2014 length? Finite number of strings. And now S means it accepts, no means it not accepts, right? It accepts some string. Which length? Of length some k, 2014. In future they'll ask 2026. No means it not accepts of any 2014 length. Can you understand? Not accept means every string you may go to infinite loop. So saying answer no is difficult. But S is, if anybody accepts 2014 length, then definitely TM will alt at final. And you can run, you can copy the TM. Let's say you have 1 lakh strings, then 1 lakh TMs I will copy, because same TM I'll copy 1 lakh times, and each TM I'll apply 1 string. If any one of the TM halts at final, then I'll stop it, I'll say yes. Okay. It's easy to understand S logic, but no, we don't have a logic. So S has a logic, no is not having a logic. So it's undecidable but semi-decidable. It is undecidable but semi-decidable. Which one will say not semi-decidable? Not RE problem. So we call it as RE but not recursive problem. Which one will say decidable? Which is having logic for both yes and no. Reducibility concept. In 2014 they were asked, and later on they ignored it. But if it comes, because complex theory is not there, so maybe they have removed or not, I don't know. But you should keep reading it. Very easy concept. If let A is reducible to B, notes language A is mapping reducible to language B, which one of the following is false? If A is reducible to B, it means A is smaller problem, or B might be bigger problem, could be equal problems also. B is recursive. If B is recursive, it's just like a project. If B is recursive, then A is also recursive. It is true. If A is undecidable, if A is not having alting program, B will not having alting program too. It's true. If B is REL, if B has a Turing machine, then A definitely will have Turing machine, because we are talking about only the concept of the program. It is also true if B is not RE, if this is not RE, then A may be RE, A may not be RE. The reason is other modules may decide the answer. If B is not RE, then don't say A is not RE, because A may or may not be not RE. And this is only the false statement we have here. When it comes to countability, is again another question on countability. Here sigma is countable, sigma star is countable, and 2 power sigma star is set of, see, this is set of symbols. Set of symbols always finite language, no? Set of strings, infinite language but regular, so countable. And this is set of languages, set of all sets, set of languages. This is uncountable. And which of the following is true for given sigma? Sigma star is countable, but 2 power sigma star is not countable. Here 2 power sigma star is not countable, but sigma star is countable. That's true. Oh, this uncountable is given, so both are wrong. 2 power sigma star is uncountable, correct. Sigma star is countable. This statement is right. And you are saying both are uncountable, but sigma star is countable. And normally why? Very simple thing. Sigma star, it's an infinite language, but it is regular. Okay. Every regular language is countable. Not only every regular, set of all regulars also countable. And now just map it with known problems. There's an emptiness for CFLs. You should know how many ways you can write that emptiness for CFLs or PDAs. The totality for CFLs. And this is just now repeated question, right? Non-trivial property. How many times it is repeated? 2 or 3 times. It is non-trivial property is undecidable, and A is the DFA, N is the DFA, and their languages are equal, means it's an equivalence problem for regular languages, which is undecidable. Totality is undecidable for CFLs, and non-trivial property for Turing machines is undecidable, remaining are decidable. So 2 and 3 are undecidable here. And look at that, the concept is keep on repeating this kind of concept, already repeated. See, whether given M is accepting regular or not is already repeated in previous questions. And I've also said that given M, is it accepting regular, is it accepting non-regular, is it accepting CFL, is it accepting DCFL, is it accepting recursive, all are non-trivial. Who are trivial? Given TM, is it accepting recursively enumerable? That's a trivial problem. Is it accepting not REL? Because always accepts REL. Now if anybody asks, is it accepting not REL? Then definitely you say no. That means always no. That is the reason it is trivial problem. Okay. Thank you so much for joining today's session. And yeah, just practice the PYQs. You will feel the same in most of the times. And in case if you have any doubt, I'm there for you to help you before winding up. And these PDFs will be shared to you. And only 2 questions from the second chapter were not solved. It is important to solve the PYQs because I don't think you will understand in one flow, right? If you are going only one time, there is a lot to understand. See, I have to read the data even though I have solved hundreds of times. Still, I need to solve it. The reason is interpret the data and apply the concept and get the answer. But don't try to remember. You remember theoretical concepts if required. First, stop giving wrong answer. When you don't understand, keep that in mind. Agar, in case if you are not able to understand the data, then why are you attempting the question? Stop doing it. Out of 65 questions, assume that 5 questions you did not understand. Leave it. Because of that, you are in safe side. Your accuracy will improve. You will not do any mistakes. Then you will get more confidence and more marks. Please don't attempt when you are not able to understand. Okay. In case if you are having any doubts, you can join the Connect platform at GFG and we'll have more discussion there. If you want to ask more doubts, I'm always there in Telegram groups here and there. You can tag me. In free time, I will try to discuss with you. Okay. Thank you so much for joining. कोई भी आपको और ज़रूरत है, please connect with me. I will definitely help you regarding your preparation. But meanwhile, I'm occupied a little bit like this session and other sessions. And in case if you want any kind of help, you can ping me. I'll be there to help you. Okay. Yes, I'll be coming for more classes too. Thank you. See you. All the best. We'll meet again on compile design. I think after tomorrow. That's on Tuesday. We'll have the compiler design PYQ series. We'll meet there. Thank you. Bye bye.